Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So, guys, am I properly audible and visible to all of you? Yes, guys. So, today is the second part when we are going to complete theory of machines and vibrations. Okay? Yes. So, Bhomik, Ganesh, Jyoti Prakash, good morning once again. Yes. So, guys, today we will be completing Tom and vibrations. Okay, so as you know, we have started Tom and we have discussed simple mechanism, velocity and acceleration analysis. We have done it. We have done kinematic and dynamic analysis of single slider crank mechanism. We also have done flywheels. So up to flywheels we have already done it. Now my dear, as this is a fresh session, so I do not want it to start from a topic which is in between. So that's why today we will be starting with the vibrations, and after vibrations then we will go to governors, cams, balancing and gears and gyroscopes. Okay, and as in the machine design we completed the session by 5 p.m. today also we have the same target. We will be going like that only. Okay, uh, Ajay, good morning bhai. Vineet, good morning. And as I already told you that tomorrow on Sunday we have a complete machine design CTQ marathon, as you guys asked me to take all the types of problems. So for that I have kept that session, and if you will like that session we will keep the same session for production also, for Tom also, and for engineering mechanics also. Okay, so now it's time to start the session, guys. Yes, Malesh, good morning. Yes, same to you, Vineet. Happy Uttarayan to you also. So we are starting, guys. So guys, this is some detail about me, and you know today's subject is related to theory of machines. Moving further. So guys, this is some information that All India Open Mega Mock Test for GATE 2023 on 10th to 16th January. These are the dates in between. You can definitely attend the test, and then you will get the video solution also on the BYJU'S Exam Prep app. This is about the workshop which is on 15th of January. This is for those students who are looking for GATE 2024 preparations. So 7 Success Mantra Mega Workshop by Abhinav Negi sir at 12:30 p.m. Okay. So if you are preparing for 24, this may be very important thing for you. Yes, sure, Malesh. Aditya, good morning, bhai. Varun, good morning. Good morning to all of you once again. So we are starting, guys, now. So just like and share the session so that other student can also reach to this. So guys, we are starting with vibration right now because vibration is having high weightage. If you will remember, yes, last time also the topics we have seen that they were high weightage topics. Simple mechanism, one question is confirmed. Velocity acceleration, one question is confirmed. Then kinematic dynamic plus flywheel, one question is confirmed. So we have already done the work for 3 questions. Now, my dear, when we are talking about vibration, the weightage is going for 4 to 6 marks in general. I would be taking 4 marks. Okay, for that also it is a very important thing. So first 2 to 3 hours we will complete it. I will be going for one case in every method of vibration. So we are starting it. So my dear, when we are talking about vibrations, first of all, you must be aware of what kind of phenomena it is. So my dear, you have studied in machine design that there was something chapter known as fatigue loading. So I would like to tell you that whenever we are having any rotating component or reciprocating components, so because of rotating and reciprocating components, some unbalanced forces are coming onto the system, which generally creates the to and fro motions, or which generally creates as vibrations. Vibrations, whenever they are generated, so we are going to see in balancing that we cannot balance the unbalanced forces, we cannot balance the fatigue forces completely. So vibrations are always going to be the part of a system. So when we are talking about a vibration system, there are 4 things which are present. First thing which is present in the vibration system, that is said to be kinetic energy storing device. So my dear, whenever we are talking about kinetic energy storing device, I feel everybody is aware we are showing kinetic energy as half mv square. So my dear, for that block is the representation. or I must say the mass of the system would be responsible for the same. Money, good morning dear. So guys, then second thing which is present in such vibration system is potential energy storing device. So when we are talking about the potential energy storing device, yes Manas, good morning. Potential energy storing device. So potential energy is given by 1 by 2 half Sx square. And my dear, for that spring is the representation. When I say spring, it doesn't mean that in reality springs would be present. Spring is just a notation. Spring is just you can say an element which represent the stiffness. Okay, so this block represent the mass of the system. This spring represent the stiffness of the system. Then my dear, the third thing which would be the part of vibration system is friction. So for relative motion is there in the vibration. Relative motion is shown by a damper. So we will say the presence of kinetic friction. Okay, because relative motion is sure. Sure means the friction is going to be of kinetic nature, not static. And when we are talking about kinetic friction, it is denoted by Cx dot, because friction force is directly proportional to velocity. It is denoted by this. For relative motion, this is the best way to represent. Okay. Then we are moving to the last thing, that is nothing but the unbalanced forces. And my dear, these unbalanced forces are coming because of two things. One is because of rotating components. Okay. Second is because of reciprocating components. And that we will see in the detail when we are entering into forced damped vibration system. So my dear, this is what we have seen right now. Okay. These are the four maximum things which can be the part of a vibration system. So these four are the maximum thing which can be the part of a vibration system. When I am saying maximum, can a vibration system have less than these four also? Yes, definitely it can have. So my dear, if a vibration system consists of only these two things, minimum these two things will be there, such vibration system is said to be the natural vibration system. Okay. If a vibration system includes only the first three things out of four, then we call it as damped vibration system. Then we call it as damped vibration system. And if a vibration system consists of all the four, then we call it as forced damped vibration system. Okay. So my dear, I would like to say now the things have certainly changed. There was a time when from all the three types of vibration, one question was coming. Kiran Konki, yes. Okay. We are moving further. Dinesh Kumar, good morning. Bhai Midun, good morning. So let's move further, guys. So when we are talking about this, we have seen these are the four maximum things which can be present in a vibration system. So my dear, there are three types of vibration system: natural, damped and forced damped. There was a time when one question was coming from all three, means one from natural, one from damped, one from forced damped. That's why at that time weightage was going to 6 marks. But now the syllabus of TOM have been increased, balancing added, cam added, governor added. They were not before in the syllabus. So that is why now the weightage is somewhere coming for 4 marks. So still I would like to say one question would be coming from natural vibrations. One question would be coming from forced or damped. Okay, because in these two topics only some formulas are there. Okay, so here you need to understand many methods of vibration. So let us continue with the first type of vibration system, which is natural vibration systems. So my dear, when we are going for natural vibration system, actually why I have kept some slides empty, because I just want to show you how the systems are going to become. Means we have said natural vibration system is having spring and mass. Teju, hello dear. So initially we are having a spring like this. Initially we are having a spring like this, which is having a stiffness of K. Okay, I can show it with K or show it by S. That is totally your choice, how you want. So my dear, this is the initial condition of the spring. Okay, now what I have done, I have just hanged a mass with that. I have just hanged a mass with that. When I have hanged a mass with that, you know spring is going to expand by some distance, that is said to be delta naught. Delta naught is said to be static deflection of mass. Delta naught is said to be static deflection of mass. So we will be calling it as static deflection of mass. static deflection of mass. Why we call it as static deflection? Because this is the point up to which there is no vibrations present in the system. Because you know, when you will be looking at the mass, there would be a downward force mg, and as the spring is getting deflected by delta naught, so there would be a restoring force s into delta naught. You can feel one thing, that this mg is the weight, okay, that is the body force, that is the surface force. So this is the resistance force actually. But my dear, this delta naught is that deformation up to which both these forces are equal in magnitude, opposite in direction, so body is in equilibrium. That is why this position of the mass is generally given the name of mean position. Till now there is no vibrations present in the system, because at this condition this spring mass system is in equilibrium. Sachin Gautam, good morning. At this condition spring mass system is in equilibrium, so that is why we call it as mean position. Now my dear, we will try to get vibrations in the system. For that we would be taking this mass x distance downward. So when you will be taking this mass x distance downward, now my dear, this s delta naught is going to increase. Now when it would be going x distance apart, you would be reaching to the new position. Now here is the mass, and this was the mean position. So it is x distance down than the mean position. Because of this, if you will see the mass now, downward force cannot increase, that is mg only, but upward force now increase from s delta naught to s delta naught plus x. So because of this, if we are going to show the net force, there would be a net upward force equals to s into x, and this is said to be the restoring force. So my dear, because of this restoring force, there will be a tendency of this mass to go up, and that is why this mass will be going up now. So when you are taking this mass down by x, now my dear, you will leave the system. So this is not the permanent force you are applying. This force you have applied for an instant just to give initial displacement, because without a start vibration cannot happen. So for starting vibration, initial disturbance is must. Okay. Then once you have given the initial disturbance, now vibration will happen by its own. But why the vibration will happen? Because my dear, now it is having a restoring force, it will go up. Why it is going up? Because my dear, it is at rest actually. There is a potential energy because of this displacement of spring. So when it is going to move, this potential energy is getting converted into kinetic energy. When this mass would be reaching to the mean position, then my dear, it would be having some velocity. Why it is having some velocity? Because this potential energy is getting converted into kinetic energy. Now my dear, because of its velocity, now x is 0, there is no restoring force. At this instant force is 0. But my dear, because of this velocity, it will keep on moving, and it will go up to a distance. It will go up to a distance. Spring is getting compressed. When it is going up to this distance, spring is getting compressed. Okay. So my dear, now once again, because of compression of spring, a restoring force will develop, that is equals to s into x. So because of that, this motion will continue, and here you can see potential energy is getting converted into kinetic energy is getting converted into potential, and as there is no friction, system energy is going to be constant. I am not saying about the thermodynamics first law that is saying that energy of the universe is conserved. That is true, but here I am talking about energy of the system, because in the system there is no friction, so energy of the system is there with the system only. So my dear, in natural vibration system, just the transformation of kinetic to potential is happening, nothing more than that. And this wonderful thing, this to and fro motion about the mean position of the system is said to be the vibrations. Please tell me everybody got it or not. Please tell me everybody got it or not. Is it clear? Very good, guys. Wonderful, guys. So moving further. So guys, we have seen this natural vibrations, what it is actually. Now my dear, I would like to tell you about, like you know, in SHM, when you see the motion of this SHM, what you have seen is that is similar to SHM. So my dear, to understand the equation of natural vibration, we need to understand SHM also. So my dear, first of all, let us see what I said. To and fro motion about the mean position of the system is said to be natural vibrations. And my dear, when it is coming down, going up, then coming down. So from mean to one extreme, going to again mean to second extreme, coming back to mean. This complete thing is said to be cycle. What is cycle? One complete oscillation is said to be the cycle. And my dear, if you are talking about time period, the time taken for one complete cycle is said to be the time period, and the number of cycles per unit time is said to be the frequency. So I have defined it. And my dear, from mean position to extreme position, the maximum displacement, that maximum displacement is said to be the amplitude. Maximum displacement is said to be the amplitude. So I have defined all the basic things. Now let us see how SHM is defined. I told you there is one motion said to be pure rotation. Other motion is pure translation. So pure translation is there, pure rotation is there. You know that. And all other motions are some combination of that. So similarly, simple harmonic motion is also derived from a circular motion. So for derivation of a, you can say, simple harmonic motion, I am taking a ball into the circular motion. If this ball is revolving with a speed of omega, so my dear, I am going to take the projection of this on any of the diameter. Let us say I am going to take this on this diameter. So if you see my dear this, at this instant projection will be coming here. And after that, when this ball will be reaching here, projection will reach here. Ball will reach here, projection will reach here. So when it is rotating like this, this projection will first go up, then will go down, and then will come up. And this type of motion is said to be simple harmonic motion. This type of motion is said to be simple harmonic motion. And in the same motion, our body is. So my dear, that is why whatever be the equation of SHM, the same should be the governing equation of vibration. So I would like to say, whenever governing equation we are talking about, so governing equation of natural vibration and SHM is going to be same. So I'm not going into derivation, otherwise you know I can go for that, but that would be wastage of time. So I can directly write it as, you can say that mx double dot plus what is the case? Okay, do not try go into that. I am not writing the SHM vibration equation, I am writing the SHM equation. What is simple harmonic equation? Simple harmonic equation is given as what? That is x double dot plus omega square x is equals to 0. This is the governing equation of simple harmonic motion. Okay. And if you are talking about angular motion, then we can write theta double dot plus omega square theta is equals to 0. Anybody wants me to derive this? Anybody wants me to derive this? Please tell me that. Because I have derived it also. How we can derive it? You know that. We would be considering this. This is the body. It is reaching to this in time t. Then you know that when the body is reaching to this, at that time, if I am going to take projection can be taken on this axis also. So this we will be considering as x. This is the radius. So you can write x is equals to r cos theta. So from here you can derive this equation. Just differentiate it once, differentiate it second time, you will be getting this equation. So no need to go for the derivation. This is how we can do this. So guys, we have done this. Now the point is how, what are the things we are going to do for the natural vibrations? We get to know the equations. So my dear, when we are talking about the natural vibration system, we have shown this is how the vibrations are going on. So my dear, now what is our target here? To find out the natural frequency of the vibrations. So we need to find out the natural frequency of the vibration. And to get that, we need to make this equation. Because in this equation, omega is our answer. So for that purpose, we need to make the equations. Okay. So there are some methods from which we can find out the frequency of these vibrations. First method is said to be the Newton method. One by one we will see all the method, and by every method I will be telling you just one case, because this is just a revision marathon now. So let us see the Newton's method, what it says. So what it says. So you already have seen when our system was like this. at the mean position. This is m, this is s. It was displaced by a distance of x. So after x displacement, it was having a restoring force s into x, because mg and s delta naught were cancelled out with each other. This was the resultant diagram. So this was coming when we are displacing it with the x. Then what was said by Newtons? Newton said that this is the displacement in this direction. So force in this direction, which is nothing but m into a. This F is equals to m into a. That can also be written as m into a. That is equals to the restoring force in the same direction. You know, it is Sx in this direction. So in the same direction, if you will take, it is coming out to be equals to minus Sx. So you will keep it to be minus Sx. You can write acceleration to be x double dot plus Sx will be equals to 0. From that you can say x double dot plus s upon m into x is 0. Then you know that we have the equation of SHM as x double dot omega square x to be 0. So from here we got omega square to be s upon m, and we will be getting omega to be square root of s by m. And as it is natural vibration, we call it as natural frequency. You can also write Fn as 1 upon 2 pi into omega n. So if the answer is asked in radians per second, this is your answer. If the answer is asked in hertz, then this will be your answer. Okay. Yes. Sir, side of method, please write which case we use this method. Definitely, Teju. So this is the Newton's method. There is no restriction on this method. You can use this method anywhere, but we will not use it because we have better methods than that. Okay. I will tell you where which method is going to be used. Second method which we are talking about is the D'Alembert's principle. D'Alembert's principle. D'Alembert's principle. So when we are talking about the D'Alembert's principle, my dear, so for that case, what we will see, the same figure I am going to make. This is the spring, this is the mass. After giving x displacement, this is the condition where this is the restoring force. Okay, I am making it again restoring force. I am making it again restoring force is like this. This is s into x. Now, my dear, what D'Alembert said? D'Alembert said, add my component to the restoring force. And what is my component? Mx double dot. Add my component to restoring force, equate it to 0, get the equation of Newton. So you will get the equation of Newton just by adding my component into the restoring force. Okay. So when you will be adding that, Sx plus mx double dot is equals to 0. So you can write it as x double dot plus s by m into x is equals to 0. So once again you will write the equation like s by m into x is equals to 0. This is the governing equation of this system, and governing equation of SHM or natural vibration system is this. So every time I will not write the governing equation, now I can directly write natural frequency would be square root of s by m. Answer will be same by everything. I told you the relation between these two. Now I will write only omega n. You can understand automatically Fn. I feel you got it. Okay. So guys, just like and share the session. This is just we have started. Okay. And today we will complete this vibrations. Okay. And after completions, then we will enter into the governors, cams, balancing, gears and gyroscopes. We try to complete by 5 p.m. today. Everything would be covered, guys. So we have seen the D'Alembert method, that is also having no limitation. You can apply anywhere. Newton method and D'Alembert method are applicable for natural vibration, damped vibration and force damped vibration, everything. I am writing this also. Okay. It is applicable for all types of vibrations. All types of vibrations. Whether it is natural damped or force damped. Now we are coming to the third method, which is energy method. Third method, which is energy method. Energy method. So as the name suggests, here we would be using the energy. Here we would be using the energy. So my dear, when we are using the energy, I would like to say that this method is applicable only for natural vibration system. Okay, it is valid for natural vibrations only. And in natural vibration also, where we will apply this, that also I will tell you, like Teju is asking. So guys, it is applicable in natural vibrations. In others, it is not applicable even. So why, my dear? First of all, I will apply this on the spring mass system. Then I will tell you in which cases it is going to be applicable. So my dear, it is going to be used. So we are having a spring mass system like this. This is displaced by x. This is the mass m. So this method says that the energy of the system is going to be conserved. It is conserved only when friction is absent. So when it is natural vibration, you can say energy of the system is conserved. So you know that first of all, we will write kinetic energy of the mass. Kinetic energy of the mass is 1 by 2 mv square. Velocity can be written as x dot. So m into x dot ka square. Then potential energy in the system is there because of spring. That can be written as half sx square. So my dear, if you see the total energy of the system is 1 by 2 m x dot ka square plus 1 by 2 sx ka square. This is the total energy of the system. Now my dear, you are saying this energy of the system is going to be constant. This energy of the system is going to be constant. So it is constant. If we are writing this, then we can say the dE by dt is going to be 0. So when you will be finding out dE by dt, 1 by 2 m 2 into x dot into x double dot. Differentiation we have done. 1 by 2 into s into 2 into x dot is equals to 0. Because energy is constant, this differentiation will be 0. You know x dot is common. 2 will get cancelled out. 2 will get cancelled out. The equation will come once again. Mx dot plus Sx is equals to 0. You can see once again we got the same equation. The same equation means the same answer. You will once again write omega n is square root of s by m. Please tell me everybody is fine or not. This is what is energy method. Now I will be telling you where you have to use it. Where you can use it, everywhere in natural vibration. But everywhere this is not efficient. Everywhere it is not efficient. Where it is efficient, it would be efficient at two places. One place is when we are having pure rolling or pure rolling motion. When we are having pure rolling motion. This is the one case. Second case is if spring is not massless. These are the two cases where energy method is more useful than the other methods. I feel you got it. Yes. Vineet sir, what is S? S is the stiffness. Vineet, stiffness can be shown by K or S both. I generally show it by S. In the books you will see generally by the K. Okay. So my dear, these are the two things. Pure rolling and spring is not constant. So my dear, now we will talk about the pure rolling motion. So what is pure rolling? We have already seen. Pure rolling is. Everybody remember the last class of Tom Marathon? Pure rolling is a combination of two motion. One is pure translation. Other is pure rotation. So pure rolling is the combination of these two motion, pure translation and pure rotation. So my dear, you know that when we write the kinetic energy of pure translation, we write it as half mv square. And for rotation, we can write half I omega square. So my dear, let us solve one question on this case so that you get to know how we will be using it. So guys, we are having a case like this. We are having this, a disk. This is a disk. This is a spring. Stiffness is S, mass is m, radius is r. Okay, the motion is pure rolling, my dear. The motion is pure rolling. So you know, first of all, we will write the kinetic energy of the system. So kinetic energy because of pure rolling will be the combination of translation plus rotation. So half m v square plus half I omega square. You know, in the pure rolling motion, V is equals to R into omega. Okay, so R omega can be written as V, and V is nothing but x dot. So you can write the kinetic energy of the system as 1 by 2 mx dot ka square. Then my dear I, when we are talking about the mass moment of inertia, so for disk it is 1 by 2 mr square. So for disk it is mr square by 2, for ring it is mr square. So for different geometry, I is different, that I will give you the values. So for that timing I am saying 1 by 2, I is 1 by 2 mr square. Then we have omega square. So it is 1 by 4 mr square omega square, R omega is V. So you can write 1 by 2 mx dot ka square plus 1 by 4 mx dot ka square. So we got it as 3 by 4 mx dot ka square. This is kinetic energy of the system. Then you know potential energy is half Sx square. Then you know the total energy is the summation 3 by 4 mx dot ka square plus 1 by 2 Sx ka square. You know energy is going to be constant. So we can differentiate it and equate it to 0. We can put it dE by dt to be 0. dE by dt to be 0. So when you will be finding out dE by dt, it is 3 by 4 m 2x dot into x double dot plus 1 by 2 into s into 2x into x dot is equals to 0. 2 will get cancelled out, 2 will get cancelled out. You would be getting what? 3 by 2 mx double dot plus sx, because x dot will get cancelled out, is 0. This is the governing equation of the system. Natural frequency will be coming out to be 2s by 3m. Everybody got it? Everybody got it? This is your choice, sir. In exam, which moment of inertia is asked? We need, first of all, as I am telling you that this is the theory of machines going on. In strength of material, we are having deformations. In theory of machines, we are having motions. So first of all, in tone and vibration, we are generally talking about the mass moment of inertia because rotation is going on. Okay, but in case of SOM, we are generally talking about area moment of inertia because torsion is going on. So here also in vibration, when we will see torsional vibration, then area moment of inertia. Otherwise, all the time in tone and mechanics, we have mass moment of inertia. Then the point is about which point. If you are talking about pure rolling as translation plus rotation. So for rotation, all the time when we are talking about the body, it is going to be about the centroid, about the centroidal axis. But my dear, you also know that in the Kennedy theorem, in the eye center approach, you have seen for rolling pairs, for pure rolling motion, it can be considered as pure rotation about the eye center. So if you are considering about eye center, it has pure rotation. So my dear, if you are going to consider this pure rolling as pure rotation, then pure rotation is about this axis. For that case, you would be considering I also about this axis. Answer will remain the same. If you are going to find out I about this axis, you know half mr square is about centroidal axis. You need to find out this. You will find out parallel axis theorem. And if you are going with that, then also you will be getting the kinetic energy to be what? You will be having 1 by 2 I omega square, because this time only pure rotation, but I would be about I axis. What is I axis? 1 by 2. For that you can write m r square by 2 is about centroidal axis, then m into r ka square into omega square. Once again you are going to get what? You are going to get 3 by 4 m r square omega square, which can be written as 3 by 4 m x dot ka square. So you got the same kinetic energy. So the same answer will be coming. So yes, Advait, good morning. Today you got late. Yes, you got it, guys. What I said, we need your doubt is clear. So it would be depending on which motion you are talking. But when we are talking about rotation, so about the axis, you need to take, about the centroidal axis, you need to take the I value. Okay. For pure rolling motion, centroidal axis which was previously this now becomes this, because this is the eye center. Okay, so guys, let us move further. So guys, second case is if spring is not massless. So my dear, if spring is also having some mass, what kind of changes we are expecting? If spring is having some mass, let us say ms is the mass of the spring. Then my dear, for that, this mass of spring will also be having some kinetic energy. So this time total energy will be having three components. One is kinetic energy of mass plus kinetic energy of spring plus potential energy of mass of spring. So you know that you need to find out kinetic energy of spring. Rest all you know. So for that, what we are going to do, we will take spring separately. If you will take the spring separately, you know that velocity of this point is 0. Velocity of this point is x dot, because this will be same as that of mass. This is the velocity. You would be taking a small part because velocity is different for everything. Kinetic energy cannot be written by half mv square because velocity is variable. So you would be taking a small section of dx length at a distance of y. You can also consider it as dy at y length. So this is the small section. So my dear, you know that for L length, the mass is ms. For 1 meter length of the spring, mass is ms by L. For dy length, the mass is ms by L into dy. This will be the mass of spring. Okay, velocity is variable. You know that this is 0, this is v. So velocity change. So you can say change of velocity is x dot in L length. So in 1 meter length, change of velocity in 1 meter length will be x dot by L. Then change of velocity, you are coming at y distance, will be x dot by L into y. So you can define the kinetic energy of the spring as it is going to be half mv square. What is mass? ms by L into dy. What is velocity? X dot by L into y ka square. You want total energy of spring, you need to integrate it. Okay, and integration will give you 1 by 6 ms x dot ka square. This you would be getting, guys, as the kinetic energy of the spring. And when you would be putting it, you would be getting the omega n for this system to be stiffness divided by m plus ms by 3. So please tell me, everybody got it or not? Then we are moving further. So I told you the application of this method also. Guys, do like and share the session. I need more and more students to join because this is very important session. You know, vibration have a very good weightage. Sir, if spring is not massless, then we have to take that I have done, Vineet. I feel so. I feel I have done the derivation for you now. Okay. So this was the energy method. Now we are going for the torque method. Okay, in the spring we have already seen. Do you remember series parallel combination and cutting of spring? If I am going to join two springs in series, this is S1, this is S2. So everybody know, if I want to find out the equivalent stiffness, it would be 1 by S1 plus 1 by S2. Similarly, if we have two springs in parallel, then S1 and S2, then you will be having S equivalent to be S1 plus S2. Similarly, if I am going to cut a spring in the part of M is to N, initially stiffness was S, then this part after cutting will be having stiffness of this, and this part will be having stiffness of this. Similarly, if we have a spring which is cut into three parts, M, N, P, initially stiffness was S, then this part will be having a stiffness of M plus N plus P, divided by m by s. This part would be having m plus n plus p dividing by n by s. This part would be having m plus n plus p divided by p by s, p into s. So this is how we can define it. I feel everybody got it. So this is how we can do this. Now we are moving to the torque method. This is nothing but D'Alembert principle of. This is nothing but D'Alembert principle. D'Alembert principle for angular vibrations. For angular vibrations. Okay. This is nothing but D'Alembert principle for angular vibrations. So my dear, if we have this is a ball M, L is the length. Okay. So you know, without any disturbance, vibration will not start. Here mg is acting downward, tension is upward, everything is balanced. But what if we are going to give an angular displacement of theta? Then with an angular displacement of theta, this would be reaching to the new position. This time mg will act like this only, because mg is going to act in the same direction. But this will be having two components. This is mg cos theta, which is balanced by the tension. Second component is mg sin theta. This component is not balanced. So this is the restoring force. But as the motion is angular motion about this axis, so we are not interested in force, we are interested in torque. So we are having a restoring torque that is equals to mg sin theta into length. This is the restoring torque. Now D'Alembert said add my component. This time D'Alembert component will also be a torque, which will be I into alpha. Alpha is theta double dot. So you will say that I theta double dot plus mgl into sin theta. You must be aware of one thing, that theta is very, very small. So when theta is very, very small, sin theta will become theta. So you would be having I theta double dot plus mgl into theta is equals to 0. So my dear, you can write omega n to be square root of mgl by ml square, because I for this mass which is at a distance of L will be ml square about this axis about which rotation is going on. I would be taken about the axis about which rotation is going on. Okay. So this is the formula which will be giving you G by L. This is the natural frequency of vibrations. Is it clear for everyone? Please tell me that. Okay. This is clear for everyone. Please tell me that. Wonderful, guys. So this is about torque method. Now the point is when torque method is applicable. Torque method is applicable in all the types of vibration, natural, damped and force damped. So my dear, where this method is applicable? Applicable in all types of vibrations. All types of vibrations. But where it is useful, where it is better than others, the places of pure rotation. Wherever pure rotation is going on, you can use it. Wherever pure rotation is going on, you can use it. It will give you faster answer. You might be asking, sir, what is the meaning of pure rotation? We are having a disc like this. There is a spring. There is a spring. Okay. The stiffness of this spring is S1. This is S2. As this is the fixed axis, it is pure rotation. So my dear, if that is the case, I am saying that let us say we are rotating it with an angle of theta. Then definitely this spring will reach to this point. So this is the deformation in the spring. What is that? R into theta. So my dear, because of that there will be a restoring force S1 R into theta. Similarly, this point will be reaching here. Here also there is deformation R into theta. So here also a restoring force will be coming, that is S2 into R into theta. Because in the rotation we are going to take restoring torque. You can see this is force, torque will be about this axis. So you would be having the torque to be, what is the restoring torque? S1 R square theta. The second restoring torque S2 R square theta. You rotate it in this way, restoring torque will come this way. Then D'Alembert said I component, my component, I theta double dot. Here I would be of this disk about this axis where about which the rotation is going on. So you will be writing I theta double dot S1 r square theta plus S2 r square theta is equals to 0, where I will be m r square by 2. For disk, you know that. So you would be having omega n to be equals to 2 times H1 plus S2 divided by mass. Is it clear for everyone? This is where the rotation is there. Even you can feel pure rolling as pure rotation. You can use torque method there also. So you might be saying, sir, then why you said in the pure rolling we need to use energy method when torque method is more easier than that? Dear, definitely it's correct. But there are some cases when we are going to have like this. They are saying that there is a pulley of mass m. There is a pulley of mass m. And we are having a spring like that. And they will be having a mass m like that. So this time there are two mass, this m and this m. So torque method when we were using, there was only one mass. Yes or no? There was one mass, that was a point mass. But energy method can be used here. So when we have more than one masses, generally we are going with the energy methods. Okay. So when we have more than one masses, then we will be going by the energy method. So for such cases, energy method is more useful. Is it clear for everyone, sir? हो सकता है, हो सके तो वाइब्रेशन में थोड़ा स्लो करवा दो. हाँ, वाइब्रेशन में मैं स्लो ही जाऊंगा, ठीक है, डोंट वरी. आई विल गो स्लो ओनली बिकॉज द टॉपिक्स लाइक गवर्नर दे ओनली हैव द फॉर्मूलाज. Camps, yes, it will take some time to tell you about the motions, but for all those topics I have everything written on the slide, so time required would be lesser. Here vibration is not something which I will be read out, that's why I am taking time properly. Okay, but yes, we are not going for too much problems, so one method, one problem, we are going like that. Is it clear, Vineet? Shall we move on now? Teju, Vineet, Advait, Ganesh, Malesh, Vineet, please tell me that. Yes. Okay, guys. So we are continuing with this. Very good, Ajay. So we are moving further, guys. Aditya, very good. Fine, great. So guys, we are moving further now. So now I would be telling you about Rayleigh method. I feel the next method is Rayleigh method. Ganesh sir, just remembering you about my doubt in eye center. Yes. Ganesh, I am going to take it at the time of governors. There in the controlling force diagram, once again, in governors, once again we will see eye center. So there I'll tell you. Okay. So my dear, okay, I want to give you the inertia value also for the geometries. If we are talking about for a ring, it is mr square. Okay. For ring it is mr square. For hollow cylinder it is mr square. For disc it is mr square by 2. For solid cylinder it is mr square by 2. For solid sphere and for hollow sphere, when we are going to do this, for solid 2 by 5 mr square, 2 by 3 mr square. Okay, so we have seen this as well. Generally they are going to use this much geometries only. Okay, not more than that. Generally only this much geometry would be used. So moving further, guys. So questions we are not going to do much because you know that we are going to have the question in the practice session. Okay, everybody got it now? We have seen all these methods. Okay. Fine guys, fine. So now I would be telling you the relay method. I feel slide is not available there. Let me take at some other place. Okay guys. So now we will see the next method. Now we will see the next method. So guys, next method is torsional vibration. After this we will see the relay method. Torsional vibrations. So when we are talking about the torsional vibrations, then my dear, in the torsional vibration we are going to have a shaft. This is the shaft which is fixed at one end and this is free at other end. Then only torsion can happen. Now it is attached with a disc. This is the disc. So my dear, if this is attached with the disc, so this disc is having mass moment of inertia of I. This shaft is having modulus of rigidity G, polar area moment of inertia J, and length of L. Okay. So my dear, here this is very much similar to the spring mass system. In the spring mass system, we are going to displace this mass by X. Because of this spring is getting expanded by X. So my dear, similarly here what is going to happen? For spring it is deformation, for mass it is displacement. Here I am going to give a rotation of this disc by an angle of theta. This is rotation for the disc because disc is free. But the same thing if we are talking about the shaft. For shaft it is going to be torsion. Why? Because here it is fixed, no deformation, no angle of rotation. Here the angle of rotation is theta. So theta will be linearly varying. This is our assumption, like in the spring we have assumed velocity was varying. So if that is the case, my dear, like here we were writing omega n was equals to square root of s by m. Like here we were writing mx double dot plus sx is equals to 0. Here also we can write I theta double dot plus s theta into theta is equals to 0. Here what is I? I is the mass moment of inertia of disc. Like here m was the mass of block. Here s was the stiffness of spring. Here s theta is the stiffness of the shaft. And I feel we derived in the SOM stiffness of the shaft is Gj by L. This is known to us. So my dear, if we are having this I theta double dot, then we know that I theta double dot plus s theta upon I is going to be equals to 0. Now my dear, what is omega n? Omega n will be s theta divided by I. Here s theta is Gj by L. If this is a disc, then I will be mr square. So by putting the value you can get the answer. This is the case of torsional vibration. We have used once again D'Alembert principle. So as I said, D'Alembert is everywhere applicable. Okay, everybody got it? From torsional vibration, questions are coming from two rotor system. Till now they have not asked, but it will be coming soon. If we are going to have one rotor like this is the shaft, this is second rotor. When we are having two rotor system, my dear, how vibration will happen? It is like an axle, or you can say a shaft on which one wheel, other wheel. Vibration will come if I will give rotation to both of the disc in opposite direction. Means this is given rotation in clockwise, then this is given rotation in anti-clockwise, like this. Then vibration will happen like this. So I am saying I have given opposite rotation. The point where theta is 0 is said to be the node. And from that node, L1 is the distance of this disk, L2 is the distance of this disk. And my dear, if you are writing this, you know that vibrations will be going on like this. So this is only possible that shaft will remain alive if both have same natural frequency. Means if omega n for 1 is equals to omega n for 2. You know that omega n is given as theta 1 upon I1 is equals to S theta 2 upon I2. What is S theta? It is G1 J1 upon I1 L1 is equals to G2 J2 upon I2 L2. You know that for both the disk, shaft is same. So if you square both sides, GJ will get cancelled out. And L1 L2, you know that this is I1 L1 is equals to I2 L2. And from this equation, question will be coming. You know that this is one equation. Second equation is L1 plus L2 is equals to L. So it says the product of I into L is constant. Means if I is more, L will be lesser. So node will always be there near to the rotor of high moment of inertia. So my dear, what they will frame a question? They will say initially we have the rotors of same I. It is also having I, it is also having I. Then the node will be at the center. Then they will say, what if we are going to replace this disk by another disk which is having 2I mass moment of inertia. So if this is becoming 2I, so my dear, you know that I into L is going to remain constant. So you will write I1 L1 is equals to I2 L2. I1 becomes 2I now. I2 becomes I only. So my dear, you know I will get cancelled out. L2 will be coming out to be 2L1. So what do you mean by that? This time disk will shift to this point, which is L by 3 from this and 2L by 3 from this. So this type of question can be framed for gate examination in the torsional vibration. Please tell me everybody got it or not. Then we are moving to the Rayleigh method, the last method for natural vibrations. And after that we will enter into damped and force damped. Dear, you know vibration is a very big topic. I have done a lot of questions in the classes. We do it around 15 hours total. But in revision we will be hardly completing it in 3 hours, 2.5 hours. Okay, because we have to complete all the things. And second thing, we are revising. This is a revision marathon. So in revision, every question if I will do, then what is the difference in class and this? Is it clear for everyone? So moving further guys to the Rayleigh method, the last method of natural vibrations. So let us see. Let us see Rayleigh method. So Rayleigh method. So my dear, when we are talking about Rayleigh method, it is applicable only for natural vibration. It is applicable only for natural vibration. The reason behind that is, my dear, the reason behind that why it is valid for natural vibrations only, because it is also based on somewhere the conservation of energy of the system. So energy of the system will remain conserved, only friction is not there. So only for natural vibration it is applicable. What it says there is no need to make the governing equation. If you have a spring mass system, this is mass, this is S. Then this says the natural frequency of the system is given by G by delta naught. Here delta naught is static deflection of mass. Means this is the point when the mass is in equilibrium. This is the deflection of mass when vibration have not yet started, when there is no external disturbance have to be given. So for such case, you know, when mass is in equilibrium, downward we have mg, upward we have s delta naught. If you would be putting s delta naught is equals to mg, you would be getting delta naught to be what? You would be getting delta naught to be mg by s. You just need to put this value here, you will get it as s by m. So you can see, my dear, the same spring mass system we have seen from Newton method, we have seen from D'Alembert principle, we have seen from energy method, we have seen from Rayleigh method. I feel this is the most easiest one, because here we need not to even make the equation. But the point is when to use this method. When to use this method? First thing, only 1 point mass. Only 1 point mass. So if only 1 point mass is present, then we will be using this system. This is the first point. Second thing, no friction. It means only natural vibration system. So guys, this method is applicable only in natural vibration system if we have 1 point mass only. Means distributed masses, you cannot apply this, first thing. Second thing, my dear, this is applicable every time if you can see any mass to be a point mass, otherwise it is not. So I would be taking one case. Every year questions are coming from that. Okay, actually there are many cases, but I would be taking one case out of them. What is that one case? This. And guys, don't worry, as I already told you one more thing. We will be having one practice session also, CTQ. So whatever the type of question you are looking for, that would be covered there. So don't worry about that. So this is something. A is the distance of the spring. B is this. Okay, let us take B to be the total distance. Let us take B to be the total distance. Okay, then it would be easy to solve for us. So B is this distance. S is the stiffness. Okay guys, so when you have question like this, you know it is hinged at this point. It is hinged at this point. So my dear, you know, because of this mass, even if I do not touch this system, you will feel the system to be displaced like this. And you would be having this as delta naught, because this is coming without any disturbance with the system. When I have not even touched the system, then also this mass would be having this much static deflection. And my dear, because spring is deformable body and spring is getting deformed by delta 1, always remember this delta naught is always defined for the mass. If mass is at some other position, if mass is here, spring is here, then for mass it is delta naught. Delta naught is defined for mass only, not for the spring. So if you have this case, I feel you can feel there are two similar triangles. One triangle is this white one, other triangle is this green one. So we are going to use the similar triangle principle. Why similar? This angle is common, one angle is 90. So two angles same means all the angles are same. So you can write, my dear, delta naught by B, delta 1 upon A. So you can find out delta naught to be B by A into delta 1. Now we are going to take summation moment about O to be 0. What is O? This is O. So when you will be taking summation moment about O to be 0. Why? To find out delta 1. So you know that mg is acting downward. So I will say mg into B. This is creating clockwise. Spring force will be acting in this direction. S into delta 1. Acting in opposite direction. So minus S delta 1 into A is equals to 0. So from here you can write delta 1 to be. Delta 1 will be coming out to be B upon A into mg upon S. Okay guys, and when you will be putting this value in this, then delta naught will be coming out to be B by A into mg by S. So it is B upon A ka whole square mg upon S. Then my dear, what is omega n? G upon delta naught. This is going to be G B upon A ka square mg upon S. So guys, this is going to be A by B S upon M. Please tell me, is it clear for everyone or not? शिवम, गवर्नर में क्या इंपॉर्टेंट है? इन गवर्नर यू मस्ट गो फॉर द कैरेक्टरिस्टिक्स ऑफ गवर्नर, sensitivity, stability, hunting, okay, those are important. Wonderful. Relay method is in vibration, that is not in governor, okay. So I feel it is clear for everyone. So always remember, one thing is point mass, second thing is no friction, and third thing is, what is the third thing? Point mass, no friction. What is the third thing? Third thing is this delta naught is static deflection of mass. Very good guys, wonderful. हाँ बिल्कुल सही शिवम, then it's fine. Moving further guys, so we have seen the relay method also. Now we are coming to the damped vibration system. So everybody is okay with that. We have seen all the methods, and don't worry if you are looking for pulley problems, so in the CTQ problem practice session we will see that kind of questions also, okay. So here we are covering the theory part completely, and there we will be having some good numericals. So my dear, with this we have completed the natural vibration. Everybody is clear? Yes, Manas? Very good. So guys, we are going with a nice pace, okay. Actually in first class of Tom we were very slow because simple mechanism we have taken for 2 to 3 hours. The reason was that is very important, okay, and that was a fundamental chapter. So now we are moving to the damped vibration system. So my dear, when we say damped vibration system, I told you many times, whenever you say the word damping, damping is the technical name. Damping is the technical name for kinetic friction, okay. It is the technical name for kinetic friction. So when we are talking about the damped vibration, numerical part कब शुरू होगा? Aditya, actually you must be aware of one thing. We are going with the numerical sessions separately, but along with the marathons only. Like we have done the practice session of SOM earlier, TOM also we have seen, and now we will be having MD sessions tomorrow. Then on Tuesday or Wednesday we will keep a vibration practice session separately also, okay. So within 2-3 days we are having practice sessions. Tomorrow we are having for machine design. So in that CTQ in 2 hours we are having all the types of problem from that subject, okay. Or otherwise whatever the case is I am discussing, they are questions only. Sir, if there will be any UDL on the beam, how to approach it? Dear, for UDL we can go for torque method, then this method is not applicable, okay. What you are asking I understood, I am telling you how to do that. If we are having this beam, previously we were having hinge, now we have a beam. If you have a point load like this P, then you know under this load P this will be deflected like this. Then you would be considering like this. This is the P load, you know that this deflection is given as PL cube upon 3 EI. You know that we have done it in the SOM. So if they give a question like this, that this is the beam on which a point mass is present, then for point mass you can go with this. This is going to be the static deflection of mass. We know we can put it as PL cube upon 3 EI, where you would be considering P to be equals to mg, okay, and then you will be writing natural frequency to be square root of g by delta naught, which is equals to g by y. So you will be having like this only, okay. For distributed force, we will not be using the relay method. Relay method is applicable only for the point masses. Teju, if aptitude marathon would be there, then we will see some change of timings, okay. I have not seen that. So if that is the case, we will change the timing in that case. Either we will try to take it before. Ha, Advait, we would be using the deflection of beams, but when we are talking about this, relay method is not applicable. If you have any such question, share it to me. I will tell you how to approach it. But otherwise, distributed is not be done by this method. Okay. Moving to the damped vibration system. So guys, as I said, damping is the technical name. Very good, Ramesh Small. Damping is the technical name of kinetic friction. You all know that when we are talking about kinetic friction, kinetic friction gives the guarantee of relative motion. It means relative motion is present anyhow. And my dear, relative motion, when we use this word, this is better shown by the damper. So this is the representation. So till now our system was spring mass system. Now our system will become spring damper mass system. This is the figure for damped vibration system. This is the figure for damped vibration system. This is the figure for damped vibration system. My dear, friction is the first reality of the mechanical components, and here the friction is introduced. So after completing marathon, complete subject practice sessions are there now. Yes, Malesh. After marathon, we have 2 more series to come from 21st of January. In those 2 series, we will be having one as formula series, where we would be having quick formula revision only, like now we are studying concepts also. Then there would be only formulas in 1 hour to 1.5 hours of the subject, and then we will be having the practice session for that, where our special number of questions, like I will be coming with some my 20 question, my 25 questions, like that. 2 series will go on, one for practice, one for formula revision, from 21st to 30th or 31st. Then we will be having mock test for your exams also. Okay. So guys, this is the damped vibration system representation. So guys, this is how we can represent the damped vibration system. And when we are talking about the damping, it is the kinetic friction. So I would like to say that the friction force or damping force is directly proportional to the x dot. So generally damping force is given as C into x dot. Here C is the proportionality constant, or it is also said to be the damping coefficient. Okay, it is also said to be the damping coefficient. Units of damping coefficient is Newton second per meter. This is the unit. Okay, it is Newton by velocity, force by velocity, Newton second by meter. I feel it is clear to everyone. So guys, now what is going to happen? This time, if you will see the free body diagram of this mass, you are going to take it down by x, then only the vibration will comes into the picture. So you know that there will be a restoring force of the spring kx, restoring force of the damper is cx dot, and this is D'Alembert component. I told you D'Alembert is applicable everywhere. So D'Alembert said, as add my component to the restoring force, equate it to 0, you will get the equation of Newton. So equation of Newton here is mx double dot plus cx dot plus sx is equals to 0. This time this is the governing equation. If you will be dividing it by mass, you will be getting x double dot plus c by m x dot plus s by m into x is equals to 0. So my dear, this is said to be the governing equation now. So if this is governing equation, this is the second order differential equation. For this, the x is given as a1 e1 to the power alpha 1t plus a2 e to the power alpha 2t. If alpha 1 is not equals to alpha 2. Or you can also write x is equals to, this is the solution of this equation, a plus what is that? A plus bt. What would be the case? A plus bt e to the power alpha t. If alpha 1 is equals to alpha 2. These are the 2 types of equations, 2 types of solution possible. What is alpha 1 and alpha 2 here? Alpha 1 and alpha 2 are the roots of auxiliary equation. Roots of auxiliary equation. What is auxiliary equation? If we put x double dot to be alpha square, x dot to be alpha, and x to be 1 in this equation, then we will be getting the auxiliary equation. So you can see this all whatever I have written, these are the 2 types of solution. Alpha 1 and 2 are the roots, and the equation will become like this. This is the quadratic equation. Quadratic equation. You know what is the root of quadratic equation? If we have a quadratic equation of ax square plus bx plus c is equals to 0, you will be having minus b plus minus square root of b square minus 4ac divided by 2a. These are said to be the roots. Okay. If the time would be remaining, then today also I will take some question, because in my slides I have 20 to 30 questions of vibrations. So if time permits, we will take those questions today only. Moving to the next slide. So we are going to use that formula, and you will be getting these are two roots. These are two roots. What are the roots? I have get it. C by 2m plus minus, it is C by 2m minus omega n ka square. These are the roots. So my dear, now when we are going to see this C by 2m, here this term C by 2m, this is somewhere telling us about the loss. Omega n term is telling us about the restoration. So my dear, this C by 2m square is for loss, omega n square is for restoration. If I would be defining C by 2m ka square divided by omega n ka square, this is said to be degree of dampness. In the paper they can ask you degree of dampness. This is degree of dampness. But this is not giving any clear idea about the damping. So for that purpose, we are going to take the square root of that. When you will take square root of that, square will get cancelled out. Then you would be having damping factor zeta, which is C by 2m divided by omega n. You can also write it as C by 2m omega n. Omega n is root k by m. So you are going to have that C by 2 root mk. So we are going to have this zeta as C by 2 root mk. This is very important formula. So here we have derived two formula in the derivation. One is degree of dampness, other is damping factor. In this formula, in this chapter, damped vibration and force damped vibration, we have some 8 to 10 formulas. If you remember those formula, then my dear, if you don't know even anything about vibration, you will be able to solve the problems. Okay. So we have already seen zeta, which is damping factor, and degree of dampness. Two formulas we have already seen. Moving to the next slide. Okay. So now my dear, when we got this, now we can also change this equation. You already know C by 2m. It was written, it is C by m. Okay, C by m. We want to change it. So you already know what is zeta. Zeta is C by 2 root mk. Okay. And how you got it as? You got it as C by 2m omega n. So if you take this 2 omega n, this m omega n like this, zeta, you can write C by m as 2 zeta omega n. So we would be replacing C by m by 2 zeta omega n. So our equation will become like this. So now our governing equation is x double dot plus 2 zeta omega n x dot plus omega n square x. This is our governing equation now. And we also know that how to find out the solutions. Now we are going to see there are three types of system now, because if you see x double dot plus 2 zeta omega n x dot plus omega n square x is equals to 0. If you see just this equation, you already know we have found out the value of alpha 1 comma 2 also. If you see that alpha 1 comma 2, what is the alpha 1 comma 2? We have seen in the previous equation. What is alpha 1 comma 2? If you see alpha 1 comma 2 in the previous equation, this is alpha 1 comma 2. You can put the value of C by 2m there also. If you will put C by 2m value, you can get the value of alpha 1 and 2. Okay. What is that? It is minus C by 2m. It is minus C by 2m plus minus square root of C by 2m ka square minus omega n ka square. You can also write it as alpha 1 comma 2 C by m is 2 zeta omega n. So it is minus zeta omega n plus minus square root of zeta omega n ka square minus omega n ka square. So you can say that minus zeta plus minus, this is zeta square minus 1 into omega n. So these are the values of alpha 1 and alpha 2. So you can write alpha 1 as minus zeta plus zeta square minus 1 into omega n. Alpha 2 as minus zeta minus zeta square minus 1 into omega n. Please tell me alpha 1 and alpha 2 are equal or not. Guys, do like and share the session. Why there is a difference in like and watching? So those who are watching, they are not liking it. So please tell me alpha 1 and alpha 2, are they equal or unequal? Because we have two types of solution. When they are equal, then we have a plus bt e to the power alpha t. If they are not equal, then a1 e alpha 1 t plus a2 e alpha 2 t. So please tell me alpha 1 and alpha 2 are equal or not. Some are saying not. Dear, I would like to say that whether they are equal or not, that will depend on the value of zeta. If you would be putting zeta to be 1, then 1 minus 1 will be 0, 1 minus 1 will be 0. You will be getting alpha 1 and alpha 2 to be equal. So whether alpha 1 and alpha 2 are equal or not, that would be depending on the value of zeta. So based on the value of zeta, we have three types of system. First type of system is said to be overdamped system. You know that if zeta is going to be more than 1, we will call it as overdamped system. Why? Because zeta was defined as c by 2m divided by omega n. So this is the factor associated with the loss. This is the factor associated with the restoration. So loss is more. Loss is because of friction. So if friction is more, friction means damping. If damping is more, the system is said to be overdamped system. If we have zeta is equals to 1, it is said to be critical damped system. If zeta is less than 1, we will say underdamped system. Because zeta less than 1 means loss is less than restoration. So if loss is lesser than restoration, we will call it as underdamped system. Underdamped is viscous damping. Overdamped is Coulomb's damping. What is Coulomb's damping? So my dear, the friction between two dry surfaces, that was for the first time observed by Coulomb's. So that is given the name of Coulomb's damping. And if we have the damping because of liquid, like let us say you are moving in a river, then definitely my dear, because of the water resistance, you will not be able to move fastly. Obviously that would be creating some damping. So that is said to be the viscous damping. So viscous damping is generally lesser than the Coulomb's damping. Yes, it's fine. So guys, when we are talking about this, these two are understandable. Critical is not understandable. Because critical word is not a simple word. It is coming under the critical conditions. When we are talking about critical condition, what it is? So my dear, when we use critical, you must have seen the scenes of old movies, 1990s movies. At that time, Amitabh Bachchan was doing the role of angry young man. You have seen that. Then in such movies, you would have noticed every movie was having a emotional scene where the mother of hero is there in the hospital and she is about to die. Then doctor comes and he says patient is critical. He didn't say patient is no more. He just said patient is critical, and people starts weeping. People starts crying. Why? Because they understand critical means now anything can happen. Critical word is used where difference is not of day and night, where the differences are of earth and sky. So that critical word is not used anywhere. Generally you use the critical word very badly. You say sometimes that, sir, situation was slightly critical. If it was slight, it cannot be critical. If it is critical, it cannot be slight. Critical, it means is extreme. Okay, sometimes you say, when I say why you are late in the class, you say, sir, actually why you are late? Because you have waken up late, so that's why you are late. But what you will say, sir, situation was critical. This was not critical. Critical means you were somewhere stuck into some bad situation. That is critical. Okay, this is not critical thing. So critical is a dangerous word. So now we will see one by one all the types of system. First of all, we will see the overdamped system where zeta is more than 1. So you know the solution is given by this. When you will keep the value of alpha 1 and alpha 2, this is going to be the solution. You know, for this case, zeta is going to be more than 1. So if zeta is more than 1, if I put zeta to be 2, let us say, then you will be having a e to the power. This is minus zeta, minus 2 plus 2 ka square minus 1 is root 3 into omega nt plus b e to the power minus 2 minus root 3 omega nt. You can see, my dear, this is going to be negative. This is also going to be negative. So it is the summation of two negative exponentials. Two negative exponentials. Two negative exponentials can be written as a single negative exponential. So when you are going to make the curve for this negative exponential, you will say x is here and time is here. The curve will be coming like this. It is going to be like asymptotic. Means it would become 0 after a very long time. After a very long time it will become 0. So here response of the system is very, very slow. Slow response. Because it is becoming 0 after a long time. Vibration is defined as to and fro system. To and fro motion. Here motion is only at the one side. Here there is no motion. So no motion in the fro side, only two motion is there. Only one side motion is there. So here I will say there are no vibrations. There are no vibrations. That is why overdamped systems are not very important for the syllabus point of view, because here in reality vibrations are not there. This curve is for critical. This is not for overdamped. We will see that. So guys, the example for overdamped system is this. In the door hinges. In the door hinges, you can see how slowly the door is closing. Whenever you are opening the door to go out, it is very, very slowly. You can see you have just opened the door. This is the door. You have just opened the door to go out. Now door is closing like this. Very slowly. You have opened it to go out, but you can say in that much time many people can go out. Is it clear? Dear, when we are talking about the negative exponential, it is the power which is negative. Okay, it was the power which is negative. If you put minus sign outside, then only it will become negative. Okay, yes, because E is 2 point something. So the negative power cannot make it negative. Okay, moving to the further second type of system. This is overdamped system. So in overdamped system, vibrations are not there. This is also present in the seats. Whenever you are using the seats, generally in the you can say aeroplanes, aircrafts, then this is also having the overdamped system. So whenever you are going down, it is coming back very, very slowly. Okay, if we are going to apply no damper here, we are not going to give overdamping, then this will happen. Okay, this will happen to you. So guys, that is why overdamping is provided at that position. This is the example and application of overdamped system. Now we are talking about critical damped system. Critical damped system means where zeta is equals to 1. Then alpha 1 comma 2 will be minus zeta omega n plus minus square root of zeta square minus 1 omega n. This is the case. So when zeta is 1, alpha 1 will be equals to alpha 2 is equals to minus omega n. This will be the value because zeta is 1. So the solution will be this. A plus bt e to the power minus omega nt. If you see a plus bt, this is the linear curve. If you ask me to plot a plus bt, I will be plotting a plus bt like this. A plus bt like this. This is a plus bt, where this value is a. Okay, and if you ask me to plot x is equals to a e to the power minus omega nt, then I would be plotting like this. becoming zero after very, very long time. Okay. But my dear, when you are having a product of this, then in the graph we see when we have the product of this, what happens actually? This which was starting from here, initially for some time duration, linear part is more dominating. So curve is coming linear like this. And after that, the exponential which was about to start from here, it is going to start from here. So when you will be shifting this to here, it will be coming like this. This time it is becoming zero at very less time. So when we are using this critical damped system, here response is very, very quick. Response is very, very quick. So if you are going to use the critical damping, then also this kind of condition can happen. If you are enjoying too much and the people at aircraft, they thought to give you a kind of enjoyment, they says ab inko maja chakhate hain, and if they provide there that kind of critical damping, you will get this type of quick response. Like this time, if you will open the door like this, it will be coming back like this very fast. You may directly get an accident. Okay, so the application of critical damping was used first time in the rifles, in the AK-47. So when it was used in the AK-47, my dear, initially there was a problem that response time was very, very less. So when you were firing a bullet, then you know when you fire a bullet, a reaction comes like this. So in overdamped system, you were just firing a bullet and it was coming back like that. So it was an overdamping kind of thing and it was taking time a lot. Okay, so my dear, to make it fast, more bullets in less time, we have applied critical damping to the rifles. AK-47 for the first time was made with critical damping. With that, we have increased the speed of the bullet in such a way that within 2.5 minutes, we are able to fire around 1850 bullets. This is a rough data. This was at that time we achieved. Now obviously we have achieved much. So this is the beauty. This is the beauty of critical damped system. Okay, I feel everybody got it. But in critical damped system also there is no to and fro motion. In both overdamping and critical damping, the difference is of the response time. And second thing, only one side motion is there. So in both overdamped and critical damped vibrations, I will say no vibrations happening. So in both the systems, vibrations are not there, so they are not very important for exam point of view. For exam point of view, the more important would be underdamping. This is once again critical damping. Now we are talking about underdamping when zeta is less than 1. So guys, when we are talking about zeta less than 1, this is a very, very important. This is the underdamped system. And when we are talking about underdamped system, we are saying zeta less than 1. And this time, if you are going to find out alpha 1, 2, it is minus zeta omega n plus minus square root of. So here it was zeta square minus 1. है ना? And we were having, let us take this omega n outside. So what we have done here, you know, zeta is less than 1, zeta square is also less than 1. Less than 1 minus 1 will be a negative quantity. Negative quantity means square root of minus 1 is iota. Square root of minus 1 is iota. So we would be having the complex number. So better we explain it in this way. Minus zeta plus minus. If we take square root of minus 1 common, it would become 1 minus zeta square. This is iota. So we are going to have alpha 1, 2 as minus zeta plus minus. Okay. So what we have done, this is the case. Omega n. Okay. So when we are going to do this type of thing, this time once again alpha 1 is not equals to alpha 2. So we would be once again having the same formula, x is equals to a e to the power alpha 1t plus b e to the power alpha 2t. Now you know e to the power iota theta is given as cos theta plus iota sin theta. You can have plus minus, plus minus. So theta here, okay. Now when you will be putting this, value, you will be getting this kind of thing. So this was the alpha 1 comma 2. You have taken iota common, and this term which is coming again and again, 1 minus zeta square into omega n, we will be calling it as omega d. Omega d is said to be the damped frequency of vibration. This is the formula number 3 from which GATE is asking the question. So we have seen the formula for zeta, the formula for degree of dampness, and this is the formula for omega d, the damped frequency of vibration. So one by one we are looking all the formulas. When you will be putting it in this, you would be getting x is equals to e to the power minus zeta omega nt into yes, a will be there, sine omega dt plus phi. So this is what we are getting. This is what we are getting as the result of underdamped system. So this is the governing equation of underdamped system. If you see this equation, this says a lot. Because, okay, definitely. Aditya, this is the previous slide. I have used these things. Yes. Wonderful, guys. So after completion of vibration, we will start the topic governors, cams, balancing, gears, gyroscope. Okay. They will not take much time, don't worry. Okay, moving further. So guys, this equation says a lot. This equation says a lot. X e to the power, this equation says a lot. My dear, generally we write x is equals to r sine omega t. Then when we are going to plot this equation, what is the procedure? We will make the x-axis. We will make one line which will represent the positive amplitude. Another line will represent the negative amplitude. And we are going to plot the sine curve between these two. So here, if you are going to compare, this also is sine curve. The difference is, here amplitude is a into e to the power minus zeta omega nt. So we can see here amplitude is negative exponential. So here amplitude will reduce with time. That is for sure. Okay. Yes. So guys, Sonu sir is there to motivate you. So get motivated, because you can see all the faculties all the time are available for you. We are all the time just looking at how your preparations are going on. Okay. So guys, when we are having this kind of solution, this is a negative exponential amplitude, means amplitude is reduces with the time. Sine is showing the harmonic function. So my dear, presence of vibration is given by this sine cos term. In overdamped system, there was no sine, no cos. You have seen that. In critically damped system, there was no sine, no cos. You have seen that. No vibration. In underdamped system, sine terms came. It means vibrations are there. But previously vibrations were with omega. This time vibrations are with omega d. What is omega d? Damped frequency. So first thing, vibrations are present. Second thing, they are present with the damped frequency. Third thing, you can see this angle phi. Okay, so because of that there will be a phase difference also. So if I am going to plot this graphically, how this damped vibration would be shown. So I would be having y-axis and x-axis. First I will make negative exponential amplitude like this. Negative exponential amplitude like this. Then in between that, I would be running a sine curve with some phase difference. So this is the sine curve with some phase difference. So you can see, my dear, this is how the vibrations are going on. This equation, which we were writing plus r, this would be plus a e to the power minus zeta omega nt. This would be minus r, means minus a e to the power minus zeta omega nt. This is how we are going to show. So amplitude is reducing like this. And my dear, we would be having this amplitude is, let us say, x0. This would be x1. This would be x2. So likewise, the amplitudes are reducing. So obviously, after some time, vibrations will become zero. So after some time, vibrations will become zero. Is it clear? So when the vibrations will become zero, it means after some time, vibrations will not be there in the system. So guys, in the damped system, we have seen that. First of all, in overdamped system, vibrations were not present. In critically damped system, vibrations were not present. In underdamped system, vibrations are there, but they will die out after some time. So up to this, we have not seen vibration is really a problem. But in forced damped vibration, we will prove that vibrations will always be present in the running systems. So please tell me, up to this, everything is clear to you or not? Is it clear, guys? Wonderful, wonderful, guys. Moving further. So this is the diagram we have seen. Now, my dear, we would be talking about, now we will be talking about the decremental ratio. Now we will be talking about the decremental ratio. You know that initially amplitude was x0, x1, x2, x3, x4, like that. So every time amplitude is getting reduced. So the ratio of amplitude in consecutive cycles, this is said to be decremental ratio. And it is found that all are coming out to be equal. We can derive it in the class. I have done it many times. You would be having all of them to be equal. You can write xn minus 1 by xn. And when you find out this ratio, this is coming out to be what? This is coming out to be minus, okay, this is coming out to be zeta, omega and Td. This is coming out to be zeta, omega and Td. Okay. So when you will see all this decremental ratio, this will be coming out to be equals to zeta, omega and Td. E to the power zeta, omega and Td. Yes. Is it correct or not? Please tell me that. Is this correct or not? Please tell me that. Everybody remember this formula or not? How you will be defining x naught? You know x naught is a e to the power minus zeta omega nt into sine omega d t plus phi. When you will be putting t to be 0, you would be getting a e to the power okay, you will be getting a only. When you will be putting first time period, x1 will be coming out to be a e to the power minus zeta omega in one time period Td. So guys, when you would be using this, taking the ratio will give you e zeta omega and Td. So this is the decremental ratio. So decremental ratio we found out. Next term is logarithmic decremental ratio. What is that? You know that x0 by x1 up to xn minus 1 by xn. It is e to the power zeta omega and Td. So if we are going to take log of this decremental ratio, it would be coming out to be zeta, omega and Td. You know, we can write it as zeta, omega n. Td can be written as 2 pi by omega d. So we can write delta as 2 pi zeta omega n divided by, what is Td? 1 minus zeta square into omega n. This is the value of omega d. Omega n will get cancelled out. So you will be getting the logarithmic decremental ratio, that is xn minus 1 by xn is equals to 2 pi zeta divided by 1 minus zeta ka square. Everybody got this or not? I need not to go into derivation. Still I am doing whatever is possible for you guys. So yes Shivam, yes Shivam. So are you asking something? Is it clear? Yes, exponential mein it is clear. So guys, this is clear. This is how the derivation have been coming. Okay, wonderful. So guys, this is the formula number 5. We have done it. First formula we have seen was the zeta. Second was degree of dampness. Third was the formula for what? Formula for what? Formula for what was that? Degree of dampness zeta. What was the next formula we have seen? Omega d. Fourth formula we have seen is decremental ratio. Fifth formula we have seen is logarithmic decremental ratio. So with that we have seen all the formulas. We are coming on to the next one. Very good, very good. Wonderful Sujish, Vineet, बहुत ही बढ़िया. So we have derived it. Now we are coming to the critical damping coefficient. We are at the end of this chapter. Then we will be moving to the force damped vibrations. Then I will tell you something about degree of freedom also for the vibration systems. And then we will enter into the next topic. What is critical damping coefficient? You know that 2m omega n was C. So if this is the equation for damping coefficient of any system, if we have critical damping, for critical damping zeta is said to be 1, C will become Cc. So I will say 2m. I have written wrongly, I feel so. Just wait. I am writing the value of zeta. Okay. Zeta is given as C by 2m omega n. So we can write C is equals to 2 zeta m omega n. So my dear, if critical damping is there, Cc will become 2m omega n. When you will be taking the ratio of this, C by Cc will be equals to m will get cancelled out, omega n, 2 will get cancelled out. This is coming out to be zeta. So now my dear, we have done many derivation taking zeta into consideration, and now we get to know that zeta is nothing but the ratio of damping coefficient to the critical damping coefficient. If zeta is the ratio of damping to critical damping coefficient, what do you mean by that? You were writing zeta to be what? C by 2 root km. So you can say Cc is 2 root km. Many times they would be asking you Cc. This is the formula number 6 which would be utilized in the questions. So these 6 formulas you will see again while solving the questions. So guys, if you know these 6 formulas, if you don't know anything about the vibration, then also you would be able to solve the questions. That is the beauty in damped vibration system. Questions are coming generally formula based. One type of question is more there which is not formula based, that I am telling you. Please tell me up to this everybody got it or not. So I am writing all the 6 formulas onto one slide for your better revision. Okay. I am writing it. First we are having zeta is equals to C by 2m by omega n. Then we have seen degree of dampness C by 2m square omega n square. Omega d is 1 minus zeta square into omega n. Fourth one is critical damping is 2 root mk. Fifth one is logarithmic decremental ratio is 2 pi zeta 1 minus zeta square. Decremental ratio is e to the power zeta omega n td. Okay, and you can also write zeta to be C by Cc. Is it clear for everyone? Okay. No issues, Vineet. You can go through the recording after that. So with this, we have seen all the formulas of the damped vibration system. Now you can solve this question. The equation of motion for a damped viscous vibration. This is the equation. So you know that mx double dot plus cx dot plus sx is equals to 0. You need to find out the damping factor. You know, damping factor is given as C by 2 root SM. SM or KM, you can use anything. Okay. So just tell me the answer for this question. As I said, we will see some 2-3 questions in between. And after that, if time is remaining, we will see some very good questions. In the cases, I am covering majority of the things. Yes, tell me guys. Sujit is saying answer to be B. Okay, what about others? What about others? Midun is also saying B. Teju is also saying B. बहुत बढ़िया. Malesh, Kartikeya, Manas, Ajay, Shreyas. Very good guys. बहुत ही बढ़िया. The answer will be B for this. Shivam, have you done it? Very good, Aditya. बहुत बढ़िया. So guys, moving further, we have many such questions. Now we are entering into force damped vibration systems. But before we go into force damped vibration system, I would also like to tell you, sometimes they can give you this type of question also. They will say this is the road. This is the road. And in this road, this is having a mass of m, length of L. Obviously, its centroid would be coming somewhere here at L by 2. Okay. We are having a spring that is at a distance of A from the hinge point. We will be having a damper at a distance of B from the hinge point. This is the hinge point. So my dear, if you see that, this is the line. Like this. So clearly, if damper is present, you can say this is the question from damped vibration system. There is no doubt about that. There should not be any doubt about that. But they can ask you two types of question here. First, they can ask you about the governing equation. No, 2-3 types of question. They can ask you the natural frequency. They can also ask you the critical damping, damping coefficient, equivalent damping coefficient. These 3 types of questions they can ask you from this, and this is the only case where you cannot go with the formulas. This is a combination of techniques like we have seen in the natural vibration. That you have seen there because of damper, energy method not applicable, Rayleigh method not applicable. It is the rotational kind of thing, so we will go for torque method. So you know, for torque method we will give some displacement by theta. If this is displaced by theta, center of mass will go like this, and you know weight will be acting downward. Okay, so if weight will be acting downward, mg will be the component. You know, this is mg cos theta, this is mg sin theta. So restoring force will be mg sin theta. So restoring torque will be coming out to be mg L by 2 into sin theta. This is first restoring torque. The second restoring torque will be coming because of spring. This is getting displaced by A into theta. So there will be a force developed S into A into theta. So restoring torque will be S into A square into theta. Then third force will be coming from damper. This is B into theta dot. So this time it will be coming the restoring torque C B square theta dot. You know, force into perpendicular distance is the torque. Now if I would be adding one more thing to this, system will become worse if I will put a torsional spring there with a stiffness of K theta. Then you would be having one more restoring torque, that is K theta into theta. Not more than that is possible. I have added everything into this system, my dear. So now you know I will be adding the D'Alembert's force or torque I theta double dot. So you would be writing the equation to be I theta double dot plus CB square theta dot plus S theta plus SA square plus MGL by 2, because sine theta will become theta. Theta is equal to 0. This is the governing equation. This is the governing equation. Generally, you would be writing the governing equation to be I theta double dot plus C theta dot plus S theta is equal to 0. So my dear, from that, as this is our equation, this is equivalent equation. So I will put IE, CE, okay, SE. So if that is the case, you can write down the equivalent damping coefficient will be CB square and natural frequency of the system will be, this is S theta plus SA square plus MGL by 2 divided by I. This is how the answer will be. Now I would be taken about the axis of rotation. So I about this axis is ml square by 3. You know that if we take a rod, then about the centroidal axis it is ml square by 12. About this axis it is ml square by 3. You can also find out using parallel axis theorem. So ml square upon 3 would be the value of I. This type of case can also come to you. If the same rod is given in the horizontal case, then weight will not come into picture because weight would be initially balanced. I feel everybody would be aware of all these things. With this, we have completed the damped vibration system. Please tell me if you have any doubt, then we will move further. With this, we have completed the damped vibrations also. So in 2 hours, we have done 2 types of vibrations. So I am damn sure that we would be completing vibration by 1, okay? And then with one more topic, we will go for the lunch break, okay? Tell me that. Wonderful, guys. So we are running with very good speed. Now we are talking about the force damped vibration systems. So when we are talking about force damped vibration system, very good, Midhun. When we are talking about the force damped vibration system, my dear, then we would be having one thing extra, that is the unbalanced force. So we would be having spring force, damper force and unbalanced force. And obviously this is the D'Alembert force, which will be saying that add my component equated to 0, you will get the equation of Newton. So the point is from where these unbalanced forces are coming. So my dear, unbalanced forces can come from 2 places. One is from the rotating component, other is from the reciprocating components. So when we have a rotor like this is the shaft, this is the rotor, okay? But let us say for the disc, the center of mass is not lying at centroid, this is lying at a distance of E eccentricity. So you will be having a force me omega square, and as this shaft will rotate, this force will also be rotating like this. So the direction of the force will change with time. So those forces whose direction is changing with the time, they are said to be fatigue loading. Okay, so this is a type of fatigue load. Such type of loads are always create vibrations. Then my dear, second is reciprocating masses. Second is reciprocation masses. If we have this block like this, if that is the case, my dear, then you know we have already seen the acceleration of the piston is r omega square cos theta plus cos 2 theta by n. You know that theta is the function of time, theta is crank rotation, theta is a function of time. So you know that here also the force on the piston, which is inertia force, this is mr omega square into cos theta plus cos 2 theta by n. So my dear, here if you will see that this force is a function of theta. So as magnitude is changing with the time, So my dear, vibration comes into picture if force is changing in magnitude or direction. So either because of such or because of such things in the system, unbalanced forces are coming into this. So generally these unbalanced forces are changing with magnitude and direction. So their magnitudes are also variable, directions are also variable like that. So in that case, obviously there will also be some functions of harmonic like sine or cos. So that is why we have taken f naught sine omega t. So this time the equation will be mx double dot plus cx dot plus sx is minus f naught sine omega t. This was the force. So as this force sine omega t, this omega is neither natural frequency nor damped frequency, because this is the rotation of shaft. This is the rotation of crank. It has nothing to do with the system vibration right now. It is neither natural frequency nor damped frequency. This is said to be the forced frequency. External frequency, you will equate it to 0 and your equation will be coming out to be mx double dot plus cx dot plus sx is equals to f naught sine omega t. Then you would be dividing it by mass and you will get the same equation like this. Why? Because you already know c by m is 2 zeta omega n and k by m is omega n ka square. Putting these in the equation, you will get the governing equation of forced damped vibration system. Governing equation of forced damped vibration system. Sir, if the cylinder is horizontal while calculation piston effort, no need to take gravitational force. Yes, it is correct. So guys, moving further, we got the governing equation. This time the solution, when you will be calculating, this time solution will be having two terms, CF plus PI. Because when we have the equation like x double dot plus 2 zeta omega n x plus omega n square x, when this is not equals to 0, then we have CF plus PI. And when it is equals to 0, x double dot plus 2 zeta omega n plus omega n square x is equals to 0, then we have the solution as x is equals to CF. So this equation we have already seen in the damped vibration system. So it means CF we need not to calculate again. We can use the same, CF means complementary functions. We can use the same complementary functions as we have seen in the damped vibration system. You know, there were overdamped, critical damped and underdamped. There was no vibration in overdamped and critical damped. So we need to consider the case of underdamped because their vibrations were there. So for critical damped, we have derived the CF value to be a e to the power minus zeta omega nt into sine omega dt plus phi. This is the value of complementary functions. Now we are going to talk about the particular integral. Particular integral is defined as, first of all, you will write right hand side and in the denominator you will put an equation for that. X double dot will be d square, x dot will be d, x is equals to 1. For that we need to go for it. Okay, so that is why we would be keeping this equation. Is it clear? Yes, yes, yes. So Abhinav Negi sir is also in the comment section. So sir is informing about two things. That one is about engineering mechanics marathon. So guys, me, Abhinav Negi sir and Sonu Chauhan sir, together we are going to take marathon of engineering mechanics because many of you have requested for that. Sir, in the marathon list, engineering mechanics is not there. So we are having it because it is having more weightage for mechanical students also. So we are coming for that. It would be common for civil and mechanical, and Abhinav sir, me and Sonu sir will be coming. And many students were asking, sir, there are so many PYQs. Shall we go for all the PYQs? So dear, the answer is no, because all the PYQs you have done a lot of time. This time we are coming for a PYQ session where we will cover 51 PYQs, where me and Abhinav sir would be there. And those PYQs are not only from mechanical or civil. They will be from mechanical, civil and XC. So from 3 branches we are going to be there with 51 best PYQs. Okay. So be ready for that session. Okay. So that will be a very good practice. And these sessions would be there on Monday, Tuesday, Okay, so that soon we can go for the new series. Marathons would be over, and Tuesday or Wednesday I will also take material science marathon. So everything we are covering. Anything, if you still feel that that is not covered, please tell, we can go for it. Okay, so let us move further. So guys, we have already calculated the CF. Now we are going for the calculation of particular integrals. So when we are talking about particular integrals, we are just putting this into the equation, putting it into the denominator. After solving, we will be having particular integral like this. I am writing it on the next slide. So what we are getting PI as? We are getting the PI like this. So my dear, the real solution for X is CF plus PI. But we have seen in the damped vibration system that complementary functions are becoming zero after some time. After some time, complementary function will become zero. So after some time, CF will become zero. So we need not to worry up to this time, because if we are having only CF, after some time vibrations will not be the part of system. So we need not to worry about that. What after that? After that we will left with only PI. What is PI? X is equals to PI, that is equals to F naught upon K into sine omega t minus phi divided by 1 minus r square ka square plus 2 zeta r ka whole square. Here r is omega by omega n. Because it is coming again and again, I have made it short. So my dear, we can further see this, what it want to say. In this solution, where X is left with only particular integral, the presence of harmonic function gives the guarantee of vibrations. This sine function says vibrations are present. Then my dear, if you see this omega, this says this time vibrations are not with omega n, they are not with omega d, neither they are with natural frequency nor they are with damped frequency, they are present with forced frequency. So vibrations are present with a frequency which is neither natural nor damped, but it is forced frequency. Advait, I feel we have already done a MSQ series. MSQ series is already done, we have done it. Okay, you can go for it, or otherwise also whenever we are coming with practice sessions, we are keeping MSQs in between. Even for mock test we will keep some MSQs, so don't worry about that. Okay, so we have done it. And my dear, if you see this thing, F naught is constant, stiffness is constant, R is constant, so this can be treated as a constant. So from now we can write X is equals to A sine omega t minus phi. This is the equation of solution of the forced vibration system, where amplitude is given by F naught by K, 1 minus R square ka square plus 2 zeta R ka whole square. So guys, up to this point, whatever we have seen, the important takeaway was the first formula, that is amplitude of forced vibration. This is the first formula. I told you na, in damped vibration and forced damped vibration we have some formulas and we just need to remember them and our work will be okay with that. So this is the first formula we have derived for this. Okay, S is the stiffness here. Very good. Teju, there are some, you can say MSQ sessions were there, if you will see, and even in the 500 plus I have taken MSQs in between, and also in the upcoming mock test. First mock test is there around 20th of January, second at 26th of January, third we would be having around 31st of January. So there are 3 mock tests before exam. There also we will keep the MSQs. Okay, so if you want, we can have one session where pure MSQs would be there. We will take top 50 MSQ for entire mechanical engineering. Okay, we will have one more session. So guys, this is the amplitude of the forced vibration system. This is the amplitude of the forced vibration system. I feel everybody is clear about this. Amplitude of forced vibration system. Now we are moving to the second thing, that is magnification factor. Here we are going to derive the second formula. First of all, we need to understand what is the magnification factor. So my dear, if we have a spring like this, on this if I apply a force F naught, you know that there would be some displacement which is F naught by K. It can also be written as static deflection, F naught by K. And my dear, on the other hand, when we are going to have a forced damped vibration system where we have all the four things: stiffness, damping coefficient, mass and unbalanced force, there we are finding out amplitude of vibration to be F naught by K divided by 1 minus R ka square plus 2 zeta R ka whole square. So my dear, you can see these are two amplitudes actually. And if I take the amplitude of forced damped vibration in the numerator, and if I take this displacement or static deflection in denominator, this ratio is said to be magnification factor. Actually, this ratio wants to tell how bad this is when compared to this. How bad this amplitude is, how big this amplitude is with respect to this static deflection. So this is said to be the magnification factor, my dear. This is said to be the magnification factor. This is the formula number 2 you need to remember. And generally GATE is asking from the formula only, okay? That is why I said you need to remember the formula. But in engineering services they are asking from the curve. Now GATE is also trying to ask from the curve. If we want to see the magnification factor, it is coming out to be what? It would be coming out to be 1 by 1 minus R square ka square plus, okay, let me correct it. It is coming out to be this 1 minus R square ka square plus 2 zeta R ka square. This is the formula for magnification factor. Okay, this is the formula for magnification factor. If you see this magnification factor, my dear, this is a function of R and zeta. It is a function of R and zeta. So when we are going to make a curve between the magnification factor with respect to R for all values of zeta, then you will be getting this type of curve. My dear, this is not a function we have seen in the graph how to plot it, but we can verify this curve, and there are only two such curves. We need not to learn how these curves are plotted. We can just verify this. You can see one thing: if R is becoming 1 and zeta is becoming 0, if R is becoming 1, zeta is becoming 0, you can understand magnification factor will become infinity. And if you are going to put R to be equals to 0, then whatever be the value of zeta, magnification factor will be coming out to be 1. It means every curve will be starting from this point. So every curve will be starting from this point when magnification factor is 1. So the curve is coming like this for zeta is equals to 0. And as you know, as the zeta would be increased, obviously denominator will increase, numerator will reduce. So that is why this would be the curve when zeta is increased. When you will increase the zeta, the curve will be coming like this. Okay, and finally this. So this is how the effect of zeta will be there. So this is for zeta 0, this is for zeta 0.25, this is for zeta 0.5, this is for zeta 0.75, and this is for zeta more than equals to 1. Okay, more than equals to 1. Got it, guys? So when you see this curve, you can feel it that magnification factor is less than 1 for this curve always. And as zeta is going to be increased, magnification factor will get reduced, and it is coming maximum much before when r is equals to 1. So my dear, r is equals to omega by omega n. You can say that r is omega by omega n. Then r will be less than 1 for magnification factor to be maximum when we have zeta other than 0 values. This question also have been there in the paper. What is that peak point represent? It is moving left with zeta increases. Yes, that's what I said. So as you are increasing the zeta, this maximum point is shifting to the left hand side. This type of question have already been there in the GATE examination. So it simply says that one more thing, the magnitude is also reducing. So if zeta is increasing, magnification factor will reduce. So more zeta is preferable when we are looking for less magnification factor. And yes, we want less magnification factor, because if magnification factor will be more, amplitude of vibration will be more, life will be less. Okay. So moving further, guys. Now we are talking about the vibrations isolation. So before we go for vibration isolation, we will be going for phase diagram or phasor. Phase diagram or phasor. You know that we have written the equation mx double dot plus cx dot plus sx minus f naught sine omega t minus phi is equals to 0. This was the equation. Okay. And you know, this is a kind of 4 forces only. So summation of these 4 forces is 0. That is actually written. Okay. So my dear, when we are talking about this, you know what is x for us. What is x for us? We have just defined it. A sine omega t minus phi. This is the value of x we have derived. When you will see x dot, it would be coming out to be a omega cos omega t minus phi, or we can write a omega sine 90 plus omega t minus phi. Then if we are going for x double dot, it would be a omega square cos. It would be cos. Okay, when you are differentiating this, cos ka differentiation is going to be minus sine. So we are going to have it as minus a omega square sine omega t minus phi. Is it clear for everyone? So we just need to put these values. We need to put the value of x double dot, x dot and x. When you will be putting all these value in the terms of sine only, you would be getting it. You would be getting m minus a omega square sine omega t minus phi plus c a omega sine 90 plus omega t minus phi, then plus s a sine omega t minus phi, then minus f naught sine omega t minus phi. Everywhere we are having the sine functions. Okay. So if we are going to write it, we can also write it in this way: f naught sine omega t minus phi. Then f naught sine omega t minus phi will go on the other side. Then this will also become ma omega square. Actually, this was not omega t minus phi. This was omega t only. Am I correct? Yes, Teju and everyone, Malesh, am I correct? This was only omega t. None of you said, hey, sir will see. Tell me, am I correct or not? Yes, yes, yes. Great. Gunamani Sahu, very good. Is it clear for everyone? Wonderful, guys. So when you are having this ma omega square sine, so this is not minus phi, this is omega t. I am writing it again. F naught sine omega t. Nowhere with the f naught it will be coming. F naught sine omega t minus will become plus ma omega square sine omega t minus phi. Both these terms will be positive. These two positive will become negative. Ca omega sine 90 plus omega t minus phi. Then minus Sa sine omega t minus phi. Now there are four forces. We have shown it. The heading is phase diagram or phasor. We have not yet plotted the phase diagram or phasor. Phase diagram or phasor is a diagram which is showing all the forces with the angles they are making, okay, in a coordinate system. So if I want to go for it, I need to define a coordinate system. And I am showing every force with the amplitude, and angle will be made in anti-clockwise direction with the x-axis. So we can show F naught sine omega t like this. F naught, it is making an angle of omega t. Similarly, if I want to make the other force, it would be like this. Ma omega square, this is making the angle omega t minus phi. We have made two forces, other two forces. You know, next force, this is 90 plus omega t minus phi. 90 plus means what? It would be going 90 plus then omega t minus phi. 90 plus. But because of minus sign, it will be coming in this direction. Ca omega. Angle is 90 degree with this. Then Sa is opposite to ma omega square. Why? Because Sa is having minus sign. Angle is same as that of omega t minus phi. So you would be having this direction, Sa, 90 degree. So what is the output of this diagram, phase diagram or phasor? Inertia and very good, very good, very good. The output is damper force and spring force are perpendicular. First, what is second point? Ma omega square and Sa, they are making an angle of 180 degree, just opposite. So here we get to know that they are having 90 degree phase difference. Means if this is the direction of damping force, then spring force will be like this. And if that is the case, if I want to write the resultant of these two, it is going to be F damper ka square plus F SP ka square. This is what I want to tell you. Now we are talking about the vibration isolations. What are these? So my dear, you must have seen whenever we are having very heavy machineries, we are not keeping those heavy machineries. You know, for that I always tell you a story. But as I said, now we are revising in the marathon. So in marathon you cannot expect what? You cannot expect, my dear, the stories. Okay, so here stories are absent, rest everything we are discussing. Other than story, everything we are discussing. So let us say, my dear, how I told you that, I am telling you that. Just an idea. If this is Earth's surface, we have a machine like this. And this is your home, sweet home. Some person is running his generator day night that generator is running, or some heavy machinery is running, that will be transferring the vibrations to the earth, and then earth will be transferring the vibration to your home. So without having any motion, still your home will be feeling the vibrations. So you are not having any motion inside the system, but still you are feeling the vibrations. So because of this, the life of your home will reduce. Because of this, the life of your home is going to be reduced. So my dear, because of that, we wanted to reduce the effect of these vibration forces which are going to the earth. So my dear, vibration isolations are required to save the bodies from the vibrations of other machines. No doubt, if I am having any rotating component, if I am having any reciprocating component, no doubt vibrations will be coming, and that I cannot stop. And because of that, my life will also be affecting, that I cannot stop. But my dear, vibrations coming because of other bodies shall be stopped. Because if someone is going to die because of his bad thing, it's fine. If one person is taking tobacco, you know that tobacco can cause cancer. If one person is smoking a lot, he know that he is taking that every day in, and it is mentioned that this can cause cancer. If he got cancer, yes, definitely he was doing that. But if you are just taking that output without any reason, so my dear, then if you got that kind of thing, you will feel bad, because it was not your problem actually. You were not smoking, so neither you have taken enjoy at that time. Now you are also suffering. Is it clear? So what I want to say, okay, Aditya, just give me a minute. Just give me a minute for that. Yes. Huh. So guys, you need to avoid that. Now is it fine? Just wait. I feel light is slightly lesser. Fine. Okay, Teju, I am showing you that. You can see this. Then we are moving further. You can see the formula. Okay. Shall we move on now, guys? Shall we move on now? Wonderful. Very good, Midun. So let's move on, guys. Let's move on. So we were saying that why we need the vibration isolation. So if this is a machine, okay, and we have our surface like this, then machine is transmitting this force directly to the surface. But what if we have a vibration isolation below this machine, and then we have the earth surface? Then what will happen, guys? For this case, machine is transferring the force to isolation, isolation is transferring the force to the earth surface. So my dear, when we are talking about this vibration isolation, now the force transmitting to the isolation was F0, but force transmitting to the isolation was Ft. So we want Ft should be 0. If Ft is 0, we will say this isolation is perfect one. But generally Ft is not 0. So we are defining the transmissibility ratio, which is defined as the transmitted force to the upcoming original force. This ratio we are saying as transmissibility ratio. The ideal value for this transmissibility ratio is 0. This is the ideal value, but it should always be less than 1. At the worst condition, it can be equals to 1. But if transmissibility ratio is coming out to be more than 1, then no need for it. No need to go for vibration isolation. That is very, very important point. So we will be using vibration isolation only for the condition when transmissibility ratio is coming out to be less than 1. So guys, do like and share the session. After vibration, we have a lot of the chapters to come. Is it clear for everyone? Shall we move on now? Yes. If you're finding any lighting issue, don't worry. In the break, we will correct it. Don't worry for that. Let us move further. So guys, now you already know that transmitted force. For that, if we go for it, first of all, I would like to know which material is best for vibration isolation. Which material is best for vibration isolation? What do you feel? Which material is best for vibration isolation? Okay. Which material is best for vibration isolation? Okay. So guys, I also told you many times, rubber is the best material for vibration isolation. Okay. Rubber is the best material. Why? My dear, anywhere, wherever you see, generally students are saying either cast iron or they are saying about the concrete. Because generally they say foundations made up of concrete. But guys, if you will see those concrete isolations or foundations also, you will find they are adding rubber powders to that. If you see our keypad of your laptop, there you know every time you are applying the forces which are going to be fatigue ones. So for that also, my dear, we are going to provide, vibrations are coming. For that also we are using the rubber padding there. In the wheels of the car we are using rubber. My dear, in the clamps of exhaust fan we are using rubber. In the shoes which are having rubber soles are more comfortable. So everywhere we are using the rubber wherever it is possible. But why under the heavy machinery we do not see the rubber? Actually, in concrete also they add rubber powder. So best material is rubber only, no doubt about that. If you see the mobile keypad, rubber is there. So everywhere we are using rubber wherever it is possible. But my dear, rubber is not able to withstand heavy loads. So when we are having heavy machinery, if you are going to keep rubber there, it would not be capable of bearing that kind of load. So because of that reason, my dear, for such cases we can go for cast iron, because they are capable of bearing the loads also, and they have excellent vibration absorbing capacity also. So that is why in the production, whenever you are going for jigs and fixtures, so all these jigs and fixtures, whenever we are going to make, we are using cast iron rather than rubber, because rubber will not be able to resist those forces. So that is the reason behind that. I feel everybody got it now. So you know that whenever we are going to apply this, there are two types of vibration isolation. One types of vibration isolations are said to be external one. Second are said to be internal ones. External one means like you are having some machine and that machine is kept on some foundation. That is vibration isolation. This is the external one. Internal one means like lathe. You know that on lathe the moving components are chuck, which is rotating. There are tool slides on which tool is moving like that, and you are having this lathe bed. So you can see lathe bed is this. So rotating and reciprocating components are at the top. So when they are going to transfer the vibration first of all to the lathe bed, then lathe bed is acting like internal vibration isolation. Then lathe bed would be transferring to the earth or to the external vibration isolation. So we are going to talk about majorly of internal vibration isolation. So that is why for internal vibration isolation, we would be having system like this. So any vibration isolation can be denoted by a spring and a damper, because majorly vibration systems are having this much only. And let us say unbalanced forces are coming like this. This is unbalanced force. So this is the case of internal vibration. This stiffness and damping coefficient are showing you the lathe bed. Okay, you can take like that example. So if we have that, my dear, for this system, you know, transmitted force will be transferred with the help of spring and damper to the earth. And you know, both the forces are perpendicular to each other. In the phase diagram, we have seen both damping force and both damping force and spring force are at an angle of 90 degree to each other. If they are at 90 degree to each other, transmitted force will be coming out to be what? Ca omega ka square plus S into A ka square. This is said to be the transmitted force. And my dear, if you want to find out the F naught, you know amplitude is defined as F naught by S square root of 1 minus R square ka square plus 2 zeta R ka whole square. So from that you can find out the value of F naught, that is SA square root of 1 minus R square plus 2 zeta R ka square. You need to take the ratio of these two, but before that I would like to convert FT into some other format, and that we can do very easily. You know that we can write it 1 plus SA by M CA omega by M. I have made this kind of divisions because amplitude will get cancelled out. S by M is omega n and C by M is 2 zeta omega n. So my dear, if I am going to do this, we can find out Ft to be equals to, it is coming out to be 1 plus 2 zeta R ka whole square. Okay, I feel I have done opposite to that. I must do it in this way. I must do it in this way. You got it. We will be writing it in this way. 1 plus CA omega upon SA ka square. And then I will be dividing both numerator and denominator by M. Then C by M into omega. This will become 2 zeta omega omega n, and S by M will become omega n ka square. Then the ratio of this, and you would be taking the square of this. It would be coming out to be 2 zeta R ka square. This is the value of transmitted force. So Ft is this, F naught is this. And you have taken actually SA to be common. You have taken SA to be common, because you have divided it with the SA. Is it clear for everyone? So we got both the forces now. I am showing it on to the next slide once again if you want. So we got two forces. Transmitted forces SA into 1 plus 2 zeta R ka whole square, and F naught is equals to what? F naught is SA into 1 minus R square ka square plus 2 zeta R ka whole square. And when you will be taking the ratio of these two, then transmitted force by F naught is nothing but transmissibility ratio. So it would be coming out to be 1 plus 2 zeta R ka whole square root of 1 minus R square ka whole square plus 2 zeta R ka whole square. This is the formula for transmissibility ratio. Please tell me guys, everybody got it or not? Very good, very good, very good guys. Just like and share the session so that we can move further with more and more students to join. This will help everyone because vibrations are very, very important topic. You can see how in the machines we are having the isolations connected like that. This is one more example. You can see this. These all are isolations. Okay, I feel you got the idea. You can see this. These foundations are isolations only. These all are the examples of isolation. So we have derived the formula for transmissibility ratio. Wonderful guys. So we have derived the formula for transmissibility ratio. I was having old derivation, but still I have done it for you. So finally we got the next formula, transmissibility ratio. For gate you need to remember the formula only, but nowadays they are coming to the graph also, and engineering services also asking the graph. So we are going for graph also. So my dear, if you see this type of function, we have never plotted the graph. So we need not to learn about that. We will just verify the curve. Okay. How we will verify, I am telling you that in the next slide. So when you would be making the curve this time, you will say the same thing like we have said before, that transmissibility ratio is the function of R and zeta. So because of this, we will be plotting a curve between transmissibility ratio and R for all the values of zeta. for all the values of zeta. Okay, so my dear, when we are talking about transmissibility ratio, we have seen the formula before. When you will be putting the value of R to be 0, you will get transmissibility ratio to be 1. When you will be putting R to be √2, you will get transmissibility ratio to be 1 for any value of zeta. Whatever be the zeta value, you will get at these two values, the zeta will remain. Anything, you will get transmissibility ratio to be 1 only. So whatever be the value of zeta, for R is equals to 0 and for R is equals to √2, it is always going to pass from these 2 points. So when you will start plotting the curve for various value of zeta, you will be getting the first curve for zeta 0. It would be coming like this. White is for zeta 0. When you will increase the value of zeta, no doubt about that, curve will be going from downwards. But you will feel after this point, it will be going from upward. So this curve is for zeta is equals to 0.3. Now let us say we are making for more increase in zeta. This will be coming like this. Like this. If I am going to make another curve, then you will be having this one. Okay. And even if you will take zeta more than 1, zeta more than equals to 1, then also it has to pass from these 2 points. This will be the case. So Z1 is for zeta more than equals to 1. And if you are going for other colors, green one is for zeta 0.85 and this one is for zeta 0.35 and this one is for zeta is 0. So my dear, first of all, I would like to tell you that we must be aware that we will not be using any vibration isolation if zeta is, if transmissibility ratio is coming more than 1. So you can see transmissibility ratio is less than 1 only after this √2 value. So we will be applying vibration isolation only for this case. So this is our operating region. This is our operating region. Okay, so my dear, we will be applying the vibration isolation only when omega is going to be more than √2 times of omega n. So they can ask you one question, vibration isolation will be applied if omega is equals to, they will give you the value of omega n. So they can ask you this question. So this is the first kind of thing. Then my dear, if you are talking about the operating range, can you see, can you feel one thing here? Can you feel one thing here? That this is zeta is equals to 0. This is zeta is equals to more than equals to 1. So as zeta value we are increasing, transmissibility ratio also increases. If I take some value of transmissibility ratio, you can see transmissibility ratio for that you have taken this value. You can see when we are going to have a vertical curve, for zeta 0 we have minimum transmissibility ratio and for zeta 1 we have maximum transmissibility ratio. It means in the operating range, zeta should be as low as possible, because in the operating range if zeta is going to be lesser, transmissibility ratio will be lesser. So my dear, 2 points we are getting here. First of all, operating range is after √2. Second thing, in the operating range zeta should be as low as possible, because more zeta will give you more transmissibility ratio. So if we are going to talk in terms of the value of zeta, let me see that after the question. Okay, here if we are talking about in terms of zeta, okay, not in terms of zeta, in terms of R, if we have R to be less than √2, then zeta should be more and vibration isolation should be avoided. Okay, should be avoided. This is the first thing. Then if we have R is equals to root 2, then my dear, whatever be the thing, you will be having transmissibility ratio will be 1. If R is more than root 2 means operating range, zeta should be as low as possible. But we have seen when zeta is more, magnification factor is less, but transmissibility ratio is more. So we need to make a balance between them. We need to consider such value that isolations will also be effective, and on the other hand, magnification factor shall also be lesser. Is it clear for everyone? Please tell me that. Then we will move further. You can solve this question now. This is the question for you guys. Let us see how many of you give right answer for this. Solve this question, guys. Solve this question, guys. Solve this question, guys. This question is asking about C and D. Which force is C? Which force is D? This is F naught. This is obviously ma omega square. Which one is correct? Elastic force and spring force are the same things. Elastic force and spring force are the same things. Just solve it, guys. Yes, Midun, Ajay. Okay, Advait is saying the answer to be D. Aditya is saying the answer to be C. Ajay is saying the answer to be C. Okay. So you know that elastic force means spring force and ma omega square are at an angle of 180 degree. So this is SA, this is CA omega. Okay. So when he is asking C and D, C for CA omega and D for elastic force. If you see this, D is correct, na? Spring force, sorry, damping force and elastic force. D is right answer. C is not correct. Okay, TPM. Wonderful, guys. Is it clear? Okay, let's move further, guys. So now we have seen this all. We are left with one more thing, that is critical speed of shaft. Let us see two more things: critical speed of shaft, and also the degree of freedom. Okay, then we will be going for the next thing. Wonderful, guys. Wonderful. So we are having critical speed of shaft. Critical speed of shaft. I feel everybody know the formula for that. When we are having omega critical is equals to omega n. Yes or no? It is said to be the critical speed. And for that the formula is coming for eccentricity, I feel so. Sorry, we are finding out the formula for y. That is coming out to be E divided by omega n by omega ka square minus 1. Everybody remember this? This is the formula for deflection. This is the eccentricity. When omega critical will become omega natural, when omega is equals to omega n, for that y will become infinity. So that is said to be critical speed of shaft. I have given you a lot of practical application related to turbines. I also told you many applications related to the laptop computers, but they were for interview prospects. So this Marathon is majorly for the practice revision purpose of your syllabus. So I'm not going on to those stories which I have told you about a newly born baby at that time, and also I have told you about the turbines, fluid machinery concept. Also I told you about laptop computer, that cooling fan, why they are just running fastly and they are coming at rest within very less time. Because if at this critical shaft even for 1 second the system will stay, then my dear system is going to burst. Because at critical speed we are having deflection to be infinity, shaft will broken. Critical speed of shaft is also said to be weeping speed, is also said to be whirling speed. So this is the speed at which shaft will get broken. We never want that kind of fracture or failure. That is why this condition needs to be avoided. And no, Teju, why infinity means deflection is becoming infinity. So like if this is the shaft, if it is deflecting like this, so you have a shaft like this and it is getting deflected like this. So when you will say this deflection to be infinity, when you will say this deflection to be infinity, when this deflection will be infinity, when they will become in two parts, so then it will be infinity. So when the shaft is getting broken into two parts, it will deflect like this. Two parts will be going parallel to each other, so that is why deflection will be infinity. Two parallel lines meets at infinity. Okay, so that is the meaning. So with this we have done it. Now we are coming to the degree of freedom of vibration system. This is the last case of vibrations. After this we will move on to the cams and followers, and then after cams and follower we will have a small break. Then after break we will see governor, gear and gyroscopes. This is how today's class will go on. Be there with me till 5 p.m. Not more than that, I will extend the class. Before 5 p.m. I will leave you like in the machine design we have done it. Okay, so just be with me till that time and we will cover entire part. Okay guys, because it will be a very good revision for all of you, I feel so. So shall we continue guys? Are you ready? Last concept of vibration, then we will be having cams and follower. Tell me that. Bolo bhai, Teju, Malesh, Bhomik, Midun, bahut badhiya. Wonderful guys. So guys, degree of freedom you already know. The types of motions. Degree of freedom is the number of motions. In short form you can say number of motions or number of variables, or number of variables. Either number of motions or number of variables. Is it clear for everyone? So when we are talking about the number of variables or number of motions, if we have a spring mass system like this, you know that here the motion of the system will be in this direction. We will consider degree of freedom will be 1. This can be shown by x. So one variable is required, so degree of freedom will be 1. If we have like this, it can also be shown with one variable theta. So degree of freedom will be 1. If we have a mass like this, this is the spring, this is the spring, then this motion and this motion, degree of freedom will be 2. Similarly, if we have like this is rotated with theta, this is rotated with phi, degree of freedom will be 2. Okay, I have also taken a daily dose on the degree of freedom. If we have a spring, a mass, on this we have a thread and a ball, then 1 degree of freedom for this, other degree of freedom for this, degree of freedom will be 2. Okay, if we have a mass, one spring, two spring, third spring, degree of freedom will be 3. So this is how the degrees of freedom are going to vary, guys. Okay. So based on the type of system, you can say 1, 2, 3, 4, 5 like that. And maximum degree of freedom generally are 6 you are taking in theory of machines. Generally in theory of machine, you take maximum degree of freedom as 6. But my dear, this is not true for vibration system. For a vibration system, if we have a beam like this, then you know when you see the deflection of beam, every point is getting deflected with a different deflection. So every point deflection is different. So you can have different motion, different natural frequency. So here degree of freedom will be infinite. So in a vibration system, the maximum degree of freedom can be infinite. If two springs are in parallel, Midun, it is single degree of freedom. If we have two springs like this, this is single degree of freedom, because this motion can be shown by one variable. But if we have one spring with two masses, then the motion of both will be different. x1, x2, degree of freedom will be 2. This is 2 degree of freedom system. So guys, they can give you a question where you need to find out the degrees of freedom. But if you will see the types of questions in the GATE or in the syllabus, we have only single degrees of freedom. Only single degree of freedom systems are there in both mechanical paper as well as in XC paper. So there is no problem with this. Please tell me everybody got it, then we are moving further. Everybody got it, then we are moving further. Yes. So with this, I will say vibrations over. So as per my promise, we have completed that in 3 hours. If you remember, I told you, vibrations marathon we have kept separate for 3 hours. So within 3 hours, we have completed it. Okay. The problem was with TOM only, and the reason for that was in TOM a lot of things needs to be explained. So because of that explanation, the time required is more in case of TOM. I feel now it is the time to move into the second topic of today, that is cams and follower. Cams and follower. Cams and follower. So my dear, after this topic we will be entering into governors, but after this topic we will take a break. So please do not ask about the break before the completion of this topic. After this topic we will take a break, and then after the break we will see governor, gear, gyroscope. I feel only we are left with that and balancing. Yes. Sir, once you solved that 3 degree of freedom system problem, Teju, yes, it can be. Don't worry, if you want, I would be taking that question in the daily dose. So in the next week daily dose, I will take that. You go for it. Okay, I will take that. Very good, Bhomik. So guys, now we are talking about the cams. So before we start, I would like to tell you that this is the only topic. This is the only topic which is there in the syllabus, which is a 2 degree of freedom system. Otherwise, all the systems are, sorry, not 2 degree of freedom system. That is the higher pair. This is the only higher pair mechanism. If it is a mechanism, degree of freedom is 1 only. But this is the only higher pair mechanism which is in your syllabus. It is the only higher pair mechanism which is there in your syllabus. And when we are talking about cams, initially the concept was like this. A circular cam was taken, and when they have taken a circular cam with a knife edge follower like this, the idea was to give the motion to the follower with the direct contact. But when cam rotated, there was no motion of the follower observed. So there was no motion of the follower observed in this case. No motion of the follower was observed in this case. Why? Because if you see, when follower is coming in contact with the cam, every point from the cam center is having the same distance, and from that we get an idea that if we want to give motion to the follower, there should be the changing of distance from the center. So for that, then we change the shape of the cam. Here the center distance is not constant. Here the center distance is first increasing, then decreasing. So based on that, you will get the follower motion. So for such cases, if you will be using any follower, this time motion will be there in the followers. So this was the one thing we have done with the cam and follower. When we are talking about with the cam and follower, for a cam and follower, the very important element is cam, second important element is follower, and third thing is there as frame, because there will be some connection between cam and follower. I would also like to tell you, in this mechanism of cam and follower, cam is the supreme authority, because follower is someone who is going to follow the cam without any reasons. Follower has to follow on the cams only. Cam is acting as a road on which your vehicle is moving. If your road is having some kind of speed breaker, your vehicle will also feel the same. So your vehicle is the follower for the road. Okay, so you are following the road like follower is following the cam. It is a kind of husband-wife kind of things. Follower is acting like a husband. Okay, so you have to follow it completely. And whenever the cam would be rotating, it would be giving heavy pushes, okay, to the follower. So there is a maintenance of contact is required, which can be done with the help of frame. Frame can be self-closed or forced closed. It can be self-closed or forced closed. Okay, we will see that. So my dear, first of all, we are going for the classification of cam. So when we are talking about the classification of cam, there is one type of cam that is said to be the wedge cam. You know what is wedge cam actually? In the wedge cam, when we are talking about, we are going to have a plate. In this plate, there is a kind of groove. In this groove, we will be having the follower. So as you will be giving this motion to the follower, cam, follower will be having a motion like this. This is said to be wedge cam. Second is plate radial or disc cam. This is said to be plate radial or disc cam. Here cam is rotating, follower is reciprocating. Generally people have that as a thumb rule. They feel always cam will be rotating and follower will be reciprocating. It is not like that. In this case, you can see cam is reciprocating, follower is also reciprocating. I can even tell you a case where cam is rotating, follower is also rotating or oscillating like this. So guys, both the types of motions are possible for both cams and follower. Then my dear, this is the animation for radial or disc cam. You can see how follower is following the cam. So if you have a cam like this, if you have the center distance same for some distance, then for that much distance there will be no motion for the follower. That is why if you want to provide no motion for some certain time, that kind of period is said to be the dwell period. Okay, शिवम एक बार उसका कॉन्सेप्ट समझा दीजिए. इसेंट्रिक कैम से क्वेश्चन एक आया था 2019 में. Okay, Shivam, I will try to take the question, but first let me complete the cam. Actually, I have not added that question. I will try to take that after the break. Okay, there will be a break for 15-20 minutes. After that, I will try to add that question into the PPTs. Okay, or I would also suggest you one thing. Whenever I am coming with some CTQ session, join that. They are all such kind of questions I am covering. Okay, if you see any session like for SOM also, whatever the doubts you guys are posting in the comments, we are taking such kind of questions in the CTQs. Okay, so don't miss that. Today I will try to take that question. I'm not having that in the slides, but after the break I will try to add it. Okay, so this is how the dwell is given. Now my dear, we are going for the cylindrical cam. What is cylindrical cam actually? So my dear, in the cylindrical cam, you can see this type of thing is there. When this cam will be rotating, follower will reciprocate like this. So this type of cam is said to be cylindrical cam. So my dear, if you see the surface of this is like a cylinder. So I am taking this surface like this, a cylinder. It is there. This is a flat surface. This is a flat surface. Okay. My dear, if we are going to have this surface to be either concave or convex, this surface can be either concave or convex like this. Okay. I can make the surface concave or convex. What do you mean by concave or convex? Means this type of or this type of. So these are three possibilities. This is cylindrical cam. This is concave and convex. We call them as globoidal cam. So when concave and convex surfaces are there, we call them as globoidal cam. Okay, that is said to be the globoidal cam. So my dear, if you see this type of surface, you know that when this is rotating, there would be a line of motion of the follower. Okay, because when follower is when cam is moving, maybe follower is at this contact and point of contact will be moving like this. So if we have that kind of thing, I am going to make this line of motion. I am going to compare all the three. How the motion is going on, like you can see, we are making the cylindrical cam like this. I am showing you like this. Like this. So you are starting the motion of the follower at this point. But when this cam is rotating, you know, this point will come up after 180 degree of rotation. So when this follower will reach to this position, this is going to be the stroke length for the follower. This is how the follower will move on. So I want to see that stroke length for all the three types of cams. One is flat cam, other is when the surface is concave and convex. So I am making all the possibilities together. For all of them, for comparison purpose, I am going to consider a line of motion. Let us say this is the line of motion. Because you know, line of motion is depending on this. Okay, so I have made this. So you can see, my dear, for cylindrical cam with flat surface. For cylindrical cam with flat surface, this is the stroke length. This is the stroke length. If we are going to see with concave and convex, for this concave, this is going to be the stroke length. It is smaller than cylindrical. And for convex, the stroke length is going from this to this. So we will be saying that Vineet sir, forced damped recording. Okay. हाँ बिल्कुल विनीत, you will get it. So what we have seen is stroke length for convex is more than for cylinder, is more than for concave. This can be a 1 mark question in the gate. That stroke length for convex is more than cylindrical than that of the concave. This is the animation for cylindrical cam, guys. Animation for cylindrical cam. Okay. This is how the cylindrical cams are working. You can see how the follower is having reciprocations. Okay, wedge cam we have already seen, my dear. Okay, this is the wedge cam. Animation for wedge cam. You can see in the wedge cam, when cam is going like this, follower is going like this. Got it? Everybody got it, guys? Everybody got it? This is the classification of cam we have seen. Now, my dear, we are having the second classification based on follower motion. First classification was based upon the shape of the cam. Okay. Now we are talking about based on the follower motion. So my dear, in a follower motion, there are three kind of thing happens. When follower go up, it is said to be rise. When follower come back, it is said to be return. No fall, we will call it as return, because it is not going to fall under gravity. Then my dear, if it is going to stay for some time, it is said to be dwell. So only these three things are happening in the motion. So if there is no dwell, we are having only rise and return. Then we will be having a curve between x and theta. X is the displacement of follower, theta is the angle rotated by cam. So when angle is rotated from 0 to 2 pi, cam will be moving from 0 to 2 pi, follower will go up and come down. Then X theta diagram will be of this type. Okay, this type of cam is said to be rise return cam, where only rise and return happen. This is said to be rise return cam. Then we are talking about the second type of cam, that is dwell rise return. So here my dear you can see that, here my dear you can see that, here my dear you can see that first of all we will be having some dwell period. First of all we will be having some dwell period. Then we will be having the rise, then we will be having the return. So this type of cam is said to be DRR cam. Rise return cam is said to be RR cam. Okay, DRR cam. Here first we have dwell, then we have rise, then we have return. I feel you got it everyone. This is another type of cam. Moving further guys, we have rise, dwell, return cam. So my dear, if you are going to say that, here we will be making it first of all rise, then dwell, then return. So this is RDR cam. And for our analysis purpose, we would be considering only this type of cam. Then we can have dwell, rise, dwell, return. Dwell, rise, dwell, return. Then dwell, rise, dwell, rise, dwell, return. So this is D, R, D, R. Dwell, rise, dwell, return. This is the fourth type of cam we have seen. So guys, if you see these four types of cam, if you will try to make any fifth type, you will be getting failed. If you are going to make any other type of cam, you will not be able to make it. The reason behind that is they will be one of them only. Let us say you say, okay, if any type of cam is coming into your mind, you can say, if you say, sir, RRD, rise, return, dwell, then my dear, you have already seen dwell, rise, return. So you know after return it would be dwell. So rise, return, dwell. So when I say rise, return, dwell, it simply means I will be starting from here and end at here. Okay, if you see any type of other, let us say dwell, rise, dwell, return, dwell, you are saying this dr, drd, dr, drd, dr, drd. So then d, r, D, R, D. So you cannot make any other. These are the four maximum types of cams. Okay, I feel you got it. Now we are going to see various angles in the cam. So my dear, when we are talking about the various angles of the cam rotation, the first rotation is out. The first angle is out stroke angle. First angle is out stroke angle. First angle is out stroke angle. This is the angle of rotation of cam during rise stroke. Angle of rotation of cam during rise stroke is said to be out stroke angle. Then we have another angle which is said to be return stroke angle. We have another angle that is said to be return stroke angle. Return stroke angle is the angle rotated by cam during return stroke. This is the angle rotated by cam during return stroke. So angle rotated by cam during return stroke. Okay. Then my dear, we would be having dwell angle. Dwell angle is the angle turned by cam when follower is at rest. It is the angle rotated by the cam when follower is at the rest. Okay. Similarly, my dear, we are having angle of action of cam. Angle of action of cam. When we are talking about angle of action of cam, this is from starting of rise to end of return. starting of rise to end of return. Okay, from starting of rise to the end of return, this angle is said to be angle of action of cam. So generally students are saying, sir, this angle of action of cam should be 2 pi only. So I would like to say not always. It can be less than or equals to 2 pi. Let us see how. Let us see how. For this case, you are having rise, starting of rise, end of return. So angle is 2 pi. Here this is the starting of rise, this is the end of return. So angle is less than 2 pi. So here dwell period will not be counted, which is coming before rise. Okay. Then starting of rise, end of return. This time angle of action of cam is 2 pi. Means dwell in between are counted. Here starting of rise, end of return, less than 2 pi. So in angle of action of cam, only those dwell are counted which are coming between rise and return. If any dwell is coming either before the rise or after the return, that kind of dwell period is not going to be counted. Is it clear for everyone? Everybody is getting it? Please tell me that. We are moving further. We have seen all the types of cam. Now we are going for the classification of follower. After classification of follower, we will see the types of derivatives. Then after types of derivative, we will see the types of motions. Okay, after types of motion, we will complete it. Then we will be having break. Okay, so after break, we will see governors and many other things. So let us see now according to the surface in contact. This is the classification of follower. We are having knife edge follower. This is the very first type of follower which came into picture. Okay, and this is the worst type of follower. Why this is worst type of follower? If you want to feel it, you can feel it. If you want to feel it, take a knife, put the knife here on your arm. This knife is the knife edge follower. Rotate the cam. Within 5 minutes, you will go to the hospital. You need to go to the hospital. And if you will not go, you will go to directly in the parcel form to the God. Yes. So this is the stages of true loves generally. Yes or no? When people are doing this kind of attempt. So this is the feeling of knife edge follower. So what is going to happen with this, with you? The same is going to happen with the cam. Within 5 minutes, cam says hands up. I cannot bear with this. So guys, why this is happening? Because here the point of contact is very, very small. Because of sharp corner, the point of contact is very, very small. Okay. And here when the cam is rotating, at this point we have the relative motion. And when we have the relative motion, it means the friction is going to be kinetic. Kinetic? Yes or no? It is going to be kinetic. Kinetic friction means maximum value of static friction will be acting. And when you are talking about this follower, obviously when it is rotating in this way, on follower also friction will be acting, on cam also friction will be acting. So this is how friction will be acting. And my dear, because of that very, very small point, you may be saying, sir, what you are saying in engineering mechanics, you always say that friction force is not a function of area. We say that in the mechanics. Then how you are saying this is a sharp point, sharp point? Dear, I am not saying about friction force. I am talking about the wear because of the force. So if area is lesser, then my dear, wear will be more. And if wear will be more, because of that, my dear, this arrangement cannot work for more time. And also because of this friction force, this will try to deviate towards the support. So there is a requirement of support reaction also. That is also one more problem with this knife edge follower. So that is not acceptable, because that thing will fail the cam and follower very soon. Within 5, 7, 10 minutes, this will fail. Second is roller follower. For the first time in history, my dear, after the worst attempt, we reach to the best attempt. Generally things are improved. Like today you don't know anything, tomorrow you learn something. It is not like that. In this case it happens, we were having the worst follower knife edge and we get the best follower roller follower. So when we are talking about the roller follower, if this is the cam, this is going to be the follower. So my dear, you can feel it. This is a case of rolling friction because rolling pair is there, and rolling friction is considered to be static friction, and that static friction is very, very less as compared to that. If you have seen the rolling friction value, it is generally coming out to be hardly 1% of the sliding friction. So whatever the friction was present with knife edge here would be hardly 1 to 2% of that. Not only that, this time the sharp point is not there, so area is also bigger. And because of that big area, wear will be very, very less. Wear was coming because of two reasons. One is high force, other is less area. If you compare the point of contact here and the point of contact there, it is 1000 times bigger. So area increased by 1000 times for the point of contact. Force reduced to 1 to 2%. So here is a reduction of 100%, here is an increase of 1000%. So overall wear get reduced by 10 to the power 5. So if that is the case, here life of this mechanism would be more than the life of human being. 10 to the power 5 times wear will get reduced. Life will get increased by the same amount. Okay. So because of that, this is the best type of follower. And there can be a small problem of because roller is there around about this pin. So sometimes jamming may happen about this pin. Otherwise there is no issue with this follower. But still these type of followers were not used in the IC engines before, because these types of follower needed 3D space, which was available at that time only for the very big gas engines. It was not available for normal IC engines. So that was the reason at that time we have used this roller follower only with the big gas engine aircraft engines. We have not used them with the normal IC engines. Nowadays IC engines are also having that 3D space and they are fulfilling this requirement, so they are able to use it, but previously it was not used. Okay, yes, I feel you got it. Moving to the third follower, that is flat face follower. So in flat face follower, my dear, you are having this follower. You can see this. This is flat face follower. And if you see the cross section in this view, the cross section of this flat face follower may be circular, may be rectangular, may be square, may be triangular, anything. But if you are using the circular cross section, this is also said to be mushroom follower. So here, my dear, if you see, this is mushroom type of follower. The name was given but without reason, because it doesn't look like mushroom. So I don't know why the name is given like that, but it was given. So if someone asks you what is mushroom type of follower, you will say flat face follower with circular cross section is said to be the mushroom type of follower. This is asked in engineering services, not in GATE actually. So when we are talking about this type of follower, here everything was fine. The problem was stress. Okay, I'm telling you what is stress actually. Surface cracks came into picture because here the contact area increases too much. So surface cracks came into picture. But still the life, if we are talking about of these type of follower, was 2.5 to 3 months. After these 2.5 to 3 months, you need to change it, not completely. You just need to, you can say, not remove it, just you need to some, you can say regrinding kind of thing is required, or sometime packing is required if the wear happens. And you can use the same cam and follower arrangement for 10 to 12 times of packing. It means the same cam and follower can be used 10 to 12 times. Okay, and it is similar to like we are using the tool after regrindings. Okay, it is similar to that. So my dear, this is something about the flat face follower. So to get the benefit of this roller follower, okay, what we have done, we have come up with the fourth type of follower, that is spherical face follower. For that, what we have done, we have made this surface as spherical, so that surface stresses gets also reduced, and this is said to be the spherical phase follower. This is having the benefit of both flat phase follower and roller follower, and at that time for IC engine they were used. For IC engine at that time they were used actually. Is it clear, guys, for everyone? Do like and share the session. We are still with the second topic going on, but now the topic left will not take that much time. Okay, so we have seen the types of cams and follower. Now there is radial follower and offset follower. If we have a cam like this, okay, if the follower is like this, so you can see the axis of motion of follower is passing through the cam center. Such type of follower is said to be radial follower. Offset follower is this. Offset follower is this. Here these are not passing, this is said to be offset. What is the benefit of offset? Benefit is in offset follower we need lesser forces. Lesser forces are required to move the follower. And the problem with that is stroke length gets reduced. Here forces are reduced and stroke length is also reduced. So reduction in force is a good point, but reduction in stroke length is not a good point. So we are getting advantage not alone, with some limitation also. I feel everybody got it. Then we are moving for the cam terminologies, and then we will see the derivatives and motions. Let us see the cam terminologies. So when we have this as cam, this is axis. If, my dear, we are having this as follower, so my dear, if I am going to start plotting the circles by taking this center as the center, I start plotting the circle. This is one circle, another circle. When you will keep on plotting the circle, there will be one circle come like this. If you see this circle is tangent to the base circle, sorry, tangent to the cam. This circle is tangent to the cam. This circle is tangent to the cam. This circle is tangent to the cam. And my dear, this is having the center same as the cam center. This circle is said to be a base circle. This circle is said to be a base circle. This circle is said to be a base circle. This circle is said to be a base circle. Okay. So guys, now base circle is very important. It somewhere decides the size of the cam. Okay. Then my dear, if we are going to use the formula or concept of kinematic inversion, here this link 1 is fixed and this link 2 cam is rotating. If we keep cam to be fixed and link 1 is rotating or moving, then my dear, this point of the roller will trace this path. So this point which is tracing the path is said to be trace point. And the path traveled by this is said to be the pitch curve. This is said to be the pitch curve. Like we have made a circle from the cam center as a center, which was tangent to the cam. Similarly, if we make a circle which is tangent to the pitch curve, then that circle which is tangent to the pitch curve, this circle is said to be prime circle. Okay. And my dear, if you see the radius of prime circle, then it is defined as radius of base circle plus radius of roller follower. This is the radius of prime circle. You may get a question from that also. And my dear, now I would also like to define some other things. So my dear, let us say you are having a cam like this. You are having a follower like this. Okay. So you can feel one thing. If you are going to say the tangent to both the surface, this is the common tangent, because this is tangent to both cam and follower. If you are going to put a perpendicular, that is to both the surfaces, 90 here, 90 here, this is said to be the common normal. Okay. And if you see, when the cam will be rotating, follower will be moving in this direction. So my dear, the angle between them is said to be the pressure angle. For cam, this is how we are defining the pressure angle. Okay. So I feel you got it. So I am simply writing this. This is the direction of motion of the follower. Okay. So what angle it is making is said to be pressure angle. So when this cam is rotating, follower is moving, pressure angle will be varying at all the times. Then my dear, there would be some specific points for which pressure angle will become maximum. When pressure angle is becoming maximum, those points for which it is happening are said to be the pitch points. For cam, we are defining them differently. Okay. And for gears, we will be defining them differently. So this is going to be the case. And if, let us say, we are getting any points as pitch point, let us say we are going to get this point. Okay, I am making on the next figure. If we are going to have this point for which pressure angle is maximum, then you would be taking cam center and this distance and radius, you would be plotting a circle like this. Then this circle is said to be the pitch circle. So here you can see this is cutting the cam at these 2 points. So if this is pitch point 1, this is pitch point 2. So my dear, pitch points, if you are going to take it, everybody got it? So pitch points are the points for which pressure angle is becoming the maximum. And if you are going to take center as center and distance up to pitch point as radius and make a circle, that is said to be a pitch circle. Very good, Midun. So all these are the terminologies for cams. We have seen them, all of them. Okay. So let us move further. Now we are talking about the types of derivatives. So after derivatives, my dear, we will see, once we will see the derivatives, after derivatives, what we will see? After derivatives, we will be having the types of motion, and after that the chapter will be over. So I feel we need 15 to 20 more minutes. So by 2 p.m. we will have the break, don't worry. Okay. So we are moving further. Yes. Very good, Ajay. So now we are talking about the follower derivatives. You know, derivatives are nothing but, like, you know, velocity is ds by dt, acceleration is dv by dt, jerk is da by dt. Generally, they are said to be derivatives. So when we are talking about the derivatives, first derivative is nothing but dx by dt. X is the displacement of follower. So we can also write it as dx by d theta by dt. Here, my dear, theta is related to the cam rotation. Theta is related to the cam rotation. X is displacement of follower. Okay. You also should be aware. Sure, Teju, we will see that. D theta by dt. D theta by dt is nothing but the angular velocity of cam. So we can write dx by dt is omega times dx by d theta. So you can see dx by dt is directly proportional to dx by dt. So you can call this dx by d theta as the first derivative. This is the first derivative. When we see this to be the first derivative, you know, people are talking with each other about different things. Here also there are two very important peoples. One is mathematics, other is physics. They are talking with each other about dx by d theta. Some are saying it is honest, some are saying it is dishonest. Like that kind of conversation is going on. So mathematics says, as per my knowledge, this is the slope of x theta diagram. Because mathematics look it at dy by dx. Physics says, I feel this is the velocity of follower. Because physics sees it in this way, v is ds by dt. So as I said, every person can have different point of view. Okay, so they can talk about anything based on their point of view. So those people who are saying it is slope of x theta diagram, they can say slope can be anything. There is no restriction on slope. Slope can be even infinity also, you know that. If you are going to make a curve between x and theta, you can have any angle. Slope can even be infinity for 90-degree angle. So mathematics put no restriction on this value. But physics says if it is velocity, it should be small. If it is velocity, it should be small. Then when I say it should be small, what do you mean by that? It should be small. The meaning is, when, my dear, follower is moving, it is moving between two positions in the rise stroke and return stroke. So when you are going to have rise stroke and return stroke, it is going to go up and then coming down. So there is a limited space in which it is happening. Like whenever train is going from one station to other station, they have to put brakes just when the station is about to come up. So here also, my dear, when the motion started from zero velocity, it has to be zero once again here. So my dear, because of that, if it is moving to more velocity, it is going to be very difficult to come at rest at this position. You need to apply more resistances for that. So that is why physics says the speed should be lesser. Speed cannot be any high. It should be small. This is the restriction put in for the first derivative. Second derivative, my dear, when we are talking about, for that, it is d square x by d theta square. Mathematics and physics have different thinking about this derivative. We need to understand about them properly. What is this actually? You must be aware that when you have studied the strength of material, you have written one thing, that when you were defining 1 by r, it was d square y by dx square upon 1 plus dy by dx ka square to the power 3 by 2. This you have used in the which chapter of SOM? Can you tell me? This we have used in which chapter of strength of material? We have used this in which chapter of strength of material? We have used this in which chapter of strength of material? Anybody? 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 Deflection of beam. Very good, Sujish. We have seen this at the time of deflection of beams. And then we said we already know dy by dx is small. We have just seen that. If it is small, we can ignore the square of this. Square of small is very, very small. So you can write 1 upon r is equals to d square y by dx square. So my dear, if d square y by dx square, this is your acceleration, then mathematics says that it is related to the radius of curvature, or it is said to be the curvature. Mathematics says this term is nothing but curvature. What is curvature? You know that curvature means the curvature of cam, because this is what follower needs to follow. So you can see you can have a cam of this shape. For this case you have radius quite big. For this point you have radius to be 0. So my dear, how this curvature is, that is mathematics says the second derivative is this curvature actually. But physics says this is acceleration. Physics says this is acceleration. And my dear, if you go as per the mathematics, this is the radius of curvature. If acceleration is going very, very high, radius of curvature is going to be 0. Your cam will be reaching to a sharp point, and when this sharp point will be meeting with the follower, there are chances that this will be unable to understand the force coming from the spring, and because of that this cam can fracture from here. This type of thing is said to be undercutting. Interference and undercutting phenomena is happening in cam because of that kind of follower. Very good, Sujish. So if you don't want that kind of thing to happen, you need to keep acceleration to be lesser, because if acceleration is going to more, then cam is going to fracture. In normal language you can feel, if you have a speed breaker like this and you are moving with your vehicle, then my dear, because of this type of sharp curvature, my dear, your vehicle will leave the contact with the road and will come back after some time. So when your vehicle is leaving the contact with the road, at that time motion is not defined. And in case of road and your bike, it is possible. But my dear, in case of cam and follower, it is not possible, because follower is kept with a spring under compression. So it will be always applying a force. Because of that, cam will fracture. So because of this kind of phenomena, we never want acceleration to be infinity. If acceleration will be very, very high, cam is going to die. So that is not acceptable. So my dear, velocity should be less. If velocity is more, losses will be more. Acceleration should be less. No, acceleration must be less. Because if acceleration is more, cam will die. This time it is not about the losses. It is about the fracture of mechanism. So acceleration must be less. The third derivative is d cube x upon dt cube, d theta cube. For this also mathematics says it is d by d theta of radius of curvature. Physics says this is jerk. So when math says this is d by d theta of radius of curvature, methods this want to say that if we have a particular distance for speed breaker, then you can have some speed breakers, like road is coming like this, some speed breaker like this. You can see here change of curvature is not much with the distance. Now if we have the curvature to be of this shape, now you can see the change is a lot more. If you are having slight more like this, and if you are having this, like this. So if you have this type of curvature, my dear, the rate of change of r is quite more with the distance, with the angle of cam rotation. For that kind of things, we would be having a lot of jerk. Whenever you see this type of speed breaker, you will never be reducing the speed of your vehicle. You will go with the same speed. But when you say this type of speed breaker, you will try to reduce the speed. When you see this type of speed breaker, you will come out from the bike and you will take the bike manually. So what do you mean by that? If jerk is going to be more, there is no problem, we need to reduce the speed. So first derivative is not very dangerous. Third derivative is not very dangerous. Second derivative is the most dangerous one. So velocity should be less, jerk should be less, acceleration must be less. Is it clear for everyone? Sujish, Malesh, Ajay, Midun, Teju, everyone, please tell me, you got it or not? Shivam, Manas, yes. Moving further, guys. So this was the story of the types of derivatives. Now we are moving to the types of motion of the follower. With this, the chapter will be over. You know that there are 4 types of motion. One is uniform velocity. Second type of motion is uniform acceleration. Third type of motion is simple harmonic motion. Fourth type of motion is cycloidal. One by one we will see that. You know that cycloidal is the best type of motion, because in this jerk is never becoming infinity, so we can use it for very, very high speeds. All others cannot be used for very high speed because their jerk is becoming infinity. So when jerk is very, very high, you need to reduce the speed. First type of motion is uniform velocity motion. So for uniform velocity motion, if you are going for the S theta diagram, then S theta diagram will be coming like this. So if we are going to say that maximum height of rise or return is h, and this is the maximum angle is phi naught, outstroke angle. So you are talking at some angle, what would be the displacement? This is denoted by x or denoted by s. So you will be writing s is equals to theta by t, you know that. So s can be written as here s upon theta from the similar triangle can be written as h upon phi naught. So s will be h theta upon phi naught. You know s can be written as h omega t upon phi naught. If this is the displacement, you can find out velocity as ds by dt, h omega by phi naught. These values either you can remember or you can derive like me. You can remember or derive like me. Then acceleration would be coming out to be 0. Okay, so this is how we can find out everything for uniform velocity motion. But we are going to choose a special type of cam, that is RDR cam. So if you see RDR cam, first of all you will be having rise, then you will be having dwell, then you will be having return. So what our expectations are? Our expectations are uniform velocity. So from here velocity will be uniform. Here also velocity will be uniform. Here velocity will be 0. This is our expectation for the diagrams. So if this is the velocity, you know velocity is constant, acceleration is 0. Velocity is constant, acceleration is 0, you know that. Okay. So when velocity is 0, acceleration is 0. Velocity is constant, acceleration is 0. But here velocity is moving from 0 to maximum. Velocity is moving from maximum to 0. 0 to maximum, maximum to 0 in 0 time. So that is why here we will be getting infinite values. You can see this. But this is not the reality, because velocity cannot become 0 to 5 in 0 time. So this is not the correct diagram. When you will be correcting this, modify this diagram, then you will get to know velocity is becoming constant after some time. First it is moving from 0 to 5. Then it is becoming constant, then 5 to 0. It will take some time from going from 0 to 5 or 5 to 0. Similarly, here it will increase from 0 to 5, then go for 5 to 0. This is the correct velocity diagram. When it is having 0 to 5, you will be having some constant acceleration also. Here constant retardation also. Constant retardation, constant acceleration. Velocity cannot change in zero time. Velocity will take some time. Acceleration can change. Why? Because acceleration can change. Why acceleration is more dangerous than jerk? Acceleration and velocity and displacement are motion parameter. Jerk is not a motion parameter. That is why you do not study jerk in engineering mechanics. So if you see this, here acceleration is going from 0 to maximum in 0 time. So jerk will be plus infinity here, minus infinity, plus infinity, minus infinity, plus infinity, plus infinity, minus infinity. So 8 times jerk becomes infinity. We were saying that beneath jerk is the third derivative, d cube x by d theta cube. It is dx. Okay, it is d by d theta of 1 by r. So it is telling you how the curvature of cam is changing with the rotation of cam. In other words, if you see the speed breakers, some speed breakers are like this. Some speed breakers are like this. Some speed breakers are like this. When you see this type of breaker, you may not speed down. For this you have to speed down. For this you have to speed very, very down, or you need to stop the vehicle to cross it. So why? Because you can see the height is changing with the time very slowly. The height is changing with the time fastly. Height is changing with the time very fast. Slope is increasing actually. That is the meaning of high jerk. And whenever jerks are high, we need to reduce the speed. That is the story. When jerk is high, you need to reduce the speed. Okay. So this is how the things are going on. So when we are getting 8 times jerk infinity, we shall need not high jerk values. High jerk means slow speed. Here jerk is not even high. It is the infinity, and that also not 1 time, 8 time in a cycle. Means if let us say you have a wheel like this, the time in which the wheel will completely rotate, up to that time you will be having 8 speed breakers like this. So for such case, forget about speed. You may have to stop the vehicle. This is for very, very, very slow speed applications. Very, very, very slow speed applications. Okay. अरे भाई 8 times ऐसे हुआ ना. Here acceleration is increasing 0 to maximum in 0 time. First infinity. Reducing maximum to 0 in 0 time. Second infinity. Then it is increasing in opposite direction. This is retardation in 0 time. Acceleration in 0 time. Retardation in 0 time. Acceleration in 0 time. So you know jerk is defined as final acceleration minus initial acceleration by time. So here when time is 0, jerk will be infinity. Plus minus will be depending on whether acceleration increases or decreases. Is it clear for everyone? Yes. Is it clear for everyone? Yes. Very good, guys. Very good. So moving further. Very good, Malesh. This was the first type of motion. Second type of motion is uniform acceleration and retardation. Second type of motion is uniform acceleration and retardation. So my dear, for that, I told you what to do for that. We will be dividing it into parts. And then what you need to do, why 2 parts? One is for acceleration, other is for retardation. We will be dividing it into 4 parts. Four vertical parts. I am dividing it for 4 parts. You can go for 8, 16 also. Then you know we will be going for some inclined lines like this. Here also. Now what you need to do, I feel everybody knows that. You need to join this. This is not required for gate. I am just giving you this for revision purpose. This is not at all required for gate. So you will be getting a curve like this. So for uniform acceleration curve, we got a curve like this. So you know here, you can take this as h by 2 and this angle as phi naught by 2. This is the phi total. Phi naught is outstroke angle. Okay. So my dear, if you are going to apply the motion for half, this is the curve between s and theta actually. So you know that when we are going to say s is equals to ut plus half at square, you can put displacement as h by 2. Initial velocity was 0, so 1 by 2. Acceleration we need to find out. When we are talking about when we are talking about time, so you know time, whenever we are talking about the time, you know omega is theta by time. Okay. So when time, you can write it as theta by omega. So here theta by omega, theta is phi naught by 2. So phi naught by 2 omega. So you can put it as phi naught by 2 omega ka square. So from that you can find out the value of acceleration. I do not remember it. You can remember also the values. I always use the motion, equation of motion, and I never remember the formulas. But if you want, you can remember it. You may be also asking about one thing, sir, what are the formulas for that? As I said, you can find out acceleration like that. And similarly, velocity can be written as u plus at. Once you get acceleration, maximum velocity will be coming out to be at because u is 0. So that is your choice. And if you want to remember the formulas, I have shared the short notes of theory of machines on my Telegram channel. And if you don't have the link, I am sharing the link of Telegram channel also, so that you join it and you will be getting the short notes. Today I will once again share. You also have handwritten notes. So from there you can directly remember the formula if you want. If you want to derive it, for that I have already given you the procedure. Is it clear for everyone? I am sharing it with you. Okay. So those who have not joined yet, do join it. Okay, wonderful guys. This PDF also will be coming for that. So guys, here what is going to happen? You know that the motion is going between these two things. Initially motion is like this, then motion is like this. You know initially velocity is 0, finally velocity is 0. So velocity will become maximum here. So first half motion is accelerated motion. Second half is retarded. Then this is retarded, this is accelerated. This is accelerated because velocity is going from 0 to max. Then going from maximum to 0. Then going from 0 to maximum in opposite direction, maximum to 0 in opposite direction. So we have derived it for this case. We got the acceleration value. So if you see acceleration is constant. So when you will be making the diagram, we have already seen the displacement diagram, how they come. So this time velocity is going to vary like this because acceleration is constant. So for first half, velocity will go to maximum, then will come to 0, then will remain 0, then will come to maximum in opposite direction, will become 0. So this is the velocity and displacement diagram for second motion. Now acceleration diagram will be coming like this. You know acceleration is constant. Here acceleration, retardation, retardation, acceleration. Once again acceleration changing in 0 time, 0 time, 0 time, 0 time, 0 time, 0 time. 6 time acceleration changing in 0. 0 time means vertical line. So 6 times jerk will become infinity. So this can be used for very slow speed application. This can be used for very slow speed application because this time 6 times it is becoming infinity. You can go for that kind of thing. Vineet, I will share. That's why I am saying I will share again. Okay, I will share it after today's class. When I will share the PDF of Tom, I will share that also along with that. Moving to the simple harmonic motion. So my dear, I already told you at the start of vibration how we are going to define this simple harmonic motion. So when we are going to define it, for that what we are going to do? We are going to do this half circle because from circular motion only SHM is derived. Now it is on to you how perfect the graph you want. So I am dividing 180 degree into 6 part, 30 degree each. You can go for 10 part, 18 part, like that. So this is for 0 degree, 30 degree, 60 degree, 90 degree, 120 degree, 150 degree, like that. So you would be making horizontal line for all 30 degree, 60 degree, 120 degree, 150 degree, like that. So we have divided into 6 parts, so vertical also should be 6, like this. Now you just need to join one horizontal with one vertical. You just need to join one horizontal with one vertical. You need to join this point, this point, this point, this point, this point, this point, and this. You will be getting a curve like this, like sinusoidal curve. So displacement diagram we have seen, rise, return. So my dear, for this, when we are going to derive the equation, for this, with that equation, when you will be going for velocity, you know velocity can be find out as ds by dt, which can be written as ds by d theta into d theta into dt. So that would be coming out to be a sine curve like this. So as it is a sine curve, this is rise, dwell, and return. Here I have kept the values pi h omega by 2. This is pi h omega by 2 phi naught. This is the value of maximum velocity for simple harmonic motion. Similarly, acceleration is going to be cosine, and the value of maximum acceleration is h by 2 pi omega by phi naught. Is it clear? So you can remember the values or you can go for the derivation also. So both the choices are there for you. Okay. Is it clear for everyone? Then my dear, when we are going to say the jerk, this time jerk will once again come sine. This is going to be minus sine, because sine ka integration, sine ka differentiation is cos, cos ka differentiation is minus sine. So velocity diagram was like this, acceleration was this, and jerk is going to be like this, opposite to sine. So this is the diagram for that. Is it clear for everyone? So if you see that here acceleration is changing in 0 time at 4 times in a cycle. So we would be having 4 times jerk will become infinity. This time I have mentioned the values of velocity, acceleration, so that you can remember it, because SHM derivation is lengthy. For uniform velocity, uniform acceleration, derivation is small. We can go for it. For SHM, you can remember it. Okay. Even I have gone through that derivation with the help. I can tell you, like if you want to find out the displacement, you know this thing is said to be h by 2. So the radius of this circle is going to be h by 2. This is h by 2. Okay. So if you need to find out that the time in which this is rotated by 180 degree, the time in which this is rotated by 180 degree, okay, in that time it is going for phi naught. It is going from 0 to phi naught. Okay. So we are talking if we are going for any angle beta, if this angle is beta, for that possibility is the cam is rotated with that angle theta, and this is going to be the displacement. So first of all, you can find out this value. You will be getting h by 2 minus h by 2 cos beta is equals to the displacement. So I am giving you the hint by which derivation will be started. You go for differentiation, you will get velocity. Go for differentiation, acceleration. Go for differentiation, you will get the value of jerk. So this is how you need to see, and beta will be equals to pi by pi omega by phi naught. You can do that. Okay. I feel you got this. Is it clear for everyone? Now we are moving to the last type of motion, cycloidal motion. For that, this is the equation for displacement. You can remember this equation. Put theta to be omega t. After putting theta to be omega t, you can find out velocity as ds by dt, acceleration as dv by dt, and jerk as dA by dt. So no need to remember these values now, just differentiate, only remember this equation for cycloidal motion. After doing that, you will be getting this as velocity, this as maximum velocity. You can do that exercise in the paper rather than remembering the value. This is the maximum acceleration. So when you will be plotting the curves, this curve will be sine square. Okay. This curve will be sine square. This is sine and this is cos. This is coming like this. This is sine square. This is sine 2 theta, cos 2 theta. Like this. Everybody got it? This time acceleration is not varying instantly with time. That is why jerk is not becoming infinity. So this is used for very, very high speed applications. Used for very, very high speed applications. So we can use this in IC engines. So nowadays we are using in IC engine roller follower plus cycloidal motion. Previously we were using spherical phased follower. Okay, this is what we are going for. With this we have done it. Everybody got it? You can solve this question. You can solve this question. सर हमको कॉलेज एग्जाम में पूछा था SHM का डेरिवेशन, बुक में एक्सेलरेशन तक ही दिया है बट मैंने जर्क तक का तो पता नहीं. Okay. Definitely dear, that is the beauty you are getting here. Okay, so guys, I feel you can do this question. You need to find out the value of jerk. Go for differentiation 3 times. You will get the answer. So shall we take the break now? Okay, Shujish have already given the answer. Shall we go for the break now? Today nobody asked for the break. Very good. D is the right answer. Very good. D is the right answer. Okay, very good Midun. बहुत ही बढ़िया. मजा आ गया. So guys, we have completed vibrations and cams. Still we are left with governors, gyroscope, gears, balancing. So guys, for this we hardly required 2.5 hours. So let us take a break, and only one break we are going with, and after this break we will go for these 4 topics fastly, because now for GATE exam they are simply formula based topics. Yes, in gear train it is slightly bigger, but balancing you need to go for majorly up to reciprocating parts. Okay, that would be coming into the paper. So when we are talking, because those diagrams are important for ESC conventional, okay, they are not important for GATE. So guys, this is something we are going to see after the break. So time is 2:10. We will start by 2:30. Okay, so class will resume at 2:30 p.m. So guys, do not miss this, okay, because this is very important. Teju, in GATE they generally do not ask, but I will teach you, don't worry. So let's meet after 20 minutes guys. Okay, so just take your lunch, come back, and we are continuing from 2:30 once again. So from 2:30 to 4:30 to 5. Okay, 5 p.m. I will leave you. Okay, 5 p.m. we will be completing all the things. So let's meet after 20 minutes. Topic yet not decided beneath, but I feel maybe two topics I will be taking. Okay, so out of them, two topics I will take. So I will tell you in the Telegram or WhatsApp. Let's meet after 20 minutes. Yes, guys. Am I properly audible and visible? Meeting once again after the lunch break. How beneath? Definitely. I will try to take truss and friction. Okay, let me share it again. Yes, guys. So we are continuing, guys, from here. Now the next topic is governors. We have discussed at the time of flywheel when we were talking about instantaneous fluctuation control devices. At that time, I told you governors are required for controlling the fluctuations coming from outside. For controlling the fluctuations coming from outside. Okay. Or in other words, we can say that intercycle, like interbank, interbranch transaction. So intercycle fluctuation, for that purpose we are going to use them. So guys, this was also required by Sir James Watt for the first time when he have made the engine, and Sir James Watt is said to be the godfather of this field again, and governor was also for the first time have been introduced by Sir James Watt. And why it was introduced, first of all we need to see that. When he have made a locomotive engine, you know, single slider crank mechanism was the accepted inversion for this purpose of making the steam engines. When they started making it, what was the problem actually? When they have made it, you know that engine is giving us some power. Okay, then what is going to happen? When we have seen the efficiency with velocity, so the curve between these two was coming like this. For a particular range of velocity, we were getting maximum efficiency. Because of that, Sir James Watt wanted to run his engine at that speed where he would be getting the maximum efficiency. This was the target actually. But to work in this region, he wanted that constant speed. But the point is, whenever the load, like he was having a locomotive, let us say, in that locomotive 10 persons are coming inside, load will increase. So because of that, speed was getting reduced. And when 20 people are going out, load will reduce, the speed will increase. So it was not possible to work within this range. So that is the reason why he wanted some device which will maintain the speed of his choice. So governors are generally trying to make the speed, desirable speed. So generally whenever I ask that whether we are going to use the governors in the IC engine, in the automobiles, then people are saying yes. Then I ask them a question, if you are going to use the governors in automobile, governor is going to make the speed to be constant. Let us say governor is getting an information that you need to keep the speed to be 60 kilometers per hour. Whenever you would be there in the city traffic, you will try to reduce the speed. But governor will once again take it to 60. If you are at the highway, you will try to take 100 km per hour, but governor will take it to 60. So we don't want that kind of governor in automobiles. In automobiles, we are going to have partially governed system. Partially means speed we will decide, governor will be there, but partially governed means speed is generally decided by us. Okay, but in case of generator, there is no driver who will decide the speed. So there we can keep the speed to be fixed. Okay, and there we can instruct the governor that we want the generator to be running at 600 rpm. So whenever there the speed is getting increased because of reduction in the load, then governor will increase the fuel supply if the load will increase, and governor will reduce the fuel supply when the load will reduce. So this is how governor would be working with an engine. Okay, so my dear, governor is going to govern the fuel supply actually. So fuel supply is governed by governor. So governor will either increase it or decrease it to get the constant speed. That is the work of governor. Okay, I feel you got it now. The function of the governor is to regulate the mean speed of an engine. Why? Because in case of generator, if you are going not going to maintain the speed, speed is associated with the voltage. If the speed will increase, voltage will increase, speed will reduce, voltage will reduce, which can harm your devices. So now we are going to start with the governors. Actually, there are two types of governor. One type of governor is centrifugal governor. Second type of governor is inertia governor. Second type of governors are inertia governors. So when we are talking about the centrifugal governor, here the governing force, here the centrifugal force is used as the controlling force. Whereas in the inertia governor, we have the combination of centrifugal plus inertia forces. So as there are two forces, no doubt about that, inertia governor can give you better results than that of centrifugal governor. But at our level, we are starting with the centrifugal governors because in our syllabus, only centrifugal governors are there. Out of centrifugal governor also, first is the simple pendulum type watt governor. This was the very first type of governor came into picture. This was not a working governor actually in reality, but this was the starting point, and every person adopted the same principle as given by Sir James Watt. That is why he is said to be the godfather, first god of this field. After that, my dear, second category is dead weight loaded type governor. In dead weight loaded type, we have Porter governor and Powell governor. Okay, here dead weight is used. I will tell you how. And then the third category is spring controlled governor. Then we have introduced the spring into that. Then we have Hartnell governor, Hartung governor, Wilson Hartnell, and Pickering. So my dear, out of this, which governors we need to study? We need to study simple pendulum type Watt governor, Porter governor, Powell governor, and Hartnell governor. Only up to this we need to see. Other than that, we need not to see. Okay, yes, so we need to see only this much types of governors, okay, for our examination purpose as per the syllabus. But I would like to say that this Pickering governor was used in gramophones. That question have been asked many times in ESC paper. Moving further, guys. So first of all, we will be talking about the Watt governor given by Sir James Watt. Okay, so my dear, whenever we are talking about the governor, first of all, you are having a spindle actually. Here there is a very thin shaft. Here there is a very thin shaft actually present. And this thin shaft is said to be spindle. Is it clear? Is it clear? There is a thin shaft said to be spindle. And my dear, after that, we are having two arms. And these two arms are joined with the fly balls. And then we have two links. And links are attached with this. This is said to be sleeve. Sir James Watt have taken massless sleeve. When we are talking about the governor, characteristic of a governor. So my dear, for a governor, when we are talking about, you can say performance of a governor, I will say two governors have same performance if For two governors, sleeve position is same for same speed, because performance are associated with the location of sleeve. Location of sleeve, which is a function of velocity. Which is a function of velocity. So my dear, it is going to be a function of velocity. If that is the case, when velocity will change, the sleeve position will also change. Okay. Then my dear, whenever these governors are designed, they are not, I will say, universal device that you will go to the market and purchase one. Governors are generally designed actually based on the requirement. So let us say you are going to make a governor for a generator. Then you come to the home, you are going to make it, let us say. So you know that that generator is having the maximum capacity of 2 kilowatt. So for this 2 kilowatt, you will be going for two tests. In one test, you will be switching on all the appliances. When all the appliances are switched on, you know that maximum power would be utilized. At that time, load is more, speed will be less. And at that less speed, it would be having some location. And similarly, when you would be having all the appliances switch off, we would be having one more position for the maximum speed. And these two locations we would be recording in this entire sleeve. And there we will be applying the stoppers S1 and S2. So your sleeve will move only within the stoppers S1 and S2. Yes, Bhavya, good afternoon. No issue, Bhavya. You can watch according to your convenience. Okay. Right now, we are having governors, and don't worry, we will try to complete it before 5 p.m. So guys, this is something going on with the governors. Okay. This is something going on with the governors. Fine. So guys, when we are talking about this, there are some very important parameters we need to consider. So this hinge point is very, very important, because every time we are going to find out the height of governor with the help of this point only. From this point to the fly ball, this is said to be the height of governor. And from this governor axis to the fly ball, this is said to be radius of governor. This angle is said to be theta, and the angle which is made by this link, it is said to be beta. So there are four things: height of governor, radius of governor, theta and beta. All these four parameters are not going to be independent, because if you change any one of them, all four will start changing. All four will change. So that is why I will say they all are not independent. They are depending on each other. So if that is the case, my dear, if any one of the parameter will change, all others will change. This is the condition of Watt governor. But the point is how this Watt governor will be acting actually, how it will be working. So my dear, actually you have seen this. After this, you are going to have a special type of gears, which is mid-tray gears. With the mid-tray gear, governor is directly attached to the engine. Mid-tray gears we will see at the time of gear. So you know, engine will be rotating at a speed of omega. Mid-tray gear replicate the same speed. So spindle will rotate with the same speed. And because of this speed, obviously fly ball would be having a force of mr omega square like this. Okay. So because of that, the fly balls, it is like fly balls are moving like this about the spindle axis. If you want to feel this type of governor, you can feel if our hands are attached to the head, then the hands are going like this. And if I am going to rotate, so this kind of motion you will see. Okay. So these hands would be like this. This kind of motion you will see. But those hands are attached here. Okay. So this type of motion, this is how it will happen. This is how the governor is working. But how the things are happening, how speed is becoming constant with this. So what is going to happen? We have attached this with the mid-tray gear so that the same speed which is with the engine should be there with the governor. We wanted the same feeling for the governor which engine is having, which engine shaft is having. So they are rotating with the same speed. Now my dear, by chance if load is going to increase on the engine, it will result into the reduction of speed. It will result into the reduction of speed. It will result into the reduction of speed. Okay. So when you would be having the reduction of speed, then my dear, when engine speed will reduce, obviously governor speed will also reduce. And when governor speed will reduce, then my dear, this omega will also reduce. So if that is the case, you know this mr omega square is the reason behind this rotation. If mr omega is getting reduced, my dear, you know that a downward force mg is also there. Mg will be more effective because it is constant. So when this omega will reduce, these fly balls will be coming to the new position like this. Fly balls are attached with the sleeve. When they are going to go down, sleeve will also coming down like that. Now my dear, sleeve is attached with a bell crank lever. And this bell crank lever is going to decide the position of valve. The valve is going to decide how much steam it shall allow. So my dear, when this is coming down, you know that this will be the new position, as the load have been increased, this sleeve will open more and more steam will go. So the point is, when the load is increasing, this sleeve will be opening, this valve will be opening, and when the load is getting reduced, speed will increase. So because of that, here the valve will getting closed. So my dear, everything is happening according to the sleeve motion, because sleeve motion is replicating in the valve with the help of bell crank lever. Bell crank lever is in blind love with sleeve. It will just follow the motion of sleeve. Is it clear for everyone? Everyone is getting it? Please tell me that. So my dear, this is how the governor is working here. So my dear, as the load will increase or load will reduce, based on that, this valve will open or close. This was the first configuration of a governor which was given by Sir James Watt. So it is said to be Watt's governor. This is how the motions are happening. Sir James Watt have taken this sleeve to be massless. This sleeve was taken to be massless. And spindle was taken to be frictionless. So at that time, he have taken this because this was the very first time. So they were not having the ideas about the results, what are going to happen. So they have taken this kind of configuration for that. Okay. So my dear, after this, what is going to happen, I am telling you. Now this is said to be simple pendulum type Watt governor. And we will see analysis of this, and then also I will tell you the 3 types of configuration of this. There are 3 types of configuration for Watt governor. One configuration is itself, this is said to be simple Watt governor. Then there is one more configuration, that another configuration is shown like this. This is the real position of our hands, like we have. This is said to be open arm type. There is something called as crossed arm type. This is crossed arm type. So these are the 3 very, very important configuration of the Watt's governor, guys. So just like and share the session. We are still having 2 more hours of sessions. Okay. So when we have this, now let us go for analysis. We will analyze this fly ball. If you will analyze this fly ball, you know there is a force acting mg downward, outward mr omega square, and there is a tension T. You know this tension is coming in the arm, which is making an angle of theta. So this angle is theta. If that is the case, Then you can write T cos theta to be mg, T sin theta to be mr omega square. Equation 1, equation 2. You can divide 1 by 2. Then dividing 1 by 2, you would be getting what? Tt will get cancelled out. You will get tangent theta as r omega square upon g. Now you know that tangent theta, when we are talking about, guys, this is the r radius, this is the h height, this is the theta. So tangent theta can also be written as r by h. Putting this value rr will get cancelled out. Omega is 2 pi n by 60. G is 9.81. After putting the value, you will be getting h is equals to 895 upon n square. This is the governing equation of what governor? Okay, this is the equation of what governor? It is said to be the dynamic equilibrium equation. Why dynamic equilibrium? Because system is not at rest. System is moving with the constant speed. Fly balls are rotating at constant speed. Why I am saying constant speed? Because at some instant when I am talking about, it would be rotating with one speed only. No doubt. Otherwise, when the load will increase, the speed will increase, the sleeve movement will be there, everything will happen. But at that instant when I am talking about, it would be moving with constant speed. So dynamic equilibrium we have used for this case. Is it clear for everyone? This is the equation for Watt governor. When you see this equation, my dear, you will get to know that this Watt governor is effective only up to 60 rpm. Once you increase the speed from 60 rpm, its effectiveness gets reduced. What do you mean by effectiveness of a governor? Dear, if the load is changing, because of that speed is also changing. But if speed change is quite more, but the sleeve movement is not happening. If speed increased by 100 rpm and sleeve is not moving even by 1 mm, it means it is showing low resistance or sensitivity. It is like when someone comes to you and slap you, you are not reacting because you are feeling it was not a slap, it was just a click. So that is your low sensitivity. Sometimes you are going to have a fight with a person without any reason. This is the more sensitivity. So when, my dear, governor is not reacting to the change of speeds, it is of no use for us. We will be saying the sensitivity of governor is going very, very less after 60 rpm. As the speed will increase, sensitivity of governor will reduce, because in the denominator we have n square factor. So, my dear, that is why this governor was not utilized at that time. Even at that time, even the maximum speeds of the engine was the maximum speed of the not maximum actually, I would like to say the minimum speed of the present engine at that time was 200 rpm. Means the poor to poor engine was having a speed of 200 rpm at which they are running. Let us say there are 5 engines, so the speed which was having minimum speed by which it can run, it was 200 rpm. I feel you are getting it or not, what I want to say. Like everything have its maximum capacity. Like one engine can run up to 5000 rpm, one can run up to 200 rpm. So at that time we were having the lowest possible value for maximum speed of an engine as 200 rpm. So for that also this governor was not able to use. So guys, that is why this governor was not a working governor. Then, my dear, there was a very, very big mathematician, that is Sir Alan Porter. Not Harry Potter, it is Sir Alan Porter. He was a very big mathematician. He tries to find what was the mistake done by Sir James Watt. By rectifying that, he can make the working governor, and he definitely succeeded into that. He was a person who have given the first working governor. So what he have done? He have done one thing. First of all, he increased the weight of sleeve. Because after his 2 to 2.5 years of study, he get to know the reason behind insensitivity of Watt governor is there is no load present on the sleeve. So first of all, he have kept a very heavy load onto the sleeve of Sir James Watt governor. That is why this comes in the category of dead weight. That is why it is said to be dead weight loaded governor. You might be saying, sir, when he is doing that kind of thing, he is increasing the inertia. You are correct. Inertia is more for this type of governor. But my dear, at that time, inertia was not the priority. At that time, the priority was they need to make a governor which is working. Is it clear? Please tell me, are you getting it or not? Clear, guys? हाँ भाई, आदित्य, मिथुन, तेजू, मलेश, भव्या, मानस, very good. Wonderful, guys. Wonderful. So guys, when he have put this inertia, he was knowing that people would abuse him for this kind of inertia. But at that time, priority was not that. Priority was to make a working governor. So he have added the weight onto the sleeve. And my dear, this weight was minimum 5 to 10 times. As I said, the weight W was minimum 5 to 10 times of fly ball. Okay. So minimum 5 to 10 times of weight was added than that of fly ball. And my dear, when it was done, now this governor started working. And why that kind of weight was added? Because my dear, he wanted, at least when he is making a working governor, if Sir Watt's governor is not capable of working at 200 RPM, if Porter governor is able to work at that speed, then it is also once again said to be of no use. So he made a governor so that it can work at least 200, 300 RPM, 2000, 3000 RPM. So up to that much speed, if his governor is working, then only it would be accepted by the peoples. So he wanted to make a governor which is working for the engines, maybe with more inertia. So that is why his governor was the first working governor. It worked well for 2000, 3000 RPM speeds. And guys, at that time, this was the first working governor. When we are going for the analysis of this, my dear, so this time you can see, first of all, we are going to see one side only, because you know that this is symmetry from both the side. If you see, they are same, so we can take one side. When we are taking one side, you are taking half the load. Half load is taken care by right hand side fly ball. So W by 2 here. This is centrifugal force. This is, you can say, I can also feel it as small mass m, and you can feel the sleeve to be capital mass M. So you can say this is capital mg by 2, and we can say this small mg. Okay, this is the centrifugal force. This is the tension T1. This time we are having tension here also, because in the last case sleeve was most massless. So arms were not having any kind, links were not having any kind of tension, only arms were having the tension. This time both arms and links will be having the tension, because sleeve is also having the mass and fly ball is also having the mass. That is the reason behind that. Let us move to the further. And guys, if you are going to see this, you can see this is W by 2, this is T2. So if you want to find out the tension, you can use T2 cos beta as mg by 2. So T2 will be mg by 2 cos beta. So we found out the tension T2. If you want to find out T1, this tension, then you know that T1 cos alpha, T1 cos alpha, if you are going to say T1 cos alpha will be this. This is T1 cos alpha. It can be written as mg, plus T2 cos beta, which is mg by 2. So you can find out T1 cos alpha is mg by 2 plus mg plus T2. Okay, T2 cos beta we have already seen. So this is the value, and you can find out T1 from that. Sometimes they can ask you the value of T1 and T2. So for that purpose, I have told you that. Then my dear, we will be going for the analysis of this to make the dynamic equilibrium equation. When you will be making that dynamic equilibrium equation, you would be considering a I center. For that, what we are doing, you know, this fly ball is rotating like this. But whenever you would be having any change of torque, any change of load, you know this will be moving in this direction or this direction. So because of that, perpendicular to velocity we are sitting. Here also sleeve is moving in this way, perpendicular to the speed we are moving. Okay, perpendicular to the speed we are sitting. Then my dear, there is a triangle you can see. And if you see this, this point is given the name of I center. So we can take the summation moment about this to be 0. Body should be in equilibrium about this, because whenever we are having the rotation motion, the relative motion of one link is pure rotation with respect to other about I center. So about I center, the relative motion of fly ball and sleeve, relative motion of fly ball and sleeve is going to be pure rotation. For pure rotation, my dear, at constant speed, the summation moment should be 0 about this. So we are going to keep summation moment to be 0 about this. You know, there is one force which is mg by 2. But if friction also would be taken into consideration, I will say plus minus f. Why plus minus f? Because friction can be upward or downward based on the tendency of motion. At the time we are talking about, we are taking the sleeve at rest. But either sleeve will be having a tendency to go down or will have a tendency to go up. Based on the direction of friction will also change. So my dear, we are assuming tangent beta by tangent alpha to be k or q. Tangent alpha is r by h, you know. So when we are going to take the summation moment about I to be 0, shall I go for the derivation or shall I directly give you the result? Shall I go for the derivation or directly give you the result? I can do derivation, you know my habits. I never mug up the values. I always believe in deriving it. Okay? Yes. Shall I directly put it? Okay, results. Directly results. Okay, you want to save your time. I also do the same. So we will be having the equation like this. N square is equals to 895 by h. Up to this we were having volt also. But this is having one extra term. M plus m by 2 1 plus k divided by m. This is when we are assuming friction to be 0. Majority of the cases we will not be considering friction into picture. If you consider, then you can write m plus minus f by 2. Otherwise you can replace m by 2 with this. This is the dynamic equilibrium equation for Porter governor. So we were having a positive point. This was the governor, which was the first working governor. Up to 2000, 3000 RPM it was working well. Okay, but still we were not happy because of the inertia of the governor. So one other person was trying to reduce the inertia of this. The name of that person was Proel, and he have given one more configuration to reduce the inertia of governor. The name is Proel governor. That is also coming in the dead weight loaded category. So I would like to say that okay. Are you saying this 2m in the denominator? Are you saying this? GG is cancel out. Okay. Dear, K is tangent beta by tangent theta. This can be shown by Q also. We have taken this angle to be theta, this angle to be beta. Okay. Is it clear now? Everyone? Fine. Clear for everyone? Fine. So guys, now what Proel have done? Proel have not kept the balls to be the extension of the link. He kept balls in this configuration. If you find any problem with the formulas, I will be sharing you the handwritten notes as well as the formula notes, which are short notes, in the Telegram channel after today's session. So for remembering the formula, you can directly see that also. Okay, and we are also coming with the formula series where we will be coming only with the formulas. Okay, those PDFs will also help you to remember the formula. Okay. Yes, Ganesh doubt now I would be answering. Actually, Ganesh was asking one thing. Sir, why from eye center the motion looks like rotation? General motion looks like rotation. So my dear, actually, I am not saying the real motion is rotation. Real motion is general only. But my dear, that general motion is having two components, translation and rotation. In relative velocity method, what we have done, we have given the translation component to the person so that he can see the relative motion, which was a pure rotation motion. It was very easy to understand. But in eye center, why we face issue? Because we are not having any kind of visuals for that. So my dear, for that, how eye center was defined, you shall go into that, how eye center was defined. Actually, whenever some body is in pure rotation, then velocity is perpendicular to the radius. So velocity is perpendicular to the radius in case of circular motion. So the idea was, if we are having a circular motion, then radius will be perpendicular to the velocity. Means if you are sitting at the radius, you will feel the velocity is perpendicular to this line. Then my dear, that's why. Okay. So I feel my equation is correct. That's why I was saying that why you are saying this 2, because this is from the typed only. Okay. So I feel I have written it correctly only, because then this will also be coming 2 if you are putting this 2. If you want this 2 to come here, then here also it will come. Is it clear, Manas? That's why I always wanted to go for derivation, because I do not mug up the equations. Okay. Is it clear? So if you want, I can go for the derivation also, or you remember it is fine. Everybody, you can see this. The same equation I have written. Wonderful, guys. Bahut badhiya. So you guys said that, sir, you have written wrong. That's why I said that I have written right only, but still I will share you the notes if you want. Okay, guys. Now let us see that. So guys, now when we are talking about this motion, so pure rotation says velocity and radius are perpendicular to each other. So if you are sitting here, you will feel the velocity is perpendicular. You will always feel velocity is perpendicular to the line where you are sitting. So what Sir Arnold Kennedy have done, he said we would be sitting at a line perpendicular to the direction of velocity. So he just went in the opposite direction. He said, you first search for the direction of velocity. Once we know this is the direction of velocity, then we will be sitting perpendicular to this. And when you will be sitting perpendicular to this, it means you are feeling that velocity is perpendicular. And this feeling is guaranteeing you for the circular motion, rotation motion. So you will feel that motion is rotation. So that is how when you are sitting on a line perpendicular to the direction of velocity, from there you will see the motion to be rotation. And if you are going to draw more than one such line, then my dear, obviously some other line may cut it at some point. So that point will act like a center. So that point was given the name of eye center. So this is the point from where you can feel the motion to be rotation, but only for that one particular instant. At the next instant, it would not be circular again. It is like we want to see it in that way. Like if I am going to, like you have seen in the politics, many speeches are given. Okay, like any politician give any speech. I want to make your thinking about him of such level. I will be taking a clip and I will be showing you only that. So for that instant, you will be feeling that person is like that. But only this is the feeling for that instant. If you will see the complete speech, your feeling will be broken. So only for that instant, when this center is defined, we will say it instantaneous center. At the next instant, this point is not going to give you rotation. So this is just a kind of feeling. For that instant, you can feel the motion to be rotation about that point. So we are using all the rotation motion formula for that eye center. At next point, you need to once again search for the eye center. Got it, Ganesh? This I have told you in very brief. When I have taught this in the classes, I have taken hours into that. Is it clear? Is it clear for everyone? Yes, my dear. So we just need to put the summation moment about this is to be 0, and we would be getting this formula. Okay, moving further, we are going for Prowell. So Prowell have not put it the fly balls to the extension of arms, but he welded it with the turning pair of these two links. I would like to tell you always the radius is not measured with the flywheel. No, radius of governor is measured with this turning pair. In some of the books they have done this wrong. Radius is always considered with this turning pair. Now on this you can attach the fly ball like this also, like this also. That is your choice. Okay, because this is welded now. This is welded now. So guys, when he have done this, what kind of change he got? You might be thinking, previously fly balls are like this, now we are having the fly balls like this. So when fly balls were taken like this, because of that one magic happens. Because of that one magic happens. You know, for that there is a complete derivation. Once again, we are not going into that, because for examination, GATE examination, we do not need those explanations. They are required for interview purpose. Okay. So if I go for those things, governor itself will take 6 to 8 hours. But I am just giving you a remembrance that I told you that why this whole work was done. This was done to reduce the inertia. But Sir Prowell don't want it to touch this sleeve. Because of the weight of sleeve, my dear, this governor is becoming sensitive at higher speed. So what he have done, he have just taken the fly ball to be in this position. And when he have taken this, my dear, now what he got, he have reduced the minor inertia. He was able to reduce the minor inertia. What do you mean by that? This time, my dear, if previously 3 kg of fly ball was required, by doing this 1.5 kg of fly ball was going to give you the same thing. So by doing that, the fly ball weight gets reduced. So minor inertia got reduced. Why this come? For that we don't need to go for the derivation, but I feel derivations are not required. When you will be going with the derivation, you will be getting this type of result if I show you. Okay, but I feel remembering that is going to be wastage of time. So you would be getting something like that. You can see this is C by E, mg A by C. What are these distances? This E is the distance of this fly ball. This distance is the R, this distance is the R1. And you know, this distance is A, this distance is B. And this force is mg plus minus F by 2. Why half? Half will be for this part, half will be for that fly ball. Okay, so when you would be putting K is equals to tangent beta by tangent theta as usual, what you would be getting the final result as this. Final result as this. Final result as this. I am showing you that. This will be coming out to be n square 895 by h into, if you are taking 2 mg plus minus F by 2 mg 1 plus K into you would be having A upon E. So my dear, I have written the equation with my derivation now. I feel now you would be remembering this equation because in the classes I use this. If we are using this much, this is the equation for watt governor. Yellow one is giving you the equation for watt governor. This will give you the equation for Porter governor. This will give you the equation for Porter governor. So when we are talking about the Watt governor and Porter governor, my dear, when we are going to talk about Watt governor and Porter governor, why this term was introduced? This term is very, very big as compared to 1. Why? Because this capital M is 5 to 10 times more than the small m. So because of that, this term was very, very big as compared to 1. When we have multiplied this, you can also write it in this way. To feel it, n square and h can be replaced by their position. You can say here is h, here is n square. So to reduce the effect of this n square, we have multiplied this with a very big term. So because of that, governor became sensitive. Powell, what he have done? He have multiplied it with the factor a by e, which is less than 1. So if this factor is once again less than 1, don't you feel from Watt you come to Porter? Now from Powell, when you are doing it, Powell is doing the opposite journey. Because when this factor is less than 1, what we have made this, it would be reducing the effect of this. But why we want this? We don't want to do that. Why we go towards Watt when we have the Porter governor? So Powell was knowing that he wanted, if not better, at least the same characteristics, at least the same performances as given by the Porter governor. So to keep those performances same, he need to nullify the effect of a by e. If we want to nullify the effect of a by e, he need to increase this factor more. To increase this factor more, there are two things. Either, my dear, either he increases the capital M or he reduces the small m. If he reduces the capital M, if he increases the capital M or he reduces the small m, both ways this factor will be increasing. And overall he want to make it same as that of Porter. So why he will increase capital M? He will reduce the small m. And when he reduce the small m, my dear, when he reduce the small m, my dear, because of that the mass of fly ball get reduced. So previously, if you were using a 5 kg fly ball, now you can do the same work with a 2 kg of fly ball. So that is how the minor inertia got reduced. No doubt we were more worried about major inertia, which was 5 to 10 times than that of this 5 kg. Major inertia is 25 to 50 kg, but we are reducing these 3 kgs. 3 plus 3, 6, because there are 2 fly balls. So when you are doing this, no doubt this is nothing as compared to major. But my dear, nowadays, even if you are going to reduce the weight by 1 gram, it is said to be lifetime achievement. So here at least that reduction was there. So because of that, after that, whatever the governor which have made, there they have followed the Powell configuration, and fly balls were kept like this. Fly balls were never kept like this after Powell configuration. Please tell me, everybody, if you got it or not, and just like and share it. So guys, the thing which I explained you in 2 hours in the course, I tried to explain within 5 minutes. Because here if we go for those explanation, governor will take 8 hours. Here we are completing everything in 8 hours. Because they are revision session for those students who have already studied the things. This is just for their revision. Now we are talking about the Hartnell governor. So my dear, Hartnell governor were coming to reduce the major inertia. Hartnell tried to see actually what is the work done by the sleeve mass. What is the work done by the weight of sleeve actually. So he found that if this is the sleeve weight W, then it is just giving a force component in the downward direction. It is just giving a force component in the downward direction. So if I produce that component by any other way, I need not to go for this. So the idea was to create a force in the downward direction anyhow. So they have kept a spring in compression. If a spring is in compression, it will give a force in downward direction. So the same thing which was done by this very, very heavy load can be done by that compressed spring. This was a wonderful idea created by Sir Hartnell. He is considered to be the second god of this field, and he have given the wonderful governor said to be the Hartnell governor. After Watt governor, if some major changes happen, they were at the Hartnell governor. And after that only spring governor, spring control governor came into picture. Some persons have made it too spring to make it more stiff. some persons have made the change in the type of spring, they converted helical spring to leaf spring. Only those kind of minor changes have been observed after that. So major change of that kind was done by Hartnell only. After that, Pickering, Powell, Wilson, whatever the governors came, they have not done major changes in centrifugal governor. But as the concept is used, given by the Sir James Watt, so we are using it as a centrifugal force only. That is why it is said to be centrifugal type of governor. Is it clear, guys, to everyone? Please tell me that. So when we are coming with this Hartnell governor, now this everything would remain the same. And you can see, like Powell, they have also kept it like this. Like Powell, they have also kept it like this. Arms are kept like that. Okay. So when you are going to analyze this is the animation for that. You can feel it. If you want to see the working, you can see this is going to be the hinge point. And you know, if this distance was considered as A, this considered as B. So my dear, obviously when the speed will be reducing, the fly ball will be coming in this direction. So R will reduce to R1. Okay. So it is coming right side by C1, and this is rotated by an angle of theta1. Bell crank lever will be having that angle to be 90 degree only. There is no change in that angle. So B became B1, A became A1, 0 becomes C1. So when you are going to take moment about A to be 0, you would be getting this equation. F1 A1 cos theta 1 mg plus Fs1 plus F. What is that? Plus minus F. This is friction force. Generally, we ignore the friction force in this governor analysis. This Fs1 is spring force. Why we are not having spring force to be negative? Because spring force is always acting in the downward direction. So it is not possible to have upward direction. So that is why we are keeping always plus here. So when you will be taking moment about this to be 0, summation moment about A to be 0, you know that there will be a force M1 R1 omega square. M is same, R1 omega 1 square into, if this is, I am taking, this is A. Okay, let us consider, you know, this is the distance now. Okay, so why we are having that kind of thetas and all, you can put it like this if you want. This I have kept it as A1 cos theta 1. Okay, otherwise you can feel it some distance. Okay, like if I consider this to be A2, you can directly like A2 here. Then you have mg force. Mg is creating in the opposite direction. So it is minus mg into C1. Okay, then you would be having one force like this. This is creating in the same direction of mg. So minus mg plus Fs1 by 2. And that is once again B1 cos theta 1. So this is equals to 0. When you will keep it, you will get the equation M R1 omega 1 square A1 cos theta 1 is equals to mg C1 plus mg plus Fs1, assuming friction is 0. Okay. So my dear, this is one equation. Similarly, you can derive the equation for second condition. Now solving these two equations, you can find out the unknowns. Okay. So there is no point in going into these derivation, because generally this will not come in paper. In paper, they will be giving you some simple things, which is that when A1, A2 becomes A, B1, B2 will become A, C1, C2 becomes 0, then you will be having this equation. That is spring force in the second position, spring force in the first position, 2A by B, F2 minus F1. What is F2 minus F1? F2 is mr omega 2 square, F1 is mr omega 1 square. So this is what you can remember. This is what you can remember. Okay. Now if you want to find out the stiffness, it is going to be 2A by B, F2 minus F1. Okay, this is H. H is the total lift, and you can find out the stiffness using this formula. This is the formula actually. Is it clear? Everybody got it? You can also derive the stiffness in this way. This is another formula you can remember. So I am putting the formulas in the brackets which you need to remember. Generally for stiffness this will be more useful because you would be given F1, F2, R1, R2, A and B. You can directly find out stiffness from this. Please tell me guys, everybody is ready? This subject is having different level. So you have seen machine design were having several topics. We have completed like this. Here a lot of explanation is there. So I feel you got it. Let's move further. Let's move further for the properties or characteristic of a governor. Characteristics of governor. So when we are talking about characteristics of governor, the very first characteristic is said to be the sensitivity. First of all, tell me, is sensitivity is desirable property or not? Desirable characteristic or not? Sensitivity is desirable or not? Manas, that I will inform you on Telegram channel and WhatsApp group because I need to check your aptitude and mathematics timing. I was not aware of that, otherwise I could have not kept the same timing. But definitely if that is the case, we will change the timing and I will inform you the new timings. Yes. Okay. Don't worry, I am not taking any cold drink and all. I am just taking water. Okay. Okay. So we are moving for the sensitivity. So guys, sensitivity is desirable property, but within some ranges. Okay. Within some ranges, no doubt about that. Because if sensitivity is beyond a range, then also it is harmful. If it is less than some value, it is also harmful. It should be there within some ranges. So when we are talking about the sensitivity, it is defined as n mean by delta n. So if we are going to say sensitivity, it generally tells us the kind of output you will get for a given input. So if you are having more sleeve movement for a change of speed, sensitivity is more. Or for the same sleeve movement, if change of speed is less, we will call it more sensitive. Very good, Azharuddin. So this is how we will define the sensitivity. So my dear, when we are talking about this, in some of the books or some of the authors, they also write it as delta n by n mean. Okay, in general, this is said to be coefficient of insensitiveness. But still, if they say this is not in option, if this is not in option, and they say that the sensitivity for a governor which is clubbed with the engine, then you can go for this option as well. Because in the option, if you don't have the correct one, then what you will do? Okay, for that case. So next is the stability of a governor. So my dear, there are three types of equilibrium. Like if we have a ball like this, you are going to displace it like this. If it come back, if this come back, this is said to be the stable equilibrium. And if governor is going to follow this, we will call it as stable governor. If we are going to have this like this, you know, if a slight touch is given, it will go away. That is the condition for unstable equilibrium. If we have a flat surface, one ball is moving, you are going to give this motion, it remain there. This is the neutral equilibrium. So in other words, if you have a sleeve like this, you are going to take this sleeve down by 1 centimeter. If you are doing it, but as you take it 1 centimeter down, if it go back to its original position, then that is said to be the stability of governor. That is the condition of stable governor. If it remain there, it is said to be neutral. If it come back, but come back by more amount, then it once again go back by more amount. Then, or it is going away once again. You are taking it 1 centimeter down, it goes 5 centimeter down without any reason. Then it is unstable governor. So my dear, in other words, for stability we generally says that if R increases, N increases, R decreases, N decreases. This is the condition of stability. If R increases, N decreases. If R decreases, N increases. This is the condition of instability. If N is going to be constant, whatever be the R, this is the condition of isochronous governor. I will be giving you a feel of isochronous governor. Name, everybody have listened to it. What is the feel of isochronous governor? Everybody have seen Crime Patrol? Everybody have seen Crime Patrol? Crime Patrol, Savdhan India, that kind of serials. Yes, those are special type of serials where police solve all the cases with 100% efficiency. So you have seen there what happens. First of all, criminal is doing some crime. Then police get to know about that. Police try to search him using the data of phone, and they are going to just find out that person. And then that person is sent to the jail behind the bars. But just imagine if police is getting to know, they get to know that crime is going to be performed tomorrow. Then they will try to stop it. And my dear, crime will not happen. Similarly, up to now, what was governor doing? What is stable governor? If load increases, speed will reduce. Speed will reduce, governor will reduce the fuel supply. Sorry, governor will increase the fuel supply. If load reduces, speed increase, governor reduce the fuel supply. So that is happening when load was increasing or decreasing. But you just imagine, when load increases, speed reduces, governor increases fuel supply, once again we reach to the same speed. If all this happens in the zero time, means governor already know load is about to increase, governor increase fuel supply, load is about to reduce, governor reduce fuel supply, and my dear, speed will remain constant for the engine. Means everything is happening in zero time. It is not possible. That is why isochronous governors are not possible. So isochronous governor means all the things are happening in zero time. But time is required to happen for that. That is why isochronous governors are not possible. So stable means for which right actions are being taken. Unstable means it is going in opposite direction. And neutral means isochronous. Isochronous, I told you. I feel you got it. Isochronous we already have seen. So isochronous governor is something for which delta n is 0. If delta n is 0, sensitivity is n mean by delta n. This is a governor with infinity sensitiveness. And stability and sensitivity are inversely proportional. So if sensitivity is infinity, stability is 0. 0 means neutral equilibrium. All these things we have seen, guys. Now hunting. So my dear, when a governor is having more sensitivity, it is said to be hunting. Means it is a condition of oversensitivity. When someone comes and just do this to you, you says he have slapped me, and you just give him 5 to 6 slaps. This is your more sensitivity. Okay, this is the more sensitivity. So this is the condition when governor is becoming extremely sensitive. Only speed increased by, speed decreased by, increased by 5 RPM. But my dear, motion of the sleeve happened that much, which should happen for 50 RPM change. So my dear, sleeve movement is 10 times. So what will happen? Previously working speed was 250. It changed to 255. Because of that, 2 mm change was required. 2 mm movement was required. But movement happened 20 mm. So because of that, now the speed will reduce to 225. Now this time you can see changes 255 to 225, 30. So because of that, some movement is required. But movement will happen more because governor is more sensitive. So because of that, initially sleeve will have motion like this. Next motion like this. Next motion like this. After that, it would be just having fight with the sliders. It try to go beyond the sliders. After some time, slider will break. Governor will not be working, and it will create that kind of situation that even many parts of the engine module can get failed. That is why the name given is hunting. It is the hunting of a governor. Actually, it is hunting performed by the governor for the engine particles, for the engine components. So this will create that bad situation. Even the new governor will not be able to make the thing stabilized. So that is why this is the poorest thing to happen. You may be saying, sir, oversensitivity is hunting and extreme sensitivity is isochronism. Oversensitivity is bad, isochronism is the best. Why? The story is of time. My dear, to make that distortion, to make the, you can say, to destroy the component of engine by the governor via hunting, time is required. 5 to 10 minutes of to and fro motion of the sleeve between the sliders, between the stoppers can cause damage. But when you are saying time is 0, then damage will not happen. That is why that oversensitivity will become the best thing and you will be getting isochronous governor. Is it clear for everyone? This is the beauty. Okay, we have seen that. Now, my dear, we are talking about the controlling force diagrams. There is a very big story about that. Even I have taken a concept capsule on the English channel on this topic, controlling force diagram. So we are not going into that much detail because you know that fly balls are having the rotation motion or circular motion. To be in circular motion, centripetal force is required. So that centripetal force which is required to be in circular motion is said to be the controlling force, because fly balls are the most important part of that. So when fly balls are moving in the watt governor, then centripetal force is provided by the tension. So you would be having T sine theta. At that time, T sine theta is providing you the centripetal force. But when we are going to have a Porter governor like this, in Porter governor there are two tension components. One is coming because of this, other is coming because of this. So two components are providing centripetal force. So that is why watt governor can work in slow speeds, whereas this can work in high speeds, because more centripetal force is available to change the direction of velocity. Thanks, Ritvik. Same to you. Yes. Is it clear, guys? Are you getting it? So you remember that kind of thing also will take hours, but I am just telling you in short that here it is provided by the centripetal force is provided by the tension. Here centripetal force is provided by the tension of link and arm both. So that is why this can work in more speeds. You know, for everybody to be in rotation, for anybody to be in circular motion, every time the body will be changing its direction of motion. If a body is moving with constant velocity, it is changing the direction of velocity every instant. So we need a component of acceleration towards the center, which is said to be centripetal acceleration. For that we require a force, centripetal force. If you are having a thread and a stone, it is rotating like this, then my dear, tension is providing the centripetal force. If we are talking about the earth and sun, okay, this is earth, this is sun. You know that for earth to rotate about the sun, it needs some centripetal force that is provided by the gravitational force between both of them. Okay, so similarly, every time centripetal and centrifugal forces are not two new types of forces, they are the resultant of other forces in the direction towards the center or away from the center. We will be having more detailed discussion of this in engineering mechanics. Please tell me, everybody understood that, or you need me to explain much on this? Centripetal and centrifugal force. Here we are not talking about centrifugal, we are talking about centripetal only. I discussed that in the tome first part. This is the second part. Please tell me, do you want me to explain this much? Very good, Manas, Ajay, Malesh. Yes, anybody, if anybody will say yes, I will explain it. We have done it in the first part of tome also, if you remember. When I was teaching you velocity analysis, I taught you that also at that time. So guys, always there is one component which is required towards the center, that is said to be centripetal acceleration. Wonderful guys, बहुत ही बढ़िया, बहुत ही बढ़िया. So guys, when we are talking about this centripetal force, the same is said to be the controlling force, mr omega square, mr 2 pi n by 60 का square. You can write n to be 60 by 2 pi का square. Okay, 1 by square root of m and fc by r का square root. This n is directly proportional to square root of fc upon r. If we make a diagram on which y-axis represent fc, x-axis represent r, this is said to be controlling force diagram. So we can write this fc by r like y by x, like tangent of theta. So my dear, you can say speed is directly proportional to tangent theta or tangent phi. So what do you mean by that? If I am having a diagram where fc is on the y-axis, r is on the x-axis. If there are three lines, this is C1, C2, C3. So first line is making some angle, second is making some angle, third is making some angle. So you can see phi 1 is more than phi 2 is more than phi 3. So it means n1 is more than n2 is more than n3. So somewhere it is telling about the speed variation. So my dear, when we are going to make the controlling force से gate में कैसे question बनते हैं मैं बताऊंगा. I will tell you beneath. So my dear, first of all, if you see this, you will see this. If controlling force diagram I want to make, these blue lines are said to be the speed lines. This is not the diagram. They are said to be speed lines. Then what is diagram? Diagram is which is plotted by experimenters, by researchers. Let us say some diploma person is doing the experiment in the lab. He will take this sleeve, he will move the sleeve by some distances. When sleeve will be moved by some distances, radius of governor will change and also the speed of governor will change. He will note it down and make a curve which is coming like this. Let us say this yellow one, whatever I have plotted, is the controlling force diagram. So this curve is obtained. Okay. If you see this curve, my dear, clearly, you can see this is R3, R2, R1. So you can see there are three speed lines, phi 1, phi 2, phi 3, n1, n2, n3. n1 is more than n2 is more than n3, but if you see r1 is more than r2 is more than r3. So you can see when r is increasing, n is also increasing. You can see when r is increasing, n is also increasing, and when r is decreasing, n is also decreasing. Can you tell me, is this the condition for stability or instability? This is the condition for stable equilibrium or unstable equilibrium. This is the condition for stable equilibrium or unstable equilibrium. Can you tell me that? This is the condition for stable equilibrium. So my dear, this is the controlling force diagram for stable equilibrium. But the point is, every time who will be making these three lines? So for that I am giving you a shortcut. When you are going to have a controlling force diagram, if you have a diagram like this, controlling force diagram is this. If you are given this curve or you are given this curve, how you will check it whether it is stable or not? This is how the question will be coming. They will give you some controlling force diagram. They will be asking you, is it for stable equilibrium, unstable equilibrium, neutral equilibrium? None of these. Cannot say. Data is less. How you will say? You will be plotting a line which is said to be speed line. You know, this is representing some speed and some angle. when you will be plotting this line, when you will be plotting this line is making some angle of phi. This is making some angle of phi. So you see that at this point of intersection, whether the controlling force is on the upper side or the speed line is on the upper side, whether the controlling force is upper or speed is upper, you can see controlling force is upper. Then upper means you need to go with some angle in anti-clockwise direction. So if controlling force is upper, this is stable. Here if you see the intersection point, the speed line is upper, you will say this as unstable. I can show you for this curve. If you have this curve, you can see this is C1, C2, C3. For this is R1, R2, R3. You can see R increases, speed decreases. R decreases, speed increases. This is the condition for unstable equilibrium. Is it clear for everyone or not? Please tell me that. Guys, do like and share the session. We are one less than the 50. Ardhashatak. Yes. Please tell me, guys, are you getting it or not? So, Sujeesh, you got it or not? Vineet, you got it or not? Ajay, Malesh, very good. Azruddin ji, understood or not? Please tell me that. Very good, guys. So now we will see the controlling force diagram for spring control governor. This was the question asked in GATE 22. For spring control governor, I remember it as parabola stable, exponent curve unstable. That is your choice how you want to remember. I told you the shortcut. So my dear, now we are talking about the spring control governor. For spring control governor, we are getting linear. Manas, I feel the question would be there from either isochronous governor or characteristic. Isochronous mein they can ask you what is the sensitivity of isochronous governor, what is stability of isochronous governor. This is one thing which can come. Second thing, they can go beyond in the controlling force diagram. They can ask from sensitivity, stability or their comparison. Third thing, the chances are numerical on Hartnell governor, where they can, Hartnell governor means controlling force diagram only, that they will ask you by giving some data that which type of governor it is. That kind of numerical, we have done it many times in the practice sessions also. So this will be like these types of equation only I am talking about. So when you see spring control governor, for them straight line is coming. Okay, generally we are getting this type of diagram for Watt governor, for Porter governor. We are getting, or Powell governor. We are getting this type of diagram for Powell governor. We are getting linear diagram for Hartnell governor. So if you have this, just make a speed line. For this case, speed line is above, so unstable. For this case, controlling force is above, so stable. And for this line, both are same, isochronous. Is it clear? This was the question in GATE 2022. Wonderful, guys. This was the GATE 22 question. Okay, this type of question I am saying that if they give you data that for this R1 force is this one, for this R2 force is this one, when they give this type of equation, then you will be assuming F is equals to AR plus B, and you will be finding out the value of A and B. When you will find out this, then you will get to know, then you will get to know, then you will get to know, then you will get to know that this AR plus B is for unstable, AR for isochronous, AR minus B for stable. That is where the questions can come. Yes, Manas. Moving further, guys. In rank up also, I have done it in the class also, in YouTube also. Not only rank up, I have done these types of, Rank up also I have added those questions. Okay, last year I added those questions. They were I may not have taken for your batch, but last year when those PPTs were made, they were added. But in YouTube also I have taken, in your course also I have taken. If you are from Vision batch or Vision Gate, so those questions were there in the classes as well. Great. Okay. So we are moving further. We are moving further, guys. Okay. These are the questions you can try. Like this type of questions are there. This type of questions are there. So you can see in a spring control governor, the balls are 300 mm and 400 mm apart. So it means R1 is 150. R2 is 200. Actually, these questions are from classroom PPTs only. Okay, that's why I am saying this we have done in the classes also. R1, R2. And you can see the force 1 is 200 Newton, 400 Newton. So you can find out the value of A and B. Manas, yaad aaya kuch ke nahi? We have done this in the classes. You are behaving like we have not done this question in class. You need to find out A and B. Yes, solve it then. Solve it. You need to find out the value of B here. B value is your answer. Solve this question. Vineet, first you give 23 paper. Then I will tell you for 24 also when you will start preparing. Right now, do not deviate from gate 23. This is a gate which is having a lot of opportunity. Try to grasp this time. Otherwise, gate happens every year, no doubt about that. This should be your attempt which will give you something. Okay, after that you have choice to go for any exam. There is no problem. But till 5th February, you should not think about any other thing. Okay, you are in second year still now. Okay, then I was not aware. Fine. Then it's fine. Definitely. So you talk to me on Telegram or WhatsApp. I will guide you for that. So the answer will be 400 Newton. Yes. Moving further, guys. Now you can remember two more formulas. I'm not writing the formulas. You need to remember two more formulas. One is power of governor. They are just formulas you need to remember. Second is effort of governor. If you will do this thing, then everything is fine. Moving further, guys. Now, whenever we are talking about gyroscope, yes. So, guys, we have done governors also. Now we are left with gyroscope, gears, and balancing. Okay. So before we go into gyroscope, I want to ask you here, do you need derivation or shall I directly give you the result? Because derivations are useless. Yes. Shall we go for derivation or directly results? In gyroscope, derivations are not required actually. Okay. Derivation Ashutosh is saying. Vineet sir actually अच्छा डिजाइन पूरा हो गया है except engineering mechanics. Okay, don't worry Vineet, I will try to take this time. I will tell you, don't worry. Okay, so I am telling you in this way. Ashutosh will also get it. Okay, let us start. First of all, we need to understand, my dear, the coordinate system we are going to use in the gyroscopes. In the gyroscopes, we are using this coordinate system. X, Y, Z. This direction is X. Okay. This direction inside is positive Y. Okay. This is X. Inside is positive Y. Okay. And this upward direction is Z. This is the three-dimensional coordinate system we are going to use. Okay. So these are the positive directions I have shown. X, Y, Z. So we are going to talk about that now. So my dear, first of all, we are talking about angular velocity. Let us say some disk is rotating like this. So whenever these kind of things happen, view plays a very, very important role. Because if you see something to be rotating in the clockwise sense of rotation from here, the same would be anti-clockwise from this view. So view plays a very important role. So for that purpose, we have defined some direction by using right hand thumb rule. Like if we say from this view something is rotating clockwise, I will rotate the fingers of my right hand here and thumb will give me the direction. And I will be saying this is the direction of omega. And direction of omega is also said to be what? Direction of omega is also said to be what? Direction of omega is said to be the axis of spin. Direction of omega is said to be the axis of spin. So direction of omega is said to be the axis of spin. And my dear, axis of spin is not depending upon the view. It is not depending upon the view. Whatever be the view, it will remain the same. Okay, that is the beauty. That's why we are generally using this. So my dear, now this direction of angular velocity, if this is going to move, this is going to rotate, this vector is going to rotate, that is said to be precision. That is said to be precision for what we are here. Angular acceleration. So my dear, just imagine that a ceiling fan is there. That ceiling fan is rotating like this. Wall fan, not ceiling fan, wall fan. Wall fan is rotating like this. So if I see that fan is rotating like this. This is the direction of omega. Then my dear, I am going to take the thread down. Then it will also start changing the direction like this. You have seen the wall fan which change the direction like this. So if already I have, this is the direction vector of omega, it is rotating. So now it would be moving in direction also like this. So such type of case is there. This is the fan which I am looking from this view. And when I am looking from this view, I know that from here it is clockwise. So this is the direction of omega. So initially this is the direction of omega. After some time the direction of omega will change. So my dear, initial omega is this, final omega is this. Why final omega is bigger? Because magnitude also changed. Previously it was running at a speed of 2, I have changed the speed to 3. So speed also increases, axis also change. So you can see this is the change of magnitude, this is the change of direction. So this will give you the change of magnitude, that is said to be alpha x. This is the acceleration in x direction. This is the acceleration in y direction. Why y direction? Because the motion is happening like this. So this is x, this is y. So this component is x, this is y. So this is alpha x, this is y. So when we are going to find out the alpha x with the derivation, we will be getting d omega by dt. This is responsible for change of magnitude. When you will find out omega y, it would be coming out to be omega d theta by dt. Here d theta is the angle turned by the axis of spin. And d theta by dt is said to be the omega p. So we would be saying alpha in the y direction as omega into omega p. Omega p is angular velocity of precision. This is alpha y. So there are two types of accelerations, but my dear, in our complete gyroscope chapter, we will assume that speed is constant, magnitude is constant. So alpha x is 0. So you would be saying the net vector angular acceleration is alpha y only, which is equals to omega p. So if you want to write down the torque required, it is coming out to be I omega omega p. I omega omega p is the torque required to give this rotation of d theta to the axis of rotation, axis of spin. So my dear, when you are going to rotate this axis of spin, when you are going to give the rotation to this fan, when you are going to turn your car, when you are going to turn your aircraft, your ship, your automobile, you are going to give some active torque. You are applying some torque for that. And that is said to be active torque. And when reaction is coming, it is said to be reactive torque. And the reaction which is coming, it is coming to the system, not to you. Because after taking the turn, you are leaving the system. Then the reaction is coming on to the system, which will be reducing the life of the system. That reaction is said to be gyroscopic couple, gyroscopic effect, or gyroscope. So generally gyroscope is an effect. Okay, so my dear, you have seen the magnitude. Now we are talking about the directions. Now we are talking about the direction. Like we are saying that in this view, I am talking about the direction. In this view, we say direction of rotation is clockwise. So in this view, if I see the clockwise rotation, I will say this is the direction of omega. This is going to be the axis of spin. Like this. Now my dear, you know that this rotated in this way. To check the direction, what is the simple principle? What you will see? You are saying this is going in this way. Always keep the tail end fix and see the rotation of head. It is going in this way. This is inside Y. So this is active torque. This is active torque. We cannot make inside, so we are making it in this way. This is your omega final. And this is your active torque. Reactive will be just opposite to this. So if this was active, this was reactive, sense of rotation would be this. So my dear, on this fan, this would be a gyroscopic couple which will be acting like that. Okay, this is how the gyroscopic couple will work. Please tell me, are you clear about the direction and magnitude? Ajruddin, Ashutosh, Vineet, Ajay, Malesh, Midun, please tell me you got it or not. The same would be applicable for ship, for aircraft, for power plant shaft, for automobile, for two-wheeler, for four-wheeler, for everything. Is it clear? And still when I will be coming with the practice session, I will take some cases, some questions of all the types. Aircraft, ship, power plant shaft and all. For aircraft, you know the front end is said to be nose, the rear end is said to be tail. Okay. If we are saying this is going in this direction, then this will be left turn, this will be right turn. When we are talking about left and right turn, it is the turn of the aircraft. Like aircraft is going like this. This is left turn, this is right turn. This is left turn, this is right turn. So initially you are looking from here, and by looking from here, engine rotation is clockwise. So you will say it is clockwise like this. We got the direction vector of omega like this. Now if he says that it is going to take left turn is going to be like this. You will take this, hold it properly. This is going in left. This is active, this is reactive. And this is the sense of rotation. This is active, this is reactive. So this is active. This is reactive. This is active, this is reactive, this is sense. So I will say nose will up, tail will down. Is it clear for everyone? Please tell me that. Can you tell some cases when gyroscope couple will act, when not? Ashutosh, I already told you. Gyroscope couple will act when the axis of spin is having the rotation. Okay. If axis of spin is not moving, then there is no gyroscopic couple. Like if you have a ship, this is a ship which is moving in this way, and this ship is going to roll like this. Then my dear, this vector is not going to change for this, because when it is rolling, this vector will remain like this only. It is neither going this way, nor this way, nor that way, nor that way. So for rolling of the ship, you will say there is no gyroscopic effect. Asutosh, you got it? Everybody got it? Please tell me that. So कोई बात नहीं, मैं pitching अभी बता रहा हूँ. But dear, if you are talking about the numerical point of view, that I know there is some doubt in some numerical sum of the student, that we will see in the practice session. But otherwise, direction point of view, I will tell you right now. Direction point of view, I will tell you right now. If we have this as omega, if the ship is going to have pitching, nose is going up, tail is going down, this is the case. So your omega vector is going like this. Active, reactive sense. Active, reactive sense. You know, right hand side is said to be starboard. So you will say the ship will have a tendency to go towards starboard. Actually, there are three things. There is one plane in which the motion is happening. There is another plane in which the precision is happening. And in the third plane, the gyroscope couple will work. I will show you that view also. You got it, Manas, what you asked? You got it, Manas, what you asked? This is the pitching. So if you have this omega, where it is going like this, this is active, this is reactive. Then it will be moving to starboard. Starboard is the right hand side. If this is omega, this is omega final. Active, reactive. Here it will be going to port. You know, right hand side is said to be starboard, left hand side is said to be port. Is it clear? Now, sometime this angle is defined. By what angle it is happening? So that kind of questions I will do for you guys. Manas, actually when pitching is happening, then if like I have written this is active and reactive. So sometimes they give this phi to tell you whether it is pitching in this way or that way. Because this is anti-clockwise, this is clockwise. So their anti-clockwise, clockwise means whether it is nose up, tail down, or nose down, tail up. So when they say anti-clockwise, means nose up, tail down. When they say clockwise, nose down, tail up. Got it, Manas? This is what I want to say. There are three planes. One is the plane of rotation, this blue one. Blue one is the plane of rotation. Blue one is the plane of rotation. Then second is the plane of force in which you are going to apply the force. Third one is the plane of precision. Actually, this is the rotation in 3 dimensions. One is the axis about which rotation is going on. Okay, other is the axis about which precision is going on. So, rotation is going on about X. Precision is going on about Z. Then gyroscopic effect will be coming about Y. So, you would be having the degree of freedom for a gyroscopic couple, for a gyroscope is 3. This is 3-dimensional rotation. Okay, I feel this is the case with gyroscope. Moving to the gears. Are we ready? Shall we start it, guys? Yes, as the number of topics increases, number of students reduces. Is it clear, guys? Shall we move on now? Yes. Guys, it is not easy to cover 80-hour subject in 8 hours. Very difficult. So that is why don't mind if 1 to 2 things are skipped, because everything what we go for that 80, 90, 100 hours of course of one subject. That is not feasible in 7-8 hours. Here we are going for a quick revision only, which will just recap the things to you. If you have any difficulty at some place, that would be rectified, and it would be easy for you to revise now from your notes, because it is a kind of recap. Have you seen when you were watching the serials, to start the next episode, they will give you a recap. 30 minutes episode, they were giving the recap in 30 seconds. The same is going on. That recap is just give you an idea how the things were discussed at that time. What was the show yesterday? Fine. SOM is very difficult again, because MD is fine, SOM is fine, TOM is very difficult. So let us talk about the gears. So my dear, you know that there are two types of drives we are going to say. One is, which are two types of drives? Positive drives and negative drives. My dear, here negative doesn't mean bad, positive doesn't mean good. Here negative means the drives in which friction is present, the drives in which slipping is present. The drive in which sliding is there. Shall I say sliding or slipping? How many of you understand that sliding and slipping are same or different? Let us check. Sliding or slipping, what do you say? In the negative drive, what is present? Yes, in the negative drive, what is present? Very good, guys. So first of all, slipping, not sliding. Sliding is present in both the drives. Slipping. So my dear, negative drive means the presence of slipping, and positive drive says slipping is not there, only sliding is there. So only sliding is there. What is the difference of sliding and slipping? My dear, sliding, when we are going to define, let us say my hand or my finger is touching the board. So there is a point of contact where my board and fingers are touching each other. So my dear, now this point of contact is getting signal from two people. One is me, other is smartboard. I am saying to be at rest, smartboard is saying to be at rest. Both are same signal, point is at rest. But if I give the signal to the finger to move, then my dear, this point of contact also have to move, because it is getting different signal from me and smartboard. And this is said to be the sliding. This is said to be the sliding. This is said to be the sliding. You can see that. So when signals coming are different from both the bodies, it is said to be the sliding. And my dear, this is sliding. Sliding in direction of power transmission. Sliding in direction of power transmission is said to be slipping. Sliding in the direction of power transmission is said to be slipping. Slip should not be there in the positive drives. So when slip is not there, then speed ratio is going to be constant. Omega 1 by omega 2 is equals to constant. That is the story for positive drives. Initially, to have a positive drive, we were having two cylindrical disc. If you see this point of contact, because it is present on the first body, omega 1 R1 will be equals to omega 2 R2. But this is possible only if sliding is not happening for this point in the direction perpendicular. Okay. So my dear, if you say omega 1 by omega 2, this time will be coming out to be R2 by R1. Radiuses can never be changed, so this ratio is constant. But without slipping, it was possible only at slower speed. As the speed increases, the sliding or slip came into picture. And if sliding is happening in this direction, it is said to be slip, because this is the direction of force and power transmission. So in gears, what is different? When we got higher speeds are giving us slipping, then we have made some new kind of configuration with this cylindrical disc. We attached the teeth which were following the law of gearing. Because of that, sliding was present, but slipping was absent. So only sliding in this direction is said to be the slipping. Sliding in some other direction is not slipping. So that is why we have made the gears Gears are the example of positive drives. Belt drive, rope drive, chain drive, these all are the example of negative drives. Positive drives are very, very costly as compared to negative drives. The manufacturing to material cost for positive drive is quite more as compared to negative drives. Now we are going for the classification of gears. The first classification is according to the arrangement of the axis of shaft. If both the axes are parallel. So both the axes are parallel means what? If we have one gear like this, other gear like this, both axes are parallel. Okay, so my dear, now how we can define it? The first classification can give you if teeth are parallel to the axis and straight, then this is the first type of gear given the name of simple spur gear. When, my dear, these types of gears were made, there were so much problems with those gears. What was the problem? These gears were having the impact loading going like this. One teeth was going on to the second teeth like this. And because of that kind of motion, my dear, what was happening actually? Impact loading was there. So stresses induced were of impact nature. So impact stresses was the biggest problem here. And my dear, there was a good point also, like whenever these gears are moving, one is applying force into the other. When one force was applying force onto the other, then there was no resultant force in the axial direction. And because there is no force in the axial direction, bearing life was superior. But bearing is a very cheap component. We want life for gear, not for bearing. Bearing also required, but not that much, because bearing is very cheap component as compared to gear. Gear are coming for 10,000 a smaller gear, 20,000 smaller gear, gearbox of thousands of rupees, lakhs of rupees. Okay, so my dear, that is why these gears were capable to be used at very slow speed application like reverse gear, first gear, or they were also replaced later on by helical gears. In the helical gears, what we have done, we have changed this impact to gradual, was changed to the gradual arrangement. Impact engagement was changed to the gradual engagement. Is it clear, guys, or not? Please tell me that. Now is it fine, guys? Okay. Wonderful, guys. Okay. So let me save this, whatever have been happened. So when we have talked about the helical gears, my dear, for that gradual engagement was there. So because of gradual engagement, they were used from medium to high speed applications. Okay, how the engagement goes gradual? We have made the teeth like this and this. So at one side we were having left hand helix, other side we were having right hand helix. So now gear teeth are coming in contact like this, point to point contact was there. So previously engagement was like this, now the engagement is like this. So it was impact, it was gradual. So when the engagement was changed from impact to gradual, this was the example for helical gears. And guys, now we are moving to the next. Third is double helical or herringbone gears. When we are talking about double helical or herringbone gears, actually in the helical gears, what was the problem? In the helical gears, forces were transmitting like this. So they were having a horizontal component, which was axial load, which was coming to bearing, affecting the bearing life. You may be saying, but sir, bearing is not very important component, you just said. Dear, I said yes. So because of that, only 99% of the application are done by, 98% of the application are done by helical gears. 1% are done by spur gears. But you know, whenever we get some good life, how we are going to move? Like, let us say you are going to a school where benches are not available. You are sitting onto some kind of, you can say, on the earth, like some tarts are there where you are sitting. So your first requirement would be that benches should be there. Then once you get benches, then you will demand for sofas or chairs. Yes or no? Initially there were no fans. You cannot directly ask for AC. First demand would be fans. Similarly, our first demand is the basic necessities. First we wanted the vehicle to run with gears. First we wanted to have the slow and medium speed application. Once both things were given, satisfied, then we thought to have some other requirement to be fulfilled, like high speed application. We want to see the races of cars, races of bikes. And when we have seen the races of cars and bikes, bearings were getting failed even sooner. And when bearings were failing sooner, then my dear, within a 20-kilometer race, if we need to stop the car to change the bearing, it is useless. So that is why we thought to reduce this axial loads. For that, what we have done, we have made the teeth on both sides, left hand helix, right hand helix. Okay, left hand helix, right hand helix, both. Because in that way, horizontal components of both the forces will balance each other. So that is why for racing cars and bikes, we are using double helical gear or herringbone gears. This was, you can say, improvement over helical gears. So 1% applications were covered by spur gear, 98% by helical gears, and 1% by herringbone or double helical gears. I feel you got it, guys. I feel you got it, guys. Moving further. Now bevel gears. My dear, when we are talking about the gears, bevel gears, if the axes are intersecting like this, then my dear, this is the generating line. We will rotate it like this. You will get these two gears. They are bevel gears. And if these bevel gears, when we are making, if both the gears are becoming similar, same size, then they are called as mitre gears, which are used in the governors to give the same speed to the governor shaft as that of engine speed. So this is the case of bevel gear. Bevel gear can also be of many types: helical bevel, double helical bevel, or zero bevel, or simple bevel. So likewise, you can see how they are having the motions. Okay. So helical bevel gears are giving the same kind of modification what helical gears are giving from the spur gears. Here engagement is becoming gradual. Okay. The same advantages. Okay. So my dear, now we will see about the mitre gear. When both the bevel gear are similar to each other, we are saying them mitre gear. They are rotating with the same speed. Now we are talking about if axes of both the shafts are neither intersecting nor parallel. In the spur gear, helical gear, they were parallel. Then they were intersecting. Now they are in different plane. Like one axis of the shaft is this, other axis of the shaft is this. They are in different planes. So when, my dear, they are in different planes, then my dear, when they are in different planes, then we are having two types of gear. One is said to be the spiral gear, and second is said to be worm and worm wheel. So when we are talking about the spiral gears, we are having a surface of hyperboloid. This is hyperboloid. On this hyperboloid, we are going to have the teeth which are curved teeth like this. They are having this type of connections. Two gears will be rotating like this. Okay? Yes. Moving further, guys. So this is the spiral gear. This is how the motion is going to happen. Now this is the pair of spiral gears. I feel you got it now. Curved teeth are there. Now we will see worm and worm wheel gear. This is the worm and worm wheel gear. So when we are talking about worm and worm wheel, you can see this is the worm. The axis of worm is this, and the axis of worm wheel is this. Here also curved teeth are there. So my dear, about this gear train, there are two very important points. First very important is worm can drive the worm wheel. Worm will be driver and worm wheel will be the driven. Always worm will be the driver and worm wheel will be the driven. Worm wheel cannot drive the worm, that is for sure. Only worm can drive the worm wheel. Worm wheel cannot drive the worm. So it is having self-locking characteristics. If worm wheel will try to rotate the worm, even if crane you are using with that, it will not be able to do that. The similar kind of things we are also having in the screw jack. You can lift the car cannot lift you. In the guitar, you are having some tuners, some tunes, some keys are there. By rotating them, you can tighten the wires of the guitar. But by just taking the wire off, extending or stretching the wire, you cannot rotate those keys. So motion can be transferred only in one direction. In the second direction, we have infinite coefficient of friction. Static friction is infinity at that time. So that is how we are getting achieved this self-locking characteristics, my dear. And second important thing is the speed ratio which we are getting here is very, very high. Minimum 10:1 is the maximum by other set of gears. After that we need to go for gear trains. But this is having a starting range of 40:1 and can go up to 1700:1 and even more than that. Even more than that. Very high speed ratios, which no other can give us. If this kind of connection is there, this is external gear. In external, if one is rotating clockwise, other is rotating anti-clockwise. Okay, second set of gear is internal gears. Whenever we are talking about the internal gears, this is the case. In internal, if this is rotating clockwise, this will also be rotating clockwise. So direction of rotations are going to be same. Okay. Yes, everybody, are you getting it or not, guys? This is the rack and pinion type. Okay. Here you can see the bigger gear is flat gear. It is having a radius of infinity. So this is how all the types of gears, can be shown. Okay, guys, moving further, we have seen the classifications. Gear terminology now we are talking about. I feel everybody is aware, this is very, very basic things. You know that whenever we are talking about the gear, this is said to be the top land of the gear. We are not going to talk about that much. Now, my dear, the biggest radius is said to be the addendum radius, addendum circle. This is said to be the dedendum circle. And you have a clearance circle also. Addendum, dedendum, clearance, everybody can see, but then we have a hypothetical circle known as pitch circle. Pitch circle is said to be a hypothetical because it is not the physical characteristic. You cannot see by looking at the gear, you cannot tell which is pitch circle. But it is that much important that everything is measured with respect to that. Means if you are going to find out addendum, it is measured with respect to pitch circle. If you want to find out dedendum, it is find out with the help of pitch circle. If you want to find out the gear teeth thickness, then also about this pitch circle thickness is said to be the teeth thickness. If you want to find out the space between the teeth, it is also found along the pitch circle. So all the dimensions are found to be with respect to the pitch circle. Addendum, dedendum, teeth thickness, teeth space, circular pitch. This is the circular pitch. Everything. You must be knowing tooth space is always more than tooth thickness, and that is said to be backlash. That is provided because in gears slip is absent, sliding is present. Because of sliding, heat will be there. Because of heat, thermal expansion will be there. If you will be keeping no backlash, teeth will get stuck into the space. Jamming will happen, motion will not happen. To avoid that, backlash is given. Very small is their backlash. So my dear, if you see, this part is said to be the face and this part is said to be the flank. Okay. So my dear, I feel we have seen all the things. I would like to say that there is something called as root circle. Root and dedendum are same. Root and dedendum are same. Base circle is not at all the terminology of gear. Never say base circle here. Base circle is not associated with gear. Base circle is associated with the involute profile. Always remember that. Is it clear for everyone? Please tell me that. So guys, just like and share the session. Like and share the session. So like in the classes, we are not going for the derivation. Don't worry. So within 15-20 minutes, this chapter will be over, and I feel by 5:15, we will be completing the subject. So we are talking about the pitch circles, my dear, now. So you know that whenever two mating gears are there, their pitch circles are always in contact. So if this is pitch circle 1, this is pitch circle 2, then where they are going to touch each other, that is said to be pitch point. And my dear, if you are going to join the center line of the pitch circles, and if you are going to make a common tangent at the pitch point, that is given the name of common tangent at P. This is the common tangent to both the pitch circles. But when we are going to have one gear teeth, like Ashutosh have asked in machine design also, when we have these two gears, okay, when we have two gears, then this is the point of contact between them. And when the force will be transferred, this gear will be rotating and it will be rotating to the other gears. This is how the force will be transmitted. So this line along which the force is acting is said to be the line of action. This line of action is nothing but the common normal to both the profiles. Common normal to both the gear profiles. So it is said to be common normal. This is common normal to the profile. Common normal to both the gears. Common normal to both the gears. This is common tangent to both the pitch circles. Generally people feel they are at an angle of 90 degree. No, common normal is normal to the profile. Common tangent is tangent to the pitch circle. So the angle between them is the pressure angle, phi. The angle between them is the pressure angle, that is phi. Okay, so we have seen in the analysis machine design, we have seen there are two forces, thrust Ft, tangential force and radial force, if you remember that. Okay, very good, very good. So guys, this angle is said to be the pressure angle. And my dear, you must be aware that whenever we are having the thing law of gearing, what law of gearing actually says? Law of gearing says that this line of action always passes through a fixed point that is said to be pitch point. And that pitch point is a point where three things are going to intersect. One is common tangent, other is common normal, other is the center line. This is the law of gearing. This is proved in the classes. Now we cannot do that derivation at all, which will be wastage of time. So my dear, now we are also defining something called a circular pitch. Circular pitch is given as pi d by t. Backlash we have already seen. Okay. Law of gearing we have already seen. Law of gearing says that the line of action always passes through a fixed point. That is said to be the pitch point. Okay. So we have seen this. So my dear, when we get to know, we can also find out the sliding velocity. Sliding velocity is given as omega 1 plus omega 2 into qp. Here q is the point of contact and p is the pitch point. All these derivations are done using the trigonometry. That is why derivations are not important for examination. Then my dear, we will move further. We are going to see what is involute profile. So my dear, first of all, we would be considering a fixed circle. We would be having a fixed circle. On this fixed circle, we would be having a pure rolling motion of a line. When we will give the pure rolling motion to this line, when we will give the pure rolling motion to this line, when we will give the pure rolling motion to this line, when we will give the pure rolling motion to this line, pure rolling motion to this line, then you can take locus of any point on this line. That locus is said to be involute. So there are two profiles in this entire universe given by mathematics which follows the law of gearing. The first profile is involute, which you have just seen. So guys, when you see this, what I said that actually, if you see, this fixed circle is given the name of base circle. So first thing is, when you are having this tangent, tangent is always outside the circle, it means involute profile will be always outside the base circle. First thing. Second thing is, the line which is tangent to the base circle is normal to the gear profile. So line of action was perpendicular to the profile. It is tangent to the base circle. Tangent to the base circle. Okay, mind this. This is a very, very important line. So my dear, when we are talking about cycloidal, it is just opposite. If we are fixing the line and give the pure rolling to the circle, then any point on the circle will be plotting the cycloidal profile. Okay, that we have also seen. Both are by nature conjugate, and these things we have done in the classes with the derivations, that whenever we are going to have base circles, any line which is line of action should be tangent to the base circle. And as for two gears, we will be having two base circles. So two base circles cannot have more than one tangent in common. So only one tangent is possible. That is why only one line of action. And as this line of action is there, so this angle phi is also going to be constant. So you know that when we are talking about a gear, you can see in any of the gear, point of contact will move at infinite locations. Point of contact will move like this. Everywhere point of contact will move. So when point of contact will be moving, obviously the line of action will be perpendicular to them only. But during that, gear is also rotating. So that is why if we are having one point of contact here, other point of contact will not lie on this curve, because at that time this curve would have moved to the next position. So because of that, the point of contact will also change. For the next instant, point of contact will also change. So that is why when we are going to make a line of action, the same line is including all the points of contact. And once it reaches to pitch point, so if this is the line of action, this line of action, everywhere point of contact is present on this. And on this only one point is P, which is said to be pitch point. So my dear, that is why whenever you are reaching to the pitch point, at this pitch point, Q and P become the same. Because of that, the velocity of sliding is 0 here. So this is the point where you will get pure rolling motion. Okay, you can see the point of contact is moving like this. So the point of contact is moving from this to this along a straight line. So that is said to be the path of contact. And during this motion of this point of contact, the rotation of any of the gear is said to be arc of contact. So all these things we have done with trigonometry and all. We have taken 10 hours to explain the gears in the classes. Here we are doing in 10 minutes because we are going for the formulas directly. So when we are going for the path of contact, everybody remember the path of contact formula? Path of contact is path of approach plus path of recess. If you remember how the formula will be, addendum circle radius ka square minus r square cos square phi or sin square phi. Is it correct? Here cos square phi or sin square phi minus Shreyas, Ajay, Vineet. Yes. Then you are going to have what? Plus RA square minus R square cos square phi minus R sin phi. This is the path of contact. This is the path of contact formula, guys. After getting the path of contact, if you forget whether cos or sin, always remember base circle radius is R sin, R cos phi. You can also feel it like addendum circle radius ka square minus base circle radius ka square. That would be easy to remember. Then we are having arc of approach to be path of approach by cos phi, path of recess by cos phi, path of contact by cos phi. Then we are going to have contact ratio. Contact ratio is defined as arc of contact by circular pitch. Okay, if you remember, contact ratio is coming out to be 1.21. It means 21% of times we were having two pairs in contact. Okay, that we have also seen in great detail. Now we are talking about interference. So my dear, when involute gears and cycloidal gears, when we are talking about, these are two profiles which follow the law of gearing. Okay, Ajay, what you want to say I didn't get? Are you talking about the formulas? Doesn't remember well? Please elaborate what you are saying. Okay, fine. Dear, for that you have to practice. When you will practice for some questions on the same formula, you will automatically remember that. But very less formulas are there and you need to revise them anyhow. Okay. So when we are talking about interference, if non-involute portion is going to connect with the involute portion, that will result into interference. And my dear, interference, if it is present, it will not allow the mating gear to be present for more time. They will fail soon. They will be having failure of teeth very soon. So if you don't want that kind of thing, for that we need to avoid interference. We cannot reduce it, we have to remove it. If even some interference is there, it will not be allowed to manufacture it. Gear is very costly device. We do not start manufacturing until we get a guarantee of no interference, zero interference. Zero tolerance policy is there for interference. And my dear, when we are having the interference, that is actually resulting in the undercutting. Because of that, what is going to happen if you have a gear like this? So what is going to happen? Actually, if base circle is coming like this, then this much part is non-involute. If you have another gears whose involute part is coming in touch to non-involute part, this will try to take the portion out, which is said to be undercut. So there are possibility of undercutting of gears due to interference. Possibility of undercutting because of interference of gears. Okay, only for these formulas, but dear, questions may come from that. Okay, so let's move further, guys. So my dear, I already told you law of gearing will not be satisfied, because of that interference will come. So my dear, we need to remove the interference. So the first way to do that is undercutting. We are having fear of undercutting if we are already doing the undercutting. So when we are going to make the gears like this, that we are removing the material, by ourselves, then other gear can come and will not be touching the gears. Then undercutting will be automatically done before starting of the mating of gears. So when you are doing this, this will definitely improve the results for you, because your undercutting will not impact that badly. But because of this, definitely here strength is getting reduced. And you would be knowing, when we have designed the gear, we got to know that because of this FT force, maximum moment was coming at this region. So this is the important region where you are removing the material. The strength of gear is getting reduced. So these undercut gears are the king of low speed power transmission, but for high speed we cannot use them. Second way to prevent the interference was to increase the pressure angle. When you are increasing the pressure angle, base circle radius was reducing. When base circle radius will be reducing, then definitely the chances of non-involute portion will also be to get reduced. But phi will also be having a range. We cannot reduce from 20 to 25 degree, because tangential force is the net force into cos phi. So if phi is more than 25 degree, the force will not be able to rotate the gears. Third is by stubbing of teeth. if you are going to reduce the addendum size of the gear, then also it will not be able to reach to in non-involute portion. This is a very good way to stop the interference stubbing of teeth. Okay, so when we are having increasing the number of teeth, this is the best way to do, because in this way everything is going to be good. In undercutting, strength reduces. In increasing of pressure angle, we have problems with one thing, that is what is going to happen, my dear. If phi is going to be more, tangential force will be less, gear will not be able to rotate. If we are going for stubbing, then also, my dear, when the stubbing will be happening, contact ratio is going to get reduced. That is the problem. But when we are going to have this increase in number of teeth, here, my dear, contact ratio is also increasing. Everything is positive here except cost, because when the number of teeth will be more, then the cost will be more. All other things is going to be positive here. Okay guys, we have seen all those things in great detail at that time. Right now we are just going for revision. Okay, and as I said, we can also go for the you also find out the minimum number of teeth. Minimum number of teeth for gear, minimum number of teeth for pinion. If you remember, it was 2 times AP. Remember that? 1 plus, yes, remember or not that formulas? Shall I write it or you remember that? 1 plus G into, remember or not? Yes. G is gear ratio. Everybody remember that, na? Very good, Ajay. बहुत बढ़िया. So, tell me guys, is it clear to everyone? Shall we move on now? Anybody tell me the formula? Let us see how many of you remember it. Let us see how many of you remember it. We are having in the slides. Don't worry. Where is that mist? Okay, solve this question. Then I will give you the formula. Very good. Plus 2 sine pi. One plus G plus 2 sine 2 phi. Okay, very good. Sine square phi. Very good. So you are saying that G plus 2 sine square phi minus 1. Are you saying that? Yes. Okay, fine. So this is for pinion. For gear, you will be replacing G by 1 by G. That is going to happen. It is clear, Malesh, now? Is it clear, Malesh? So now we are talking about this question. Solve this question. Solve this question, then we will move further. Solve this question. Very good, Ajay. बहुत बढ़िया. We are about to complete, don't worry. Okay. So magnitude of the force applied on the gear in the radial direction, FR. FR is FT tan phi. FT is 2T by MZ. We have not done the questions on that. Solve it. Solve it. Okay. Will you do that? Power is given, omega is given. So power is T into omega. You can directly find out torque from here. Solve it, guys. Anybody? बोलो भाई. Okay, number of teeths are not given. Sorry. So I feel data is not complete for this. Let me check. Okay, leave it, guys. I feel data is incomplete. So we are moving to the center distance also we have seen. So if you are talking about the second profile is cycloidal. For cycloidal, my dear, cycloidal gears are the best one because in them there is no interference. And when we are talking about these types of gears, they are having one part as convex, other part as concave, like this. They are this type of gears. Okay, they are the best type of gears. You can find FT. Acha, radius directly they have given, yaar. Then you can do that. Okay, now leave it. You will do that. It is there in the slide only. Now I am also teaching you from last 7 hours. So my brain is also working less. Okay. Because exam is of 3 hours and I'm continuously running it for 7 hours. So that's why I also forget that. Answer is correct. Ajruddin, C is correct. That's why I was saying that before the class I have done it and now I am facing difficulty in that. So I thought maybe some data is missing. Okay, C is correct. C is correct. Wonderful. So guys, can you tell me cycloidal is the best because there is no interference. Still we are not using them. What is the reason behind that? Still we are not using them. What is the reason behind that? Still we are not using them. What is the reason behind that? Yes, Sujish, Manas, Ajay, Malesh. Because the problem is whenever vibrations comes into picture, then in cycloidal gear center distance varies and omega 1 by omega 2 ratio is not remaining constant. So they are violating the definition of gears. So that is why, and in reality we cannot remove the vibrations from the system. Vibrations are always present because particular integral part of the force depth vibration system can never become zero. That is why vibrations are always present. So my dear, we can never have vibration zero. That is why cycloidal gears are not in the use. We are using only involute gear because involute gear can bear the vibrations. Now my dear, I would like to tell you the velocity ratio. Omega 1 by omega 2 or omega driver by omega driven or n driver by n driven. This is the speed ratio or velocity ratio. Then second thing is said to be the train value. Train value is defined as omega driven by driver. Okay, then we have gear ratio. Gear ratio is number of teeth in the gear by number of teeth in the pinions. It is always more than 1. Gear ratio is always more than 1. For others, we cannot say that kind of thing. So always remember this thing. I feel you are aware of that. You also know omega into R. Sorry, omega 1 by omega 2. for gears are equals to R2 by R1. You know that. You can also write it as omega 1 by omega 2, d2 by d1. R is radius, d is diameter. You know module of two gears are always equal. Module is d1 by t1. We have seen this in the machine design, d2 by t2. So when that is the case, we can write d2 by d1 as t2 by t1. So we can write here t2 by t1. So always remember, whenever you are writing the speed ratio, it is equals to the t2 by t1. Here t is the number of teeths. Very good, guys. So this is how we can have this formula to be used in the gear trains. Moving further, guys. Why we need gear train? If we need the speed ratio, more than 10, we cannot get it by the set of gears, we need the gear trains. This is the first reason why we need to go for the gear trains. This is the combination of gears. When we are talking about gear trains, if we have two gears, this is the set of gears. So if we are having more than two gears, it becomes gear train. In gear train, we can have first thing as driver gear, second thing as driven gear, third thing as idler. Idler is a gear which is neither driver nor driven. Idler is not a good word for that. Actually, I must write intermediate gear. I must write intermediate gears. Intermediate gears. Okay, and fourth one is arm or spider. So when we have these three things, the example is simple gear train, compound gear train, reverted gear train. And when we have these 1, 2 and 4, example is epicyclic gear train. And when we have all 1, 2, 3 and 4, then we call it as planetary gear train. Is it clear for everyone? Everybody is getting it? Please tell me that. So my dear, speed ratio and train value we have already defined. These are the four types of gear train we are going to see. The reason for gear train, first is high speed ratio. Second is we require it to cover large center distances. Third thing, gear trains are required for desired sense of rotation. Okay. Fourth thing, for multiple speed ratios. Everybody know the meaning of everything, multiple speed ratio. If you want, I can explain further. Is it clear for everyone? Please tell me that. Wonderful. So Teju is back. Okay. So guys, now we are moving further. So first of all, we will talk about the simple gear train. Yes, Shreyas. First of all, we are having the simple gear trains. If every gear is the single gear on the shaft and none of the shaft is having two gears or more than one gear, we call it as simple gear train. For such gear train, if you have 4 gears, you can directly write the speed ratio omega 1 by omega 4 as T4 by T1. Okay. And here these intermediate gears are not contributing to our speed ratio, so we will call them idler. Idler means of no use. They are not going to help in terms of speed ratio, but they are helping us to cover the center distance. They are also helping us for the giving sense of rotation. If you can see, there are two idlers. If this is clockwise, this is anti-clockwise. So you are getting this is clockwise, this is anti-clockwise. So if number of idlers is even, we will get opposite sense of rotation. If number of idlers are odd, we will get same sense of rotation for driver and driven gears. This is about simple gear trains. Is it fine, guys? Actually, I feel all the systems are tired now. All the systems are tired now. Only me and you guys are not tired. Okay. So I said if number of idlers are even, the sense of rotation is opposite. If number of idlers are odd, then they are same. Moving further. So we have already seen that. Moving further. Compound gear train. So my dear, yes. So when we are talking about compound gear train. So if, my dear, we have any one shaft which is having more than one gears like this, we will call it as a compound gear train. So my dear, for this case, how we will define it? Omega 1 by omega 6. Number of product of number of teeths of driven to the driver. You know here 1 is driver, 2 is driven, 3 is driver, 4 is driven, 5 is driver, 6 is driven. So we can write T2, T4, T6, T1, T3, T5. This time every gear is contributing to our speed ratio. So that is why none of them is idler. This time none of them is idler. Okay, this is the compound gear train. You can see the formula. Then my dear, this is the examples: automobile, gear system, lathe machine, clocks and watches, where we use it. Then reverted gear train. If we have the same axis for driver and driven, if driver and driven are coaxial, we are going for reverted gear train. It is a type of compound gear train. So 1 will transmit power to 2, 2 will transmit to 3, 3 will transmit to 4. So 1 is driver, 2 is driven, 3 is driver, 4 is driven. So we can write speed ratio omega 1 by omega 4, T2, T4, T1, T3. For such cases, sometimes they do not give you the number of teeths value. So you can also apply center distance. R1 plus R2 is R3 plus R4. By equal module, you will get T1 plus T2 is equals to T3 plus T4. So one of the number of teeth which are unknown, you can find out using this formula, because center distance is going to be same. I feel you got it. This is the reverted gear train. Okay. Can you find out this center distance? I taught you that in machine design also. Center distance between P and S, that you need to find out. 1 radius, 2nd radius, 3rd radius, 4th radius. So X is nothing but RP plus RQ plus RR plus RS. Tell me guys. Is it clear for everyone? Please tell me that. Some of you may be remembering the formula. Tell me the answer, guys. Tell me the answer. Yes. Teju, Ajay, Manas, Malesh, Sujish, Avinash. Anyone? You know that radius is mt by 2. Module of all the gears are not same. So MP TP by 2, MQ TQ by 2. Or you can directly use the geometry also. How you can use the geometry? It is mentioned that module of R is 2 mm. So module of R is 2 mm. And it is also mentioned the number of teeths. So module of R is 2. D of R by T of R. So D of R will be 30 mm. D of Q will be 60 mm. 60 or what? D of Q is double to that, 60 mm. From here you can find out module of P and Q. And then you can find out the answer like Manas have given. The answer will be 80 mm. So we got dr and dq. So we know drp and rq. Similarly, you can say s and r will have same module. You will find out rs. P and q have same module. You can find out rp and rq. The answer will be coming out to be 80 mm. Anybody have any doubt in this question? Please ask. अरे कुछ तो बोलो. Tell me. Ajay, Sujish, Malesh. Any doubt in this? No doubt, sir. Okay, moving further, guys. 80 mm is the answer. Moving to the epicyclic gear train. You know the degree of freedom for this is 2. Here we need to control 2 inputs. So you know that the axis of one gear is rotating about other. That is why it is epicyclic or planetary gear train. This is the extra element arm. Arm is something which is generally not present. If it is present, it is everything. It controls the motion of every gear and its rotations are added to every one. If you are going to see, this is one gear and this is another. Okay, this is how the arm can rotate. To solve a problem from epicyclic gear train, we have tabular method. For that, first of all, you will say arm rotation is 0. You will put the arm rotation is 0. Gear A is rotated by +1 revolution. Gear B will be rotated by how much? So this is gear A, this is gear B. You know that we can write omega A by omega B. NA by NB is minus TB by TA. So you can write NB to be minus TA by TB. Minus is for external gearing because direction will be opposite into NA. When NA is 1, it would be minus TA by TB. Similarly, when we are having 0 and X here, it would be minus X TA by TB. When we have Y rotation for arm, that would be added to every element. Okay. This is how we are going to see the total motion. So total motion will be this. Y will be added to every speed. Okay. Then out of these 3, 2 will be given, third would be asked. And from 2 inputs, 2 data, you can find out 2 unknowns which are X and Y. This is tabular method. This is tabular method. For planetary gear train also we can apply the same tabular method. In the planetary gear train, generally we are having multiple planets. Multiple planets are there for some purpose. One purpose of planetary gear train is the balancing. Like one centrifugal force will be going in this way, other in this way, other is this way. Why? Because these gears are rotating. So these forces will automatically balance. And if we have more than one planets, the load can be distributed to all 3. Okay, these are the 2 benefits. But for analysis purpose, we will say one sun gear, one planet and other ring gear. Sun and planet are having external gearing, then planet and ring is having internal gearing. Okay. No, analytical method is applicable for ring also. Who said not applicable? I have done many questions in the classes. Have not you revised that? Here how you will do? I am writing arm. I am writing sun, planet, ring. Everything is applicable. Who is saying not applicable? You can see one thing. Arm is having 0 rotation. Sun is +1. So it is minus TS by TP. It is minus TS by TR. Why? Because planet is idler. Whenever any gear is single intermediate gear is always idler. If we have more than one intermediate gear present on a shaft, then they cannot be idler. You know that. When arm is given 0 rotation, this is given +X. Teju, remember or not? Tabular method is always applicable. Who said it is not applicable? Then you can have +Y to this, +X plus Y, Y minus X TS by TP. y minus x ts by tr. The best thing is unknowns still are 2 only. So this time also they will give you 2 values. Third is 0. Fourth you need to find out. Okay, Teju, you are saying analytical. No, analytical is also valid. But analytical, when we are talking about is, we have to use it carefully. Okay, because analytical is used in such a way that arm should be there in between. If arm is there, analytical is applicable. Okay, so this is the tabular method. So we can have, like for analytical, if you're talking about, in analytical method, what you need to write, like if you have this and this is the arm, this is gear 1, gear 2. So you can write omega 1 minus omega arm, omega 2 minus omega arm, minus N2 minus T2 by T1. So you can apply this between any two gears, like this. Okay, so it is applicable. Wonderful. Okay, so like if you see any question of this type, like here if you see, you can apply between 1 and 2, you can apply between 3 and 4. How you will write? You will write omega 1 minus omega arm, omega 2 minus omega arm, minus T2 by T1, omega 3 minus omega arm, omega 4 minus omega arm, T4 by T3. You know omega 2 and omega 3 are same. When you will multiply both the equation, you will get the answer. I feel you will get the answer to be A for this case. Just you need to remember one thing. If you are using the ring gear, then you cannot put this minus sign, because ring gear is in internal gearing. Okay, dear, right now I don't have any such problem. As I said, marathons are not for questions, but for sure in the problem session I will take that. Okay, in the next week the CTQs we have. If you have time, please attempt it. If you don't have time, don't worry. You can go through the PDFs. If you see the question of your type, only go for that question. For that I need a particular statement and data, na? Yes, then only I can solve it. But otherwise you can apply that, but you need to take care of this minus sign only. Okay, that is the point. Otherwise, if you are talking about this planetary, any question like this, here you can use that. Like this is sun, this is planet. You can write omega sun minus omega arm, omega planet minus omega arm is equals to minus Tp by Ts. Use it. Who is stopping you from that? And then you will apply omega p minus omega arm, omega ring minus omega arm is equals to T ring by Tp. P for planet. Teju, is it clear? Use it. You can find out the answer. And when you will multiply both of them, then planet minus arm and planet minus arm will get cancelled out. Okay, fine. Okay, one thing more I would like to ask you. Which gear is idler? 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 So guys, you need to see first of all, driver is separated, driven is separated. These three are intermediate. Out of these three, fifth one is present alone. Akelapan, alone gear is going to be idler. Fifth will be the answer. Moving to the last topic, but before that I would also like to add one thing. When we are talking about the fixing torque, what is the meaning of fixing torque? Like in these questions, whenever you see they are saying something, they are saying that in epicyclic gear train shown in the figure, the ring gear is fixed. So when you are fixing some gear, it is having a tendency of motion. So that gear, when you are fixing it, so whenever you are fixing some gears, that would be requiring some fixing torque. So for that you always need to apply two equations. One is summation torque to be 0. Other is summation T into omega to be 0. Because you are having this system, nothing is coming inside, nothing is going outside. So here when you will be applying summation T into omega or summation T is equals to 0, using these two equations, you can apply the fixing torque. I will take one better example. If we are going to have one gear like this, other gear like this, we are having this arm, then you would be fixing the axis of one gear. Second gear axis will be rotating like this. So if they ask you the fixing torque, what you will say? T1 plus TF plus T2 will be 0. You will write it, the first equation. Okay. T1, TF, T2. Similarly, you will say summation T into omega to be 0. You will say T1 omega 1, T2 omega 2, T arm omega arm to be 0. Out of them, one gear is given to you as fixed. Then for that omega will be 0. And one torque will be given to you. Using these two equations, you can find out one unknown. I have done this type of questions many times, I feel so. Now it should not be a problem for you guys. But still I am announcing here a very important thing for you guys. I have seen all the times you guys are asking about this. So you will be getting a daily dose on the concept of fixing torque. And not only daily dose why I am saying, because I will explain it in detail for that, or I can go for it in the practice session also. Because the problem is with the questions, I know that, because that concept you have seen in the classes also. So we will be taking 2 to 3 questions on this, because this is something new which is not seen by you before. Okay. I promised you one more thing for the daily dose. What was that? Let us see how many of you remember that. I told you one more thing for the daily dose. Anybody remember it? Anybody? Manas, Malays, Teju, Sujish, Shreyas. What was that? Nobody remember? Okay. Don't worry. Then it would be a surprise for you. Okay. If you forget, then it would be a surprise for you. So now we are talking about the last topic, that is balancing. First of all, you must be knowing, can you tell me for which forces we need balancing? For which forces we need balancing? We need balancing for those forces which creates vibrations. The forces which creates vibration, we need to balance them. Which forces create vibrations? Whose magnitude or direction changes with the time. So my dear, we need to balance actually two types of components. One is rotating, other is reciprocating. So that is why there are two types of balancing: balancing of rotating components and balancing of reciprocating components. Balancing of rotating components and balancing of reciprocating components. Ajay, those forces for which we need balancing are said to be unbalanced force. That's true, but that is very childish thing to say unbalanced force. You must say fatigue forces. The forces whose magnitude or direction changes with time, we need to balance them. So they are present because of rotating components. For rotating components, direction is changing. For reciprocating components, magnitude is changing. Okay, so we need to talk about these two, reciprocating and rotating. Wonderful, guys. So when we are going to talk about that, there are two types of balancing. One is said to be static, other is said to be dynamic. We will see the important point directly. Static balancing is done for which? Static balancing is done for what? Static balancing is done for the masses in same plane. If all the masses are in same plane, we will go for the static balancing. And if all the masses are in different plane, if all the masses are in different planes, we will go for dynamic balancing. For static balancing, we need to balance the forces. Moments are self-balanced. Here we need to balance forces and moment both. Here we need a single balance mass. Here we need two balanced masses. Two balanced masses together balancing the forces and couples. Yes, it is not like one balanced mass will balance the force, other balanced mass will balance the couple. No, together they will balance force and moment. Okay. Then, my dear, you have the first case of static balancing, where all the masses are in the same plane. These are three masses, M1, M2 and M3. M1, M2 and M3. And they are present in a body like this. This is the body. One is this. Other is this. Okay, this is M3. We are assuming that some balance mass is attached. Okay. So if we are attaching the balance mass, this system now should be in equilibrium. So for static balancing, we need to balance the forces. So we will be going for the net force to be 0. So we can go for summation Fx to be 0, summation Fy to be 0. Why? Because summation F can be written as square root of summation Fx to be 0, square, plus summation Fy ka square. So it can be 0 only if they are individually 0. So we need to go for summation Fx and summation Fy separately, and in that way we can go for the static balancing. Moving further. So my dear, when we are going for static balancing, there is a formula also. You can say summation Fx, it would be nothing but M1 R1 omega square cos theta 1, M2 R2 omega square cos theta 2, M3 R3 omega square cos theta 3 plus MB RB cos theta b omega square. This is the summation Fx. You will be having summation Fy M1 R1 omega square cos theta 1. Cos will become sine. Everybody got it? Cos will become sine. Cos will become sine in the same way. Then you can write M1 R1 MB RB cos theta b minus summation MI RI cos theta I. I is varying from 1 to n. MB RB sin theta B minus summation 1 to n MI RI sin theta I. When you would be having these two equations, equations are 2, unknowns are 3. We are having the balance mass unknown, RB unknown, theta B unknown. So with the two equations, we can find out only two unknowns. So out of M and R, we can find out this product as one quantity. So if M is known to us, we can find out R. If R is known to us, we can find out M. But no method can give you both the values. One must be known to you. If one is known to you, second you can find out for sure. Okay, this is the analytical method. Okay, so guys, this is something analytical method. Everybody got it? Everybody got it? Please tell me that. Everybody got it? Wonderful. So guys, if you are going to divide them to get theta B, always remember when you will be dividing 2 by 1, then in the tangent theta B you will be getting summation I is equals to 1 to n MI RI sin theta I by MI RI cos theta I. This minus sign you will never cancel out, because they will change the quadrant of balance mass. Very good, Ramesh Mon. Is it clear for everyone? So always remember this thing. So on this, then we have dynamic balancing also. But dynamic balancing would be requiring the graphical method. Okay, which generally cannot be utilized in objective questions. But still, I will not say that leave this method. You can revise this very easily. So shall I skip here, because making force and moment polygons you are going to learn in engineering mechanics also. Okay, because those polygons making is not required for gate, but still I will say revise it once from the notes. That would be required. Okay, so I feel this is the case of rotating balancing. Now this is the reciprocating balancing. Now when we are talking about the reciprocating balancing, you know that, okay, you know that when we are talking about reciprocating balancing, in reality we have seen that the inertia force was coming out to be mr omega square cos theta plus cos to theta by n. And this force, when we are talking about, it was said to be in two parts, primary and secondary, where primary was defined as mr omega square cos theta and secondary as mr omega square cos to theta by n. So there are two forces. So my dear, to balance this, what was the story behind that? When we are talking about the balancing of these forces, my dear, you know, a method was given. We were having this to be crank. Okay, this is the connecting rod. You know that this is the piston. So we have assumed maybe there is a mass equals to the mass of piston. Maybe there is a mass equals to the mass of the piston which is present here. This is just a hypothetical thing. This is how they have start solving this. When Sir James Watt was having problem with this balancing because of this unbalanced force, his engine was not having a very good running life. So my dear, when he wanted to improve the running life, the suggestion was given to balance it. So what he have done, he have just felt like that maybe some mass mp is present on the crank, which is rotating at omega at an angle of theta. Because of that, here is some force coming out to be mr omega square, whose x component is mr omega square cos theta. So he said, if I want to balance this, I will be applying a balance mass just opposite to this, which will also be having mr omega square. This is the balance. I would be putting balance mass RB. It is not required to be at R only, but the point is product of M into R should be equals to MB into RB. So let us say they are equal like that. So its horizontal component will be balancing this. So it was good. It is going to be balanced, but the problem was this was assumption. this was a hypothetical mass, but this was a real mass for the balancing purpose. Because of that, my dear, horizontal component balanced, but vertical was not balanced. So vertical components, there is no vertical component in reality because this mass is not real. But here vertical component came, which was equals to mr omega square sine theta. So previously vibrations were coming this way, now the vibrations were coming in this way. So the point is vibrations were still present on the crankshaft and crankshaft was vibrating like this. So life was not improved by this. This is said to be the complete balancing, which was an attempt for complete balancing. Then some of his team members have given the suggestion for partial balancing. And when they went for the partial balancing, they have kept the balance mass into Rb as some C times of m into R. Because of that, this time some force in x direction was present as 1 minus C mr omega square cos theta, and some force present in y direction as C mr omega square sine theta. Now this C was lying between 0.5 to 0.75. The minimum value was 0.5 and optimum value was 0.75. So these two forces were present. The amplitude, the magnitude of vibration gets reduced. Because of that, running life was improved. So when this was done, no doubt a lot of uncomforts were coming. Sir James Watt was not happy with that, but still there was no other way to go because we wanted to balance actually. So using this, my dear, it was said that when this work was going on, the first locomotive of the history were made keeping complete rotating balancing and partial reciprocating balancing. And when they went for it, they have made the first locomotive that is said to be two-cylinder locomotive. If you remember, we have been there a very long story on two-cylinder locomotive when I gave you the feelings of Sir James Watt and team. Okay, we have seen all those things in great detail, but those things are not possible to have right now in the revision session. So you know there were a lot of problems came into picture. Remember or not those stories? How the name came as passenger, super fast and express locomotives. So when we have this two-cylinder locomotive, every cylinder, every wheel was having a cylinder. That was the two-cylinder locomotive. Okay, so when we have done that, and while doing that, they have taken the crank position to be at 90 degrees to each other for two-cylinder locomotive. So this was the case of two-cylinder locomotive, where this is cylinder 1, this is cylinder 2, which was at a distance of a by 2 and a by 2. Yes or no? And these are wheel 1 and wheel 2. Then because of this, a lot of uncomfort came. The effect of partial balancing was variation in tractive forces. So we got the variation in tractive forces. Tractive forces were plus minus root 2 times of 1 minus C into mr omega square. These were the variation of tractive forces. They were changing in magnitude and direction. Whereas we wanted the tractive forces to be 0. Because of tractive forces, the wheels were sliding onto the rails. We don't want that tractive force. This was not responsible for running of vehicle. Then we have seen the swaying couples values as plus minus 1 by root 2 into 1 minus C mr omega square into A. This is the variation of swaying couple. Because of this, your vehicle was having the snake movement. Swaying means snake movement. You would be remembering at that time I told you the story of going over to a river and everything. Okay, so those things are not required here because this is for the quick revision based on exam. So you know hammer blow is balance mass into B into omega square. This is said to be the value of hammer blow, and you have seen why it is said to be hammer blow because of this. Because of this, the contact of the wheel is getting away from the rails, and then once again it is coming again. So because of that, we are going to have that rails are feeling that hammer is blown again and again onto them. That is why it is said to be hammer blow. So I would like to say that we will stop here. because after that the line diagram, the forces, they cannot be done like this speed. For that you need to revise from the notes only. The vector diagram, force polygon, moment polygon, and also the diagrams of radial engines. Okay, so direct and reverse crank method, those kind of things, but they have never been asked in GATE. I will not suggest you to leave it, but those you have to revise. I feel we have done it in a nice manner. Hope you enjoyed the session also. I feel we are about to complete 8 hours today. Okay, is it clear for everyone? So tomorrow's timing for CTQ session, I will be telling you in the Telegram or WhatsApp group. If you have not joined yet, join my Telegram channel to get the PDF of this session. Okay, and I will be sharing this PDF which have questions also. You can try them. Okay, wonderful guys. So we are going to have other sessions like Marathon of Engineering Mechanics, where me, Abhinav sir and Sonu sir will come. Top 51 PYQs, where Abhinav sir and me will be taking. And there are many sessions will be there for XC paper also. We are keeping the mock test for XC also between mechanical paper and next week. Tomorrow in the morning we have 100 expected questions also, where the entire mechanical team would be coming up live from morning 10 a.m. and we will try to complete the session by 2 to 3 p.m. which if you want to practice question, you can join that as well. So goodbye guys for this session. Thanks for joining. Thanks for your love and support. Malesh, up to 3rd, 4th February they will continue, but attend only on your convenience. I will not suggest you to leave your revisions and all and come for every session. You need to go wisely. If you feel that session is helping you more than your revision, then only you join. Okay, otherwise we have done all the marathons now, so only go as per your requirement, because every student may need different. So we are having different type of session. Marathons are there, formula revision are there, practice are there, expected question are there. What is useful for you, that you have to identify. So goodbye guys for this session. Thanks for joining. Goodbye. Just like and share the session before leaving.